Hello, hello, hello. Hello everyone, how are you all? Welcome to this booster pack for JEE 2022 kids out there. I hope I'm audible and visible to all of you guys. Please do confirm, are we guys well connected or not? I want to see your Josh in the chat box. Shiva is here, Sher is here, a lot of guys, okay. So I have just come from a class, that's why a bit late over here, but I think we are all prepared for our upcoming JEE examination. What's the response over there in the chat box? What is going to happen in the examination? Can I see what the guys are feeling as of now? What the guys are feeling as of now? Can I see your responses in the chat box, everyone out there? Everyone, ek bari, before we begin this session, I would like to see some energy in the chat box, everyone. Yeah, 11th plus 12th. Okay, so today in this session we're gonna cover class 11th topics, and after that we're gonna take one more session for class 12th as well. So we're gonna cover all the relevant theory that is there in the chapter class 11th. Okay, I'll tell you all the formulas, all the concepts that you need to master at this last time, and also we will be covering a few previous year questions as well along with the session. All right, let's move into the session, kids. So we're gonna start first with sets, relations and functions. Definition of set is nothing but collection of well-defined objects. I hope you are aware of that. And there is a symbol which is this symbol epsilon, which means belongs to, and it is used to denote elements in a particular set. So if 1 is lying in set, we say 1 belongs to A. If 2 is lying in the set A, then we say that 2 belongs to set A. I hope you people are already aware of that. Roster form is there, set builder form is there. In roster form, we do write elements by separating them with a comma, whereas in set builder form, we use a property to write down the elements in a particular set. Can you guys write down this particular set in the chat box, everyone? What is going to be the answer if I say write down this particular set in roster form? Everyone out there, please do respond so that I can see the guys are there with me. Quickly tell me people, each and everyone, if I give you such kind of a set in set builder form, what is going to be the answer of this particular thing? I want to see the responses in the chat box, everyone. It is saying that x is a natural number and also less than equal to 5. That means x can be nothing but 1, 2, 3, 4 and 5. Okay. Usually in a set, elements are not repeated. It does not matter which element is written first, because order of the elements in a set is immaterial. That does not matter. Okay, I hope you people are already aware of this. Empty set is a set in which no element is there. If a set is having cardinality equal to 0, then we say that that particular set is nothing but empty set. Empty set is usually represented by curly brackets or phi, but not both. If I talk about this particular set, is it a null set, everyone? Is this particular thing that I have just written over here on the screen a null set or not? So let me tell you, this is not a null set, because anything written inside two curly brackets is nothing but an element. So over here, this phi will be considered as an element. So this set is nothing but a singleton set, because it is consisting of how many elements? It is consisting of one element. If I talk about this set also, then this is also not a null set, because 0 is an element of this particular set. So this is also having cardinality, that is number of elements equal to 1. So this is also a singleton set. I hope you guys are aware of all these things. Okay, so singleton set, as I have just told you, the set in which only one element is there is nothing but it is known as singleton set. Alright, cardinal number, as I just told you, the number of elements which are lying in a particular set is nothing but it's a cardinal number. Cardinal number is represented by this particular thing, n of that particular set A. If I give you a set like this, can you tell me the cardinality of this particular set is going to be nothing but equal to 3? Yes or no, everyone? Yes, sir. Okay. If I give you a set like this, let's say, you have to tell me the cardinality of this particular set. All right, how many of you guys are ready to answer this particular question? What is the cardinality of this particular set? Everyone in the chat box, I want to see your responses. देखता हूँ कितने सादा बच्चे. How many of you kids give me the correct answer? Over here, this is one element, this is one element, and this particular thing is considered as a single element. A lot of guys say the answer of this particular question as 4, but let me tell you people, this is having only 3 elements, because if something is starting, it has to end as well. So this particular thing will be considered as a single element only. So this is one element, this is second element, this is third element. So over here, the cardinality of this particular set is going to be how much? 3. Yes, very good, very good, very good. All right. Infinite set, a very tough definition. If a set is having infinite number of elements, it will be considered as an infinite set. Whereas if a set is having finite number of elements, that means the number of element can be counted. It will be considered as a finite set. If I talk about this, is it going to be a finite set or infinite set? Finite set, because the number of first 100 natural numbers are countable. If you talk about this, x belongs to an integer and greater than 2, then it is nothing but an infinite set, because integers greater than 2 are going to be 3, 4, 5, 6 and so on. Universal set is usually represented by u or mu. Whatever universal set will be having, universal set will be actually having everything. A lot of guys are confused whether universal set will be given to us in the problem or not. Every time the problem involves universal set, it will be given to you by the question. So you don't need to worry about that, okay? You don't need to worry about the universal set. The universal set will be given to you in the problems, okay? Talking about the definition of equal sets, if two sets are having exactly same elements, if two sets are having exactly same elements, those sets will be called as nothing but equal sets. If two sets are having same cardinality, two sets having same cardinality, or we can say same number of elements, same number of elements, not same elements, but same number of elements, then those particular set will be called as equivalent sets. Equivalent sets. Subset, I hope you people are aware of subset. It's a very, very, very important thing. Subset. A will be called as subset of B, will be called as subset of B if subset of B if whatever A holds, whatever A holds comes in B also, comes in B also. I hope you are aware of this definition and the meaning as well. Superset, if A is a subset of B, if A is a subset of B, then we can say that B is going to be nothing but, then B is going to be nothing but subset of superset of A only, then B is superset of A only. These are the few basic definitions I am writing down quickly, and then I'll give you a few examples as well. Disjoint sets are what kind of sets, kids? Disjoint sets are the sets in which there is no common element, or we can say that their intersection is nothing but a null set. Okay, if I give you a set like this, is B a subset of A? Yes or no, everyone tell me. Is B a subset of A? Whatever B is holding, is it also there in A? If yes, then we say that B is a subset of A. How do we write down that B is a subset of A? We write this particular thing like this: B is a subset of A. If B is a subset of A, then we say that A is nothing but superset of B only. A is nothing but superset of B only. I hope you guys are clear with this. What is the cardinality of set A over here? The cardinality of set A is 3. What is the cardinality of B? The cardinality of set B is nothing but 2. Okay, if I take a set C which is looking something like this, let's say Let's say it is looking like this. Okay, which of the following A, B and C, which of the following sets are going to be equivalent sets? Everyone tell me in the chat box, which of the following sets, C, A and B, out of these three, which sets are going to be equivalent sets? Equivalent sets do have same number of cardinality. So what you have to find out are the sets where cardinality is same. So as you can see, the cardinality of set over C over here is 3. So we can say that set C and set A have same cardinality, that is equal to 3. Therefore, A and C are going to be equivalent sets only. Okay, out of these three sets, can you tell me which of the following sets are disjoint sets, everyone? Which of the following sets are disjoint sets? Everyone, do let me know which of the following sets are disjoint sets. If the two sets are having nothing in common, then we say that those sets are nothing but disjoint sets. So which of the following sets are going to be disjoint sets over here? A and C are going to be disjoint sets because they do have nothing in common. Also, C and B are also having nothing in common. Therefore, we're gonna say that B and C are also disjoint sets. How many of you guys are clear with these particular things I have talked about so far? Everyone, do let me know in the chat box, because if the chat flows continuously, you can see tremendous energy coming from my side as well. And believe me, we're gonna complete class 11th today itself. We're gonna do PYQs as well, and we're gonna cover each and every concept of theory as well. It is my promise to you, but ultimately what I need from your side is that the chat must flow in an amazing manner. Yes, are you guys there with me? Do let me know in the chat box. I'm going to give you complete energy of mine, but what I need from you is the continuous energy in the chat box. All right, as I just told you, two sets will be equal if they have exactly same elements. The cardinality is same of two sets, then we're gonna say that those sets are equivalent sets. So over here, A and B sets are equivalent but not equal sets because the elements are not same, though their cardinality is same. Also, if you talk about these two sets, then these two sets are having same cardinality and also exactly same elements. Therefore, we say that these sets are equivalent as well as equal sets. Also, I told you earlier that in a set, order of the elements is immaterial. That means order of the elements does not matter. If one is coming earlier than 2, it does not matter what is the order. 1 is coming before 2, that's also fine. 2 is coming before 1, that's also fine. The two sets are considered to be same because they have same elements, exactly same elements. All right, moving on to the next thing, subset. As I just told you the definition, if whatever A is having, if B is also having those things, whatever A is having, if B is also having those same things, then we can say that A is nothing but a subset of B. Over here, you guys can see that whatever A is having, 1, 2 and 3, is B also holding those things? Yes. So we say that A is a subset of B. If A is a subset of B, then we say that B is nothing but a superset of A. Just say, if I give an example, if Arvind is father of Kavesh, Arvind is father of Kavesh, then this very same thing I can say like this as well, that Kavesh is son of Arvind. Isn't it, everyone? Exactly same thing happens with a subset and superset as well. If A is a subset of B, then we can say that B is a superset of A as well. I hope you guys are clear with this. There has to be no issue at all. So if B is a superset of A, how do we write down this particular thing? We write down this particular thing like this, okay? In whichever side the mouth is opening, we say that that is a bigger set. I hope you guys are clear with this particular thing. All right, let's talk about this. Which of the following are true and false? You have to tell me. X is such that ka symbol can be this or this as well. Both are same only. Both are same only. I hope I am audible, everyone. Yes, am I audible, everyone? Yes, exactly. Okay, this particular thing is a null set, x belonging to real number given to me. From here we do get two solutions, plus iota and minus iota. So definitely it is going to be a null set only. So this statement is true. Is this a null set? No, 0 will be considered as an element. X is the smallest natural number, is going to be a singleton set. Yes, because the set will be written like this, because the smallest natural number will be written like this. So it is true. Okay. Now, null set, is 0 an element of a null set? No, because null set contains nothing. So this is going to be false. Is this a singleton set? No. Why? Because 5 will be an element of this particular set. So rather, no. This thing is true. This thing is true because 5 will be considered as an element of the particular set. So this is a true statement because it is having one element in it. All right, so these are the answers. I hope, how many of you guys got 5 on 5 from here? Everyone, do let me know in the chat box. How many of you guys got 5 on 5? Do let me know in the chat box. I want to see your marks because these are very easy things and I want you to have a maximum out of these things, people. All right, talking about this, null set is going to be a subset of each and every other set. Okay, every set is a subset of universal set because whatever we are doing it in universe only. So any set is going to be a subset of universal set. Every set is a subset of itself, and also what kind of subset? It is going to be an improper subset. Every set is a subset of itself, and we do say that it is nothing but an improper subset. All right, I hope you guys are aware of this. Power set, a very important thing. Now, if a set is having n elements, what will be the number of subsets of A? If a set A is having n elements, how many number of subsets you guys can write down? How many subsets of A can be written? Do let me know in the chat box. 2 to the power n. If you now want to know how does this formula comes, then this comes because of permutation and combination. For each and every element you have two choices, whether to select it or to reject it, yes or no. So for every element you have two choices, and individually if you multiply 2 into 2 into 2 into 2 into 2 n times, because you have n elements, then what you get is nothing but the formula 2 to the power n. So if a set is having n elements in it, then number of subsets that can be written for that particular set is 2 to the power n. For example, if I say that a set is having 4 elements in it, how many subsets can be written? Then the answer is 2 to the power 4, that is equal to 16 subsets can be written. If I take all those subsets, and put it inside curly brackets, what do I get? Is nothing but a power set of A only. If I take all these subsets and put in two curly brackets, what do I get? Is nothing but power set of that particular set A only. So let's say power set of A will be represented like this. Number 1, if a set A is written like this, then what is the cardinality of set A over here? 3, sir. That means how many subset of this particular set A can be written? 2 to the power 3, that is equal to 8. Can I write down all those 8 subsets, people? A null set, 3 singleton sets, then sets having 2 elements in it, 1 2 2 3 3 1, and then the set itself. So these are the 8 subsets of A written. If I take two curly brackets and put these subsets inside two curly brackets, what do I get? Is nothing but power set of A only. I hope you people are clear with this. Okay, if I ask you an important question over here, what is the cardinality? What is the cardinality of power set of A if a set is having n elements in it? Do let me know, guys. What is the cardinality of power set of A if a set is having n elements in it? I want to see the responses in the chat box. It's a very important question. If a set is having n elements in it, if a set A is having n elements in it, what will be the cardinality of power set of A, people? Do let me know quickly. The more quickly you're gonna respond, the more energy you're gonna get from my side, and definitely I'm telling you guys, we're gonna cover each and everything from here. Yes, absolutely, 2 to the power n number of elements power of set of A will be holding, because number of subsets of A can be written as 2 to the power n in that case, and all those subsets will be acting as elements for the power set of A, and that's why the cardinality of power set of A has to be equal to nothing but 2 to the power n only. Now, talking about a few things, let me quickly take you into concepts. Let's say a set is having cardinality 2. What will be the cardinality of power set of A, people? Do let me know, people. Come on, come on, come on, come on, come on. So cardinality of power set of A means nothing but number of subsets of A only. So how many number of subsets A will be having? 2 to the power 2, that is equal to 4. Okay. What will be the cardinality of power set of A? How many of you guys will give me the correct answer? Let's see. What will be the cardinality of power set of A? Then it is going to be 2 to the power 4. That is equal to 16. What will be the cardinality of power set of A, people? It is going to be 2 to the power 16. Can you guys get this? Can you guys get this? Yes or no? Do let me know. Power sets. Yes or no? How many of you guys know this particular thing? Do let me know, people. This is a very, very, very important thing. All right, great to see this. Okay, so can we write down the power set for these particular things? Yes, obviously you guys can attempt it as part of homework. It is not at all difficult. Whatever I have told you so far, you can definitely apply over here and can get the answer. I have attached the solution for you people so that you guys can refer this particular thing, because it is going to be easier as I have taken examples on it already. Okay, so as I just told you, if a set is having n elements in it, 2 to the power n number of elements the set will be holding. If a set is having 4 elements in it, then number of subsets will be 2 to the power 4, that is equal to 16. Yes sir. Yes sir. Okay, talking about Venn diagrams, if I want to represent such kind of a thing in Venn diagram, then we can say that whatever A is holding, is it also there in the set B? That means which set is going to be A and which set is going to be B. If I want to represent such kind of a thing in Venn diagram, people, do let me know. The outer set is going to be B set and the inner set is going to be A set. Yes or no? Because A is a subset of B given to me. On the same logic, can you tell me about this? Which set is going to be A, which set is going to be B, which set is going to be C? If it is given to you that A is a superset of B, B is a superset of C, do let me know, people. The outermost set is going to be A, the blue one is going to be B, and the C one is going to be the green one. Are you guys clear with this particular thing on the Venn diagram? Do let me know, people. Very good. All right, union of two sets. I hope you are aware of this. Union in Venn diagram is represented by, if this is set A, if this is set B, then union means the region that I have shaded on the screen, people. Do let me know, are you guys aware of this? Yes, you must know. Union means write every value once. Union means write every value once. So if I want to take the union of these two things, then I have to write down every value once coming in these sets. Let's say I first write down 1, 2, 3, 4, that I have written. Now 3 I have already written, 4 I have already written. Now we need to write 9. So number of elements in A union B over here is nothing but equal to how much? 5, people. You must also know that the shaded region of A union B is going to be the one that I have represented over here. A union B is represented like this. By the way, how many of you guys know that A union B and B union A are going to be nothing but equal only? If you don't know, then you must know. All right, let's talk about a few more properties over here. A union B will always be equal to B union A. Also, if you take union of the set with itself, then it is going to be that particular set only. Okay, talking about the third one, A union B union C, the order does not matter. If 2 times union is coming over here, then we can either take B union C first and then take union with A, or we first take union of A and B and then take union with C. It does not matter. That is going to be same only. If we take union of any set A with a universal set, then the answer is going to be universal set. How many of you guys can feel this? Also, if you take A's union with null set, then the answer is going to be this particular thing, set A only. If A is a subset of B, then answer of A union B is going to be B only. Any confusion of all these, out of all these properties, do let me know, people. Any confusion of whatsoever kind in these properties, do let me know. The sixth one, this is a relatively important one, because if A is a subset of B, that means if B is holding like this and A has to be like this, so if you take union of all this and you shade the regions, ultimately don't you think that you're gonna get the entire region of B set? Yes or no, people? Alright, intersection of sets, let's talk about that. Intersection, if this is set A and this is set B, then intersection means common. Intersection means common. It is represented like this, A intersection B. Okay, intersection means common. If I want to write down intersection of these two sets, then it is going to be nothing but 3 and 4, because these are the two things which are common in both sets A and B. Also, how many of you guys know that A intersection B and B intersection A is going to be same only? Yes, they are going to be equal sets because they do hold exactly same elements. Talking about this, A intersection B and B intersection A are both same. A intersection A, if you take intersection of a set with itself only, then you're gonna get set A only. Also here, if you are having both the sides intersections only, then it does not matter whether you take the intersection of B and C first or you take the intersection of A and B first. Ultimately the things are going to be same only. What is common in a universal set and set A? If let's say this is my universal set and I am talking about a set A, then A set is like this. What is common in these two sets? Only set A, that's why this is going to be the answer. What is common in a set A and a null set? Nothing is common, because null set does not contain anything. Null set does not contain anything. Okay, if A is a subset of B, then B will be drawn like this and A will be drawn like this. What is common in these two sets? I think set A, so A intersection B will be coming out to be nothing but set A only. Are we guys clear with this? Anyone is having any confusion? What are disjoint sets? As I already told you, if two sets A and B are there and they have nothing in common, that means A intersection B is coming out to be a null set, then we say that those sets are nothing but disjoint sets. Difference of sets, a very important thing where I have observed that people do make mistake. So let's clarify that. If you listen my words carefully, then I'm telling you that there is going to be no confusion at all. So listen to me carefully. If A set is given to you like this and B set is given to you like this, and you need to find out A minus B, what you should do is remove those things from A, which are also coming in B, So if you want to do A minus B, then you need to remove those things which are also coming in B. So let's check it out. Can we remove 1? No, because 1 is not coming in B. Can we remove 2? Yes, because 2 is coming in B also. Can we remove 3? Yes, because 3 is coming in B also. Can we remove 4? No, 4 is not coming in B. So what is going to be the answer of A minus B? It is going to be nothing but 1, 4 only. I hope you guys are clear with this. Okay, talking about the next thing, if I want to do B minus A, then B minus A on the same pattern is going to be what, kids? B minus A is going to be remove those things from B, which are also in A, So can we remove 2? Yes, 2 is coming in B. Okay, can we remove 3? Yes, 3 is also coming in A. Can we remove 7? No. So ultimately B minus A is going to be 7 only. I hope you guys are clear with this. So we can make an observation over here that A minus B and B minus A, these are different things. Yes or no, people? These are different things. So A minus B is not equal to B minus A. Now if you look at the definition of A minus B, I told you remove those things from A which are also lying in B. That means if you want to do A minus B, you take this complete circle A and remove the portion which is also coming in B. That means you remove this particular portion. So from A, if you remove this particular portion, don't you think that A minus B is going to look something like this? And similarly, B minus A, if I tell you to plot, then this is B, and you have to remove the things from here which are also coming in A. That means you need to remove this particular region. So from B, if you remove this particular region, don't you think that you are going to get this particular thing as your B minus A? I hope we guys are clear with this particular thing. Also, if you see over here, one very important thing, that A minus B is nothing but only A. Observe over here. And B minus A over here is nothing but only B, or B alone. or B alone. Over here we can also say A alone. I hope you guys are clear with this. Yes or no? Yes or no, people? Do let me know. Yes, sir. All right, talking about this, if you talk about this A minus A, don't you think that whatever you need to remove those things from A which are also coming in A? Means you need to remove everything, yes or no? So is it going to be a null set or not, people? Yes, sir. Remove those things from A which are also coming in null set. Null set does not contain anything. That means you don't need to remove anything. That's why complete set A will be there. Okay, remove those things from A which is also coming in universe. By the way, universe is holding each and everything. So that means you need to remove everything from A. Yes or no? So null set will come. If you talk about this, then also you can see it through Venn diagrams. For this, you need to draw the Venn diagram for 3 sets. Venn diagram for 3 sets is required. I'll talk about that in the upcoming lecture. No need to worry about that, because over here 3 sets are there. I'll talk about this as well. Okay, complement of a set. If I'm talking about A complement, means I'm talking about everything apart from A. Everything apart from A. That means what? A complement is nothing but you need to remove A from the universal set. Yes or no, everyone? If A set is given to me like this, 1, 2, 3, and if universal set is given to me like this, 1, 2, 3, 4, 5, then what is going to be A complement? Remove everything from, remove whatever A is having from the universal set, or we can say apart from 1, 2, 3, whatever is left out in the universal set. So it is going to be nothing but 4 and 5. So your A complement is going to be nothing but 4 and 5 only. Okay, what is the union of A and A complement? Can you guys tell me one thing before I go on to this? What will be the things common in A and A complement? Nothing, isn't it? Because if I talk about a universal set like this, and if this is my set A, then this has to be set A. The outermost region, the outer region is going to be nothing but A complement. So what is the common thing between A complement and A? Nothing. That's why this has to be nothing but a null set. What is the union of these two things? The entire universal set, isn't it? So this has to be your answer. Talking about this, what is the complement of universal set? The complement of universal set is nothing but null set. Feel about this. What is left out apart from the universe? Nothing there. So universal set's complement is going to be nothing but a null set. What is the complement of null set? Everything. So it is going to be a universal set. Now talking about A minus A complement, you need to remove those things from A which are also coming in A complement. Do you really need to remove anything? Because these two things have nothing in common. So ultimately answer has to be A only. Also, if you talk about A complement minus A, then you need to remove those things from A complement which are also lying in A. These two things have nothing in common. So ultimately it has to be nothing but A complement only. How many of you guys are clear till here? Do let me know. How many of you guys are clear till here? Do let me know, everyone. I want to see your responses in the chat box. Quickly tell me, because we have so many things to cover. I am full of energy, but are we guys clear till this particular thing or not? If you are confused about De Morgan laws, then let me tell you a simple trick to remember these two. Morgan is a very good player of England cricket team. What happens is, if I want to write down these two things, then De Morgan law will be applied. Number one, what Ian Morgan does is, he gives compliments to the bowlers. Let's say here are two bowlers, A and B. So he gives compliment to the bowlers, A compliment, B compliment. Here also he gives compliment to the bowlers that you are very good bowlers. And then what he does, he hit them so hard that their line length changes. Means this intersection sign is going to become universal. That means line length changes. And here also the universal side will, the union sign will get converted to intersection, so that we can say line length is getting changed. So I hope you guys are clear with these two formulas as well. There has to be no difficulty at all. Yes. Okay, quickly moving on to the next thing, symmetric difference. This is the symbol for symmetric difference, A delta B. Now A delta B is nothing but A minus B union B minus A. I have told you that this thing is nothing but only A or A alone. This thing is nothing but only B, that is B alone. So A delta B is going to be this shaded region in the diagram or not. Everyone do let me know. We have talked about this. This is nothing but A minus B and this is nothing but B minus A. So if we have to take union of these two, that means we have to take these two regions. So that is nothing but our A delta B, people. Okay, do solve this question because this question contains everything that we have just learnt, people. Yes, come on kids, let's solve this question up. Now there will be a lot of guys who will get confused if I give them an equation like this. Whenever an inequality involving modulus is there, whenever an inequality having modulus in it is there, how to solve it? A lot of guys do remember formulas, but let me tell you people, you don't even need to remember formulas. You can simply solve the question if you follow my logic. Whatever is this mod x, you can consider this mod x as nothing but distance from 0. You can consider this mod x as nothing but distance from 0. So over here you guys can imagine that it is written that distance from 0 should be less than 2. So what you do is you stand over here at 0 and ultimately you have to travel distance less than 2. Yes or no? Ultimately the distance that you have to travel from 0 should be less than 2. So if you walk in this direction, you can move till 2 so that your distance is less than 2. Okay, by the way, distance is always positive. If you move along the left hand side, then you can move till minus 2. Yes or no? So ultimately where you can walk from minus 2 to 2. So that is going to be nothing but your values of x. I hope you people are clear with this particular thing. What is going to be the solution of this particular thing is x belonging to minus 2 to 2. Anyone is having any sort of confusion in this, feel free to reach out to me. If I give you a problem like this, can you guys now tell me the answer orally? Ultimately the distance from 0 that you have to travel has to be greater than or equal to 3. If you are traveling in the positive x-axis, then you can go at 3 and far than 3, that is 3 to infinity. Over here equality is also there, that's why I am putting equality at 3 as well. Okay, and if you walk onto the left of 0, then you can travel till minus infinity but from minus 3. So this is going to be your answer. Yes or no? How many of you guys are clear with this particular logic? Do let me know, people. Yes, these are very basic things you must know. Also, you can get an inequality like this as well. Let's say this is, I give you something and you have to tell me your x goes from where to where. So ultimately the distance from 0 that you have to travel should be between 2 to 4. If you are moving on to the positive x-axis, you can travel here to here. If you are moving on the negative integers, then you can go from minus 2 to 2. Put a union between these two, your x can go from here to here. I hope we guys are clear with all these things. Anyone is having any sort of confusion in this? There should not be any. Okay, so let's talk about this question, kids. I want you guys to solve this question. And also, whenever, if anything bad is written inside the modulus, you can consider it as t. So ultimately, if you put x minus 2 equal to t in the problem is going to be this. And we have just seen how to write down the solution of this particular thing. It is going to be minus infinity to minus 3. That means t has to be lesser than or equal to minus 3, or t has to be greater than or equal to 3. T was nothing but x minus 2. So you can put it over here and you can directly get the answer. From here x has to be greater than or equal to 5. From here x has to be equal to less than equal to minus 1. Yes or no? From here we have just seen that x belongs to minus 2 to 2. From here we have just seen that x belongs to minus infinity to minus 1 union 5 to infinity. You need to find out a minus b, b minus a union b, and a intersection b, people. What is going to be the correct answer? Do let me know. A, B, C, D. What is going to be the correct answer? Do let me know, people. Come on. What is going to be the correct answer? This question you have to solve it, and I'm really looking forward for your responses, people. A, B, C, D. What is going to be the correct answer? A minus b, if you do, then a minus b is going to be what? A minus b is going to be what? A minus b is going to be what? You have to tell me, people. Come on. A minus b is going to be minus 1 till 2. minus 1 till 2. Yes or no? Try to do this. B minus A is going to be what? B minus A is going to be what? B minus A is going to be what? Minus B minus A is going to be what? Minus infinity to minus 2 union 5 to infinity. Union 5 to infinity. Or this very same thing can also be written as B minus A is equal to all real numbers excluding minus 2 to 5. That means B for Bombay has to be the correct answer. How many of you guys got the answer? Oh ho 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 ho. You guys have fundamentally mistakes. No problem. I will try to explain this question to you guys. B is the correct answer, by the way, kids, because over here 2 will not come and also minus 1 will not come. Because look, minus 1 is included over here and here as well. Yes or no? That means if I am doing A minus B, I need to remove minus 1 as well. And over here A minus B is having minus 1 in it. How can this be my answer? So that's why I rejected. Talking about this, if you see, then minus 2 is not included over here and minus 2 is included over here. So if you do B minus A, then minus 2 has to be there in your answer. This answer is having minus 2 in it because ultimately from real numbers, you are removing all the values between minus 2 to 5, but not minus 2 and 5. Also, this set is having 5 in it and this set is not having 5 in it. So you don't need to remove 5 from in order to get B minus A. So B minus A must have 5. This is also having 5. That's why this will be your correct answer. By the way, if you talk about A union B, then A union B is going to be how much? A union B is going to be minus infinity to minus 1. Okay, it will go minus infinity to 2. It will go minus infinity to 2, minus infinity to 2. Okay, union 5 to infinity. This is going to be the answer, beta, of A union B. So are these two things the same? Are these two things the same? No, because you can write down this very same thing also like this. All real numbers excluding 2 to 5 open. Over here at 2 closed bracket will come. That's why this cannot be your answer. If you talk about the common values between these two things, then the common values are going to be what? Minus 1 is common. Look closely. Minus 1 is common in both these sets. Minus 1 is common in these two sets. So A intersection B is going to be minus 2, but minus 1 is common in both the sets. So this cannot be your answer. I hope you understood that the correct answer is going to be D for Delhi. Yes or sorry, B for Bombay. Yep. Yeah, it's a very, very, very beautiful problem. It's a very important problem as it covers almost all the concepts that we have just learnt, people. Yes, anyone is having still any confusion, do let me know, people. I can explain it on a number line as well, but I think if you are about to write down your JEE examination, then you must think these kind of things in your mind pretty comfortably. Also, I would like to give you one very, very, very important tip for your JEE examination, which nobody is going to give you, and that is think more, write less rule. How many of you guys know about this rule? Think more, write less rule. How many of you people are aware of this? If you want to score good in your examination, then you have to follow this particular rule, people, because I have seen over the years, I have seen so many kids coming to me at the last time and they say, sir, I'm not able to score much. But right from the first day, they do not follow this particular rule. It's a very, 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 very important rule, people. Look, in order to, if you write down anything, definitely it takes more time as compared to the time you allot so that you can think the question or how to solve the question, right? So if you see why you are scoring less and why other kids are scoring more, or why the toppers are there and you are scoring less as compared to toppers, then you need to see your rough work, because the thing lies there. If you see your rough work and the topper's rough work, you will find that if you are, let's say, using 10 pages for the rough work in an examination, the topper will only be using 2 or 3 pages only. 2 or 3 pages only. You have to write down minimal things, people. You have to write down minimal things. I have tried sharing this art with you people in whatever crash courses I have taken. This is a very important art. a lot of time what happens, kid attempts only the question paper of let's say 150 marks. Let me tell you one thing beta, if you are attempting 150 marks question paper, then you're gonna get only around 110 marks only. If you want to improvise, if you want to increase your marks in the examination, then first thing is you have to improve your number of questions attempted. So one thing is definitely you're gonna prepare at your home for that. Also you're gonna do time bounded manner के अंदर practice. Time bounded manner के अंदर practice is a very important thing. Ultimately you will be given only 2 minutes 30 seconds. 2 minutes 30 seconds for each and every question in the examination hall. So you have to practice that art, and also you have to follow this very important rule if you want to score good in the examination, kids. So do follow this advice very sincerely. Alright, I'll talk about this question now. How many of you guys can solve this particular question? Do let me know, people. Yeah, find the values of x. Find the values of x. Do let me know, people. Also do solve this particular question. Also do solve this particular question, people. Solve for x. Solve for x. Can you guys solve these kind of questions? I have seen that kids do get uncomfortable when modulus comes into the picture, when greatest integer comes into the picture. But believe me guys, these are very fundamental topics and very favorite topics of JEE Wallahs. Okay, so you must master these kind of questions, as these are very basic and very important as well. Okay. Yep. So whatever bad is coming inside the modulus, you take it as t. So put greatest integer of x equal to t. The question becomes mod of t greater than equal to 2, and as I just told you on the previous page, for that case t will be either less than or equal to -2, or t will be greater than or equal to 2. Yes or no? Now t is nothing but greatest integer of x. So greatest integer of x will be less than or equal to -2, or greatest integer of x will be this particular thing. Now greatest integer is always an integer. Yes or no? So from here what do we understand is greatest integer of x can be -2, greatest integer of x can be -1, greatest integer of x can be 0, and so on. So if you write down the solution of this, it is going to be x belonging to -2 to -1 open. The solution of this is going to be x belonging to -1 to 0 open. The solution of this is going to be closed 0 to open 1, and so on. And if you take union of all these things, ultimately the solution of this equation is coming out to be what? The solution of this equation, okay, sorry, it is going to be -3. I have made a mistake over here. It is going to be -3. Yes, because greatest integer of x is always going to be an integer only. Yes or no, people? Yes. So greatest integer of x equal to -2 is possible. Greatest integer of x equal to -3 is possible. Greatest integer of x equal to -4 is possible, and so on. So if you solve this equation now, from here you're gonna get -2 till -1 open. Over here you get -3, -2 open. Over here if you see, it is going to be -4, -3 open, and so on. So taking union of all these things, you're going to get the answer of this particular inequality, and it is going to be what? -infinity till -1, people. It's a very important thing where fundamentally people do make mistake. Talking about this particular expression, so greatest integer of x can be 2, greatest integer of x can be 3, greatest integer of x can be 4, and so on. Combining all those, you will get your answer. So ultimately it is going to be x greater than or equal to 2 only. So the answer of this particular problem is going to be this union this. That is -infinity to -1 union 2 to infinity. How many of you guys got the correct answer? Do let me know, people, as this is very basic thing that you have to follow. If you follow the tricks that I am giving you, I am telling you that you will be able to solve each and every question for sure. Okay, chalo. Talking about this, here whatever is coming inside the greatest integer thing, we're gonna take it as t. So the greatest integer of t is nothing but greater than or equal to 2. So from here you can say that t has to be greater than or equal to 2, as I have just solved over there. The greatest integer of anything greater than or equal to 2 means that anything has to be greater than or equal to 2 only. Now talking about this mod x being greater than or equal to 2, the solution of this, as I told you on the previous page, you have to ultimately travel distance from 0 greater than or equal to 2. That means means you can move beyond 2 and beyond minus 2. That means x belonging to minus infinity to minus 2 union 2 to infinity. Anyone is having any confusion in these two questions, please do reach out to me in the chat box. If you will attend this session right from the beginning, I am telling you, you will be able to understand each and everything. But if you come in the middle and go, there will be a lot of things which you will not be able to understand, people. So don't do that. It's my sincere request. If you are following it, follow it religiously, because I have used over here what? I have used what I have taught over here. I have used on this particular slide. So if you do not master what I have taught earlier, then there will be difficulty in order to follow what I am saying over here. So do follow the session completely if you want to improvise your score in the examination. Okay, what is going to be the answer of this particular question? Do let me know. Before that, I'll give you a quick tip over here that whenever you see f of x and f of 1 by x coming in a same question, whenever you see, it's a JEE Mains 2016 question, whenever you see f of x and f of 1 by x coming in the same question, you call this as equation number 1, and in place of x, you replace 1 by x so that you get the equation 2. So the equation 2 looks something like this. Let's call this as equation number 2. Now from these two equations, what you do is you get the value of f of x. So solve 1 and 2 to get the f of x, people. Solve 1 and 2 to get f of x. F of x. Again, I am telling you, whenever you see an equation coming in f of x and f of 1 by x, you call that particular equation as equation 1 and replace x by 1 by x to get another equation. The equation will look something like this. Call it as equation 2 and solve these two equations to get the value of f of x. This thing will happen always. Okay, now getting the value of f of x, how much it is going to be? Do let me know, people. We need to multiply this by 2. If you multiply this by 2, now think in mind itself, because the more you're going to write in the examination hall, the more time it is going to take. Okay, so also carry pencil with you if possible, because pen and pencil, if you work together with that, a lot of things which are needed to be written will be eliminated. Okay, so let's say you have written this with pencil, then if you multiply this with 2, so that if you subtract these two equations, f of 1 by x will be eliminated. Write this particular thing with a pen if you have written the earlier things with a pencil. Okay, over here 4 will come and over here 6 will come. Now if you subtract these two, on the left hand side you're going to get 3 of f of x, and on the right hand side you're going to get 3 times x minus 2 by x. Yes or no, people? So 3 and 3 can be cancelled out. F of x ka value you have just got. Now the question is saying, for what values of x, f of x and f of minus x will be equal. So if this is your f of x, your f of minus x is going to be what? You just need to replace x by minus x so that you get f of minus x. Solving these two equations, you get 2x equals to 4 by x. That means x square equals to 2. That means x equal to plus minus root 2. And over here, it is given to you that x can be any real number. So how many values you are getting, kids? You are getting exactly 2 elements. So the answer is going to be C for Calcutta. I hope you guys are clear with this particular question. Moving on to the next problem, kids. Here we go. I hope you are clear with this formula. NA union B is equal to NA plus NB minus NA intersection B. This formula will be used in probability also. This formula will be used in permutations and combinations also. If you have gone through the questions like this, let's say if you want to find out the number of numbers between 1 to 100, let's say you want to find out number of numbers between 1 to 100 which are divisible by 3 as well as 5. If you want to find out the numbers which are numbers between 1 to 100, number of numbers between 1 to 100 which are divisible by 3 as well as 5, then you will have to use this particular formula in permutations and combinations. Also, the usage of this particular formula is there in probability as well. So this is a very important formula. You must remember this. Also, if 3 sets are there, then this formula is also very important. Can you tell me the answer of this particular question, kids? Whenever you have been given these kind of questions, you can solve these questions by Venn diagram quite comfortably. Over here, as you can see, 2 sets are there. So you need to draw Venn diagram for the 2 sets. The 2 sets Venn diagram looks something like this. Okay, calling the white set as set A and the calling as this pink set as set B. Let's say over here, how many regions are there? There are 4 regions. One is the outermost region, one is this only A region, and third one is the common region between A and B, and this is only B region, that is region number 4. Now A union B means what? A union B means region 1, region 2, region 3 and region 4. I hope you remember, I have shown you the Venn diagram. So region 2 plus region 3 plus region 4. Okay, what will be the complement of A union B? Because here you can see you need to require A union B's complement is what is required over here. So what is coming in this set apart from R2, R3, R4 is going to be your A union B's complement, that is equal to R1. Talking about A complement means everything apart from A, that means R1 and R4, yes or no? And B set you are already having, which you need over here is nothing but R3 plus R4. Can you take the intersection of these two? Because the intersection of these two is required over here. So the intersection of these two is nothing but R4, and talking about this particular thing, it is nothing but how much? It is nothing but R1. So what is the union of these two things? Is nothing but region 1 union region 4. Now which of the following options are giving you region 1 and region 4? Nothing but A complement. Yes, that's why A complement is your answer. This particular thing you will be using where? This particular thing you will be using in mathematical reasoning as well. If you understood whatever I have taught over here, then I am telling you people, each and every question of mathematical reasoning you will be able to solve, and that too under 1 minute for sure. Under 1 minute for sure. So this method which I have taught you over here, I will also be using in mathematical reasoning, and 100% guarantee I can bet on this that you will be able to solve each and every question of mathematical reasoning as well. Alright, moving on to the next thing. Can you guys solve this particular question? It is found that 21 people like product A. Let me remove these data from here so that you guys can work on it. Yeah, come on kids, come on. Let's try to utilize the information given in this particular question, and let's try to solve this question as early as possible. Come on. Okay, in these kind of questions you have to, whenever 3 things are given to you, you have to draw this 3 set Venn diagram. Number 1, over here 8 regions do come. How many regions? 8 regions do come. Number 1. Okay, always try to first write down this particular region, that means the region which is common to all the 3 sets. Always try to write down the value of this particular thing first. So over here it is given to me that 8 like all the 3 things. So 8 like all the 3 things means over here 8 will come, because this is the region which is common to all the 3 sets. Okay, now if we talk about these things A and B means what regions in this Venn diagram? A and B means the thing which is common in A and B, that is these 2 regions. These 2 regions A and B included this as well as this as well and this as well. A and B includes this as well and this as well. Okay, so it is given to me that 14 people like A and B, that means 8 are already liking this, so 6 people will be liking this particular thing, yes or no? Okay, also 12 like C and A. 12 like C and A means this region has to have 12 people in it. So if 8 are over here, then that means 4 people will be over here. Okay, talking about B and C, 14 like B and C. B and C means this region as well as this region. So if 8 people are over here, then over here 6 people has to be there. Okay, 21 like product A. 21 like product A means all these people. So this has to be 21 in number. Over here you have already written 6, 8 and 4. So 6, 8 and 4 is going to be nothing but 18. So the remaining 3 people has to be there in only A. Only A means these 3 people. Also 26 people like product B. So 8 plus 6 is 14, 14 plus 6 is 20. So 26 has to be there in B set. So over here 6 people has to be there. Yes or no? And 29 people like product C. So 8 and 6 is 14, 14 and 4 is 18, and ultimately it has to be 29 in number. So these people has to be 11 in number. Okay. Once you get this particular data, you have to look for your answer now. How many people like only one of the 3 products? Only one of the 3 products means Either these people, or these people. These are the people who are liking only product A. These are the people who are liking only product B. These are the people who are liking only product C. So your answer is going to be how much? 3 plus 6 plus 11. That is equal to how much? 20 people. I hope you guys are clear with this question. Anyone is having any confusion in this, feel free to reach out to me. Do let me know, people. Are we guys clear with this? Yes? All right. Okay, let's talk about Cartesian product. In order to understand Cartesian product, this is how I teach. I take Saf's family, I take Karina's family, and I do conduct a marriage. Because of this marriage, let's say Cartesian product is what I am calling as marriage. Okay. If we say A cross B, I am talking Saf weds Karina. Okay. I'm saying that these two things are same only. Just feel it like this. Because of this marriage, what happens? Saf is going to form a connection with Karina, Karishma, as well as Ranbir. Also, Soha is going to form new connections because of this marriage with Karina, Karishma and Ranbir. So how many new connections will be formed because of Saf weds Karina? These will be the 6 new connections which will be formed, isn't it? Okay. Over here you need to observe that I am talking about Saf weds Karina. I am talking about Saf weds Karina. That means I am first writing down the members of Saf's family. That is Saf and Soha, and then I am writing down the members of Karina's family. So that is what nothing but the foundation of ordered pair. I hope you are aware of that. Since you know the basics, I am quickly moving on to this thing. Yes, let me talk about this. Saf comma Karina and Karina comma Saf is going to be different because here the reception will be conducted by Saf's family. That's why Saf's name is coming first. Over here, reception will be conducted by Karina's family. That's why Karina's name is coming first. So these two things are going to be different. Also, we can feel it like this. Saf is going to be husband of Karina and Karina is going to be wife of Saf. These two things are we will be considering different in mathematics. Okay. Let's say if this is A, this is B, this is 1, this is 2, this is 3. So what do we get in A cross B if this is set A and this is set B, people? A cross B is nothing but A comma 1, A comma 2, A comma 3. B comma 1, B comma 2 and B comma 3. Yes or no? If I talk about B cross A, then B cross A is going to be 1 comma A, 1 comma B, 2 comma A, 2 comma B, 3 comma A, 3 comma C. Yes or no, people? Let me tell you one thing, that A cross B and B cross A are not equal, though their cardinality is same, means number of elements in A cross B is always equal to number of elements in B cross A, and that is equal to number of elements in A times number of elements in B. How many of you people are aware of this, that A cross B and B cross A are going to be different, though their cardinality is going to be same? Anyone is having any confusion in this? Yes? Are we guys clear with this? Are we guys aware of this? Yes, absolutely. Okay. Yep. So we know Cartesian product well. So obviously, I think you must know that 1 comma A and A comma 1, these are two different ordered pairs, because whatever is coming first, because orders do matter, that's why I'm calling it as ordered pair. So these two things are different things, right? Okay. So that is what I hope you guys already aware of. Okay, can you tell me the answer of this particular thing, people? If A set is having 3 elements in it, B set is also having 3 elements in it, what will be the cardinality of A cross B, or how many number of elements will be coming in A cross B set? As I just told you, the formula is going to be NA times NB, so it is going to be nothing but 3 times 3, that is equal to 9 only. If I tell you to write down A cross B set, then it is going to be nothing but 1 comma 7, 1 comma 10, 1 comma 12, 3 comma 7, 3 comma 10, 3 comma 12, 4 comma 7, 4 comma 10, 4 comma 12. Yes or no, everyone? Yes. Okay. I hope you guys are clear with this particular thing. Okay. Ordered pair A comma B and B comma A will be different until and unless A and B are equal. Okay. That's why we do call them ordered pairs. Okay, if A set is given to me like this and B set is given to me like this, can you find out A cross B and B cross A? Obviously these two sets are different. So as I told you, A cross B and B cross A are different things, though their cardinality is same. That means number of elements in A cross B and number of elements in B cross A are both equal. Okay, moving on to the next thing. Can you solve this particular question? It's a very beautiful question that I would like to see how many of you guys can solve this particular question. If you talk about S1 cross S2, The S1 cross S2 will be looking as how? 1 comma A, 1 comma B, 1 comma C, 1 comma D. Yes? 2 comma A, 2 comma B, 2 comma C, 2 comma D. Then 3 comma A, 3 comma B, 3 comma C, 3 comma D. Yes or no, people? And so on, it will go till 20 comma A, 20 comma B, 20 comma C, 20 comma D. Alright. Over here, S1 cross S3 is also mentioned. So can you write down S1 cross S3 set, everyone? It is going to be 1 comma B, 1 comma D, 1 comma E, 1 comma F. 2 comma B, 2 comma D, 2 comma E, 2 comma F. 3 comma B, 3 comma D, 3 comma E, 3 comma F. Yes or no, people? Can you tell me the answer of this? Because this is a very, very, very beautiful problem, and problems like this you can expect in your JEE examination. Okay, this is dot 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 dot, because I cannot write each and everything. That's why I have applied dot 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 thing over here. Okay. Yep. Okay. So let's say I call this particular set as A and this particular set as B. What I need is nothing but number of elements coming in A union B. So I know the formula that it can be written as NA plus NB minus NA intersection B. Yes or no? How many elements are coming in A? That is S1 cross S2. Can you tell me? 4 plus 4 plus 4, and like this 20 rows are there. So 20 times 4, that is 80. How many elements are coming in B? That is S1 cross S3. Can you count it down? 4 plus 4 plus 4, 20 such rows will be there. So that is 80 again. How many elements are common in these two? Let's check it out. 1 comma B is here also. 1 comma D is here also, and here also. So in the first two rows, in the first row, we are having two elements common. If we talk about 2 comma B, 2 comma D, they are also coming over here. So in the second row also, we have two elements common. In the third row also, we will be having two elements common. So like this, there will be 20 rows, yes or no? So in each and every row, we are having two elements common, and there are 20 such rows. So 20 times 2, that is 40 elements has to be common or not? If yes, then what will be the answer? The answer is going to be 140. So the answer of this problem is going to be C for Calcutta. How many of you guys are, B for Bombay. Yes, exactly. B for Bombay is the correct answer. It's a very, 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 very beautiful question. You must be clear with this particular question. Yes, what's the doubt, beta? What's the doubt, beta? Do let me know, beta. Yeah, do let me know what's the doubt, beta. This is a very, very, very beautiful problem, and this problem should be definitely clear in your mind because it carries a lot of things. It carries a lot of conceptual, thing over here. Yeah. Okay. Yep. Can you do this question? It's a challenge question for all of you guys. It's a challenge question for all of you guys. Let me see how many of you guys do get the correct answer. Challenge question from my side. Come on, people. Challenge question from my side. What is the correct answer? Do let me know, people. A is a set in which it is going from 0 to 1, and B is a set in which it is going from -1 to 1. Then A cross B. A cross B means these are the values for X and these are the values for Y. So you can plot all these points. X is going from -1 to 1. X is going from 0 to 1. That means X is going from 0 to 1 like this. X equal to 0, X equal to 1. Okay. And if I talk about these values, these are nothing but the values of Y because it is coming over here, right? So it is going from -1 to 1. -1 to 1 means this is Y equal to -1 and this is Y equal to 1. So what kind of a shape is getting formed over here? Is it a rectangle? Yes. The coordinates of this point are nothing but 0, 1. The coordinate of this are nothing but 1, 1. The coordinate of this point is nothing but 1, -1. The coordinate of this point is nothing but 0, -1. So is it a rectangle having these four as the vertices? 1, 1, 0, 1, 0, -1 and 1, -1. So is the answer going to be C for Calcutta or not? Yes. Okay, no, not on the sides but rather insides. Why inside? Is because it is saying X is going from 0 to 1 but not 0 and 1. X is going to be from 0 to 1. So inside these two lines, my X lies. Over here, these particular lines lie between -1 and 1. So the answer has to be between these two regions. So that means the entire region inside this rectangle has been covered. So the answer has to be B for Bombay. That is inside the rectangle having vertices at 1, 0, 0, 1, 0, no. The points has to be this, but the answer has to be inside the rectangle. So the answer has to be D for Delhi, beta. Yes, inside or on the sides, no. No, not on the sides, because equality is not given over here. Inside the rectangle having vertices 1, 1, 0, 1, 0, -1, yes, inside. A is the correct answer, beta, rather. Because inside, only inside things are your answer. Look, X is going from 0 to 1. A set is coming first, that means this will be your X coordinate. B set is coming later, means these will be your values of Y. Okay, so your X coordinate is going from 0 to 1, means the region inside these two lines, X equal to 0 and X equal to 1, the region inside these two lines. Talking about this B set means values of Y, they are going from -1 to 1. So Y equal to -1 will go from here like this, and Y equal to 1 will go like this. So it is saying that the value is going between -1 to 1, means entire region between these two green lines will be your answer. And over here, the entire region between these two pink lines will be your answer. So the intersection of these two things is going to be what? The intersection of these two things is going to be the region which is coming inside this rectangle. That means this. So the answer has to be inside the rectangle. Why not the sides of the rectangle? Is because over here equalities are not given. If over here equalities are given, then the answer would have been on the sides as well. Okay, so over here the equalities are not given, that's why the answer cannot be sides. The answer will be inside the rectangle only. I hope we guys are clear. I hope you guys are clear with the answer. Yes, everyone? Yes, I hope we guys are clear with the answer. Yes, everyone? Alright, moving on to the next thing, relations. Look, any subset of A cross B. Look, as I just told you, that if a set A is having, let's say, 3 elements in it, and set B is having 4 elements in it, what will be the cardinality of A cross B? The cardinality of set A cross B is going to be nothing but number of elements in A times number of elements in B, that is equal to 12. So this A cross B is again a set. So if I ask you, number of subsets of A cross B will be how much? Number of subsets of A cross B will be how much? It will be nothing but equal to 2 to the power 12. Yes or no? And let me tell you a very important definition, and that is what? Any subset of A cross B is nothing but a relation from A to B. Any subset of A cross B is nothing but a relation from A to B. So number of subsets of A cross B means it has to be equal to number of relations from A to B, because any subset of A cross B is nothing but a relation from A to B. The number of relations from A to B will also be equal to 2 to the power 12. Out of those 2 to the power 12, can you imagine this number? Out of this many number of relations, one relation is given over here. Is this a subset of A cross B? Do let me know. Is this a subset of A cross B? Is this R a subset of A cross B? Is this R a subset of A cross B? Because if you do A cross B over here, it is going to be A1, B1, A1, B2, A1, B3, A1, B4, A2, B1, A2, B2, A2, B3, A2, B4, A3, B1, A3, B2, A3, B3, A3, B4. Yes or no? Yes. Is this R a subset of A cross B? Is this R a subset of A cross B, people? Is this R a subset of A cross B? Yes. If it is a subset of A cross B, then it is going to be a relation from A to B, because I just told you any subset of A cross B is going to be a relation from A to B. Yes. So this is nothing but a relation from A to B. Now, in this relation, you have to follow two things. Whatever is coming in the ordered pairs, these are nothing but your domain. So domain is consisting of A1 and A3. Whatever is coming later in these ordered pair is nothing but your range. So a range of the relation R is what? B2, B1. I hope you guys are clear with this particular thing. So what is domain? A1, A3. What is your range? Range is nothing but equal to whatever is coming later in these ordered pairs. So range of the relation R is nothing but B2 comma B1. I hope you guys are clear with this. Okay, moving ahead. So as I just told you, relation is nothing but a subset of A cross B. Any subset of A cross B is going to be a relation from A to B. So if I ask you a formula, number of relations from A to B, so that has to be equal to what? That has to be equal to 2 to the power number of elements in A cross B, and that is again has to be equal to 2 to the power number of elements in A times number of elements in B, because any subset of A cross B is going to be a relation from A to B. Okay, similarly we do have A cross A as well. A cross B and A cross A, the funda is absolutely same. Over here if you do A cross A, you can get A1 comma A1, A1 comma A2, A1 comma A3, A1 comma A4, A2 comma A1, A2 comma A2, A2 comma A3, A2 comma A4, A3 comma A1, A3 comma A2, A3 comma A3, A3 comma A4, A4 comma A1, A4 comma A2, A4 comma A3, A4 comma A4. Yes or no? 16 elements will be there in A cross A. Yes or no? 4 times 4, that is equal to 16. Yes. So how many subsets of A cross A can be written? How many subsets of A cross A can be written? That is equal to 2 to the power 16. So look, any subset of A cross A is going to be a relation from A to A, or in short, from A to A can also be written as relation on set A. If I say that relation is on set A, that means it is a relation from A to A only. Relation on set A means it is a relation from set A to A only. Either I say relation on set A or I say relation from set A to A, they are both same things. Okay, so this many relations on A can be written 2 to the power 16. You can imagine the number, how many relations can be written. Now coming on to this thing, is this R a subset of A cross A? Because A1 comma A2 will be there in A cross A, yes. A2 comma A3, yes, it will be there in A cross A. A2 comma A4, yes. So obviously this relation is a subset of A cross A, so we can say that this is a relation on A. What is the domain of the relation R? A1 comma A2 comma A2, or we can say A1 comma A2 only, because usually we don't repeat elements in a set. And also what is the range? A2 comma A3 comma A4. Yes or no everyone? Alright, moving on to the next thing. If A is the set of even natural numbers less than 8 and B is the set of first prime numbers less than 7, then the number of relations from A to B is going to be what? Can you tell me? Even natural numbers less than 8. Less than 8 even natural numbers will be written like this. B set is nothing but prime numbers less than 7. So can you write down the answer, people? B set will be written like this, 2, 3, 5. Okay, then the number of relations from A to B is nothing but number of subsets of A cross B, and by the way, number of elements in A cross B will be written as number of elements in A times number of elements in B, that is equal to 9. So number of relations that can be written from A to B is nothing but 2 to the power 9. That is the answer is going to be option A. Are we guys clear with this? Okay, let's talk about this particular relation, kids. Let R be a relation in N. Relation in N means relation from N to N. Relation from N to N. If I am talking about relation from N to N, that means both of these things in the order pair should be a natural number. Okay, it is also saying me that x has to be less than or equal to 5 and it has to be a natural number. So from these two things we can say x will be either equal to 1, it will be either equal to 3, it will be either equal to 4, or either it will be equal to 5. Yes or no? A natural number, and that too less than or equal to 5. Yes or no? So over here the ordered pairs are going to be what? First we put x equal to 1 in both these places. So 2 comma 2. Then we put x equal to 2, so it is going to be 3 comma 5. Then we put x equal to 3, it is going to be 4 comma 10. Then we put x equal to 4, so we get 5 comma 16, 17. Then we put x equal to 5, so we're going to get 6 comma 26. Yes or no? Now what is the domain? Domain is 2, 3, 4, 5, 6. So this is the correct statement. What is the range? 2, 5, 10, 17, 26. So this is the correct statement. So if B and C are correct, then D also needs to be correct. The question is talking about a false statement, so the answer has to be option A, because over here it has to be 6 comma 26, not 6 comma 25. I hope we guys are clear with this particular question, kids. Okay, if I tell you that do write down R inverse, If I tell you that do write down R inverse, these are the elements which are going to be there in R. If I tell you to write down R inverse over here, what you do? You just interchange these ordered pairs. So if you do the interchanging of 2 and 2, it is going to be 2, 2 only. But over here, if you want to write down R inverse, then you will write 5, 3 over here. You will write, if you want to write down R inverse, you can write 10, 4 over here. If you want to write down R inverse, so over here 17, 5 will come, and over here 26, 6 will come. Look, that is R and this is R inverse. In R inverse, what happens? Every ordered pair flips. 2, 2's, if you flip this 2, 2, it is going to be 2, 2 only. If it is 3, 5, if you flip it, it becomes 5, 3. If it is 4, 10, if you 4, 10, and if you flip it, it is going to be 10, 4 like this. So this is going to be your R inverse. Okay, that's how we get R inverse. This is a very important thing. What is the domain of this R inverse? 2, 5, 10, 17, 26. What is the range of R inverse? 2, 3, 4, 5 and 6. I hope you guys are clear with this particular thing. Any confusion of whatsoever kind? There has to be none. Okay, moving on to this problem. This time it is asking non-empty relations. Always remember, one relation is always empty. So over here, if you talk about A cross B, it will be having 8 times P number of elements in it. So 2 to the power 8P number of subsets of A cross B can be written, and that many relations from A to B can also be written, and out of these number of subsets of A cross B, or we can say this many number of relations from A to B, one has to be empty. So the question here is asking you number of non-empty relations. Number of non-empty relations. That means you need to remove one empty relation from the total number of relations that you're gonna get. So the answer is going to be D for Delhi. I hope you guys are clear with this question as well. Anyone is having any sort of confusion in this? Feel free to reach out to me. There has to be none. Moving on to next thing. Okay, these things we have just talked about, so we're gonna quickly move from here. Okay, if a relation R is given to you like this, if you want to do the mapping, that means what? 1 is shooting 1, or 1 is getting mapped with 1, 2 is getting mapped with 8, that means 2 is shooting 8, you can remember it like this. 3, 27 means 3 is shooting or 3 is mapping with 27. Okay, number 1. Number 2, listen to me very carefully over here. If I ask you what is the image of this one, that means the image of this one is 1. What is the image of 2? It is going to be 8. What is the image of 3? It is going to be 27. If I talk about the elements, these elements, I will be talking about pre-image. What is the pre-image of 1? 1. What is the pre-image of 8? 2. What is the pre-image of 27? 3. So image and pre-image, these two terms should be absolutely clear to you guys. We will be talking about image of these elements, and we will be talking about pre-image of these elements. This should also be clear to all of you guys. Domain we have just talked about. In every ordered pair, whichever is coming first before comma, that will be there in the domain. Range is what? In every ordered pair, whichever is coming later has to be there in the domain. Okay, yes, range is always a subset of B and domain is always a subset of A. You must always remember this. Over here, if you do A cross B, it is going to be 1, X, 1, Y, 1, Z, 2, X, 2, Y, 2, Z, 3, X, 3, Y, 3, Z. So 9 elements will be there. Out of these 9 elements, if you pick these 3, is it going to be a subset of A cross B? Yes. That's why it is a relation from A to B. If it is a relation from A to B, then can you write down the domain? The domain is nothing but 1, 2, whichever is coming earlier in the ordered pair, and the range is going to be whichever is coming later, means X, Z. So here you can see that domain is nothing but a subset of A and range is nothing but a subset of B only. I hope you guys are clear with this. Number of relations, we have seen this formula so many times today only. I think we guys are clear. If R is given to us and we need to find out R inverse, what we do? We just flip it. So 4, 2, 9, 3, 16, 4 will come in R inverse, right? Okay, let's do this question. Let's see how many of you guys can solve this question. Come on people. Yeah, X and Y are both natural numbers. So this is the equation between X and Y given to me. So X can be 1, X can be 2, X can be 3, X can be 4 and so on. If I put X equal to 1 over here, because X has to be a natural number only, so it is going to be 34. If I put X equal to 2, then it is going to be 35 minus 8, that is going to be 27. If I put X equal to 3, then it is going to be 8. If I put x equal to 4, it is going to be a negative number. And now every time you can see that if you put x equal to 5, y has to be negative. If you put x equal to 6, y will be negative, and so on. Every time you're going to get a negative number only. And over here it was given to you that y also needs to be a natural number. That means these things we're going to never take. So these are the ordered pairs that we're going to take: 1, 34, 2, 27, because x and y both needs to be natural number, as you can see over here, 3, 8. So your relation R will be looking something like this: 1, 34, 2, 27, 3, 8. If you want to write down R inverse, what you do is you just flip each and everything coming over here. Yes or no? So this is your R inverse. If this is your R inverse, then the domain of R inverse is what? Whichever is coming first in the ordered pair. So 34, 27, 8. And what is the range over here? Whichever is coming later in the ordered pair, 1, 2, 3. Yes, any confusion of whatsoever kind? There has to be none. Moving on to the next thing, people. This was a question asked in JEE Main 2020. Come on, let's solve this question. This is an ellipse. The region inside ellipse, yes or no? The equation can be written as x square by 8 plus y square over 8 by 3 is less than equal to 1. This is an ellipse which is flattened more onto which axis? X axis or y axis? X axis, because the thing which is written below the y square is lesser as compared to the thing which is written below the x square. That's why the ellipse will be flattened more onto the x axis. So the ellipse will be looking something like this, first of all. Okay. If you put x equal to, if you say the equation of this ellipse is going to be what? The equation of this ellipse is going to be x square by 8. The equation of this ellipse is going to be x square by 8 plus y square over 8 by 3 equal to 1. Okay. So this point is going to be how much? 2 root 2 comma 0. This point is going to be what? Minus 2 root 2 comma 0. This point is going to be what? 0 comma root 8 by 3. This point is going to be what? 0 comma minus root 8 by 3. Yes or no? Okay. As per this equation, the region inside the ellipse and the boundary is also included. As per this thing, the region inside the ellipse and the boundary is also included. Okay. I hope you have learned this much ellipse in conic sections. Okay. Now you have to solve this question. Okay. Relation on the set of integers, that means x and y, both should be integers only. Both should be integers only. So 0 comma 0 is obviously coming over here. 1 comma 0 is also coming. 2 comma 0 will also be coming inside only, because 2 root 2. 2 root 2 is how much? 2 times 1.414. This is going to be 2.828. So 2 comma 0 will be definitely coming before only. Over here, as per the symmetry, minus 1 comma 0 and minus 2 comma 0 will come inside the ellipse only, right? Okay. If you talk about 1 comma 1, 1 comma 1 will also be satisfying this inequality. Look. Is 1 comma 1 satisfying this inequality? Yes, absolutely. 1 comma 2 also satisfying this inequality or not? No, 1 comma 2 is not satisfying this inequality. I said fine, okay, no issues. Is 2 comma 1 satisfying this inequality? Yes, 2 comma 1 is satisfying this inequality. That means 2 comma 1 will be there in my relation R. As per the symmetry, 1 comma minus 1 and 2 comma minus 1 will also be there. Also, if you see, minus 1 comma 1 will also satisfy as per the symmetry. Minus 1 comma minus 1 and also minus 2 comma 1 and minus 2 comma minus 1 will also be there inside the ellipse. Can you find out these points inside the ellipse, because it is given to you that your relation R is on integers, means x and y should both be integers. So these are the points which will be there in the relation R. So the relation R will be consisting of all these red points that I have plotted over there. So the question is asking me the domain of R inverse. But before that, can we write down R inverse? R inverse. R will be having all these points. So R inverse will be having flip of all these points. Flip of all these points, if you do, the flip of 0 comma 0 is going to be 0 comma 0 only. The flip of all these points is going to be 0 comma minus 1, 0 comma minus 2, 0 comma 1, 0 comma 2. So let me write it down. 0 comma 1, 0 comma 2, 0 comma minus 1, 0 comma minus 2. The flip of this is going to be 1 comma minus 1. The flip of this is going to be 1 comma minus 2. The flip of this is going to be 1 comma 1, the flip of this is going to be 1 comma 2. Yes or no, people? The flip of these points, if you do minus 1 comma minus 2, the flip of this is minus 1 comma minus 1, the flip of this is 1 comma minus 1 comma 1, the flip of this is going to be minus 1 comma 2. Yes or no? Also, if you see 0 comma 1 will also be satisfying this inequality, and over here 0 comma minus 1 will also be satisfying this inequality. So if you do the flip of those points, so 1 comma 0 and 0 and minus 1 comma 0 will also come. So it is asking you what? Domain of R inverse. So domain of R inverse, if you talk about domain of R inverse, 0 will come, 1 will come, minus 1 will come, anything else? 0, 1 and minus 1 will definitely come. So these three value has to come. That means C for Calcutta will not be your answer. 0 will also come. So this will not be your answer. Okay. Can the answer ever come over here inside, and y's value can ever come 2 over here? If you do y equal to 2, then it is y will never come out to be equal to 2 for R. So for R inverse, x will never be come out to be equal to 2. That means this will not be your answer. So the answer has to be option A. Are you guys clear with this question or not? Do let me know, people. It's a very, very, very beautiful question, as this question was clubbed with conic sections and also sets, relations and functions. I consider this question as an easier one, provided you have a good visual experience of ellipse, because this is a very, very, very easy question, provided you have good visibility of how ellipse is going to look like, right? Yes, this is a very, very, very important and very, very, very beautiful question rather. Okay. All right, let's talk about relations on A. So there are multiple types of relations: empty relation, universal relation, identity relation, reflexive, symmetric, transitive. I will just say one sentence in all of these and you will be able to understand. So listen to me very carefully what I am going to say about all these types of relations. Okay. Number one, all these types of relations are defined on relations on A only. Relations on A only, that means from relations from A to A only. Relations from A to A only. Let's first talk about empty relation. Empty relation means null set. A null set is also a subset of A cross A. That's why a null set is going to be an empty relation from A to A, or empty relation on A. Let's say A is given to me like this and Y is given to me like this. Now it is a relation on A, means X and Y must both belong to A. This is the meaning of relation on A, that X and Y must both belong to set A. So if you put X equal to minus 1, X equal to minus 2, X equal to minus 3, X equal to minus 4, are you going to get the value of Y also from the set A only? Are you going to get the value of Y also from set A only? No, because here Y is going to be 5, here Y is going to be 10, here Y is going to be 15, here Y is going to be 20. So none of these values of Y lies in the set A. That means the set A is nothing but a null set only. Okay, universal relation. The entire A cross A is going to be a subset of A cross A as well. So the entire A cross A is going to be nothing but a universal relation on A, or universal relation from A to A. Over here, if you see, if you do A cross A, so if A is like this, 1, minus 2, minus 3, minus 4, over here also minus 1, minus 2, minus 3, minus 4, A cross A will be what? Minus 1, minus 1, minus 1, minus 2, minus 1, minus 3, minus 1, minus 4, minus 2, minus 1, minus 2, minus 2, minus 2, minus 3, minus 2, minus 4, minus 3, minus 1, minus 3, minus 2, minus 3, minus 3, minus 3, minus 4, minus 4, minus 1, minus 4, minus 2, minus 4, minus 3, minus 4, minus 4. 16 elements in A cross A is what you're gonna get. Yes or no? If you write down this relation R, if you put X equal to minus 1, so the value is going to be something like this. That means Y can be any value less than or equal to 5. I am talking about relation on A, means X and Y both should be from set A only. So look, Y has to be less than or equal to 5. So don't you think that all these values of Y are possible? That means if X is equal to minus 1, then the value of Y is minus 1 also possible, minus 2 also possible, minus 3 also possible, minus 4 also possible. Yes or no? That means minus 1, minus 1, minus 1, minus 2, minus 1, minus 3, minus 1, minus 4. These ordered pairs are possible. If we take X equal to minus 2, over here Y will be nothing but less than or equal to 10. all these values are less than or equal to 10 only, that means minus 2 comma minus 1 also possible, minus 2 comma minus 2 also possible, minus 2 comma minus 3 also possible, minus 2 comma minus 4 also possible, and like this if you move, don't you think that the entire A cross A will be coming in this relation R? If yes, then we say that it is nothing but a universal relation only. Identity relation. If all elements of A are connected with itself only, then we say that it is nothing but an identity relation. Look, if set A is given to me like this, then the relation 1, 1, 2, 2 ordered pair, 3, 3 ordered pair, this is nothing but an identity relation. Means every element is connected with itself only. 1 is connected with 1, 2 is connected with 2, 3 is connected with 3. This relation is nothing but identity relation. Okay, I hope you understood the definition of identity relation. How many identity relations we can write for a given set having n elements in it? Think over it. How many identity relations can be written? One, single. Because every element has to be connected with itself. None other than that. Okay, talking about reflexive relations. Now, if you have understood identity relations, reflexive relation is just a one-liner thing. Identity relation elements are required. It has to be identity relation plus extras are fine. Extras are fine. That means an element has to be connected with itself so that it becomes an identity relation. Also, if the element is related with other elements also, that is fine. So if this is a set given to us and I want to form an identity relation, then 1, 1, 2, 2, 3, 3 should be there. So these elements should be there in a reflexive relation as well, because here extras are also fine. Every element must be connected with itself. That means 1, 1, 2, 2, 3, 3. This has to be there. Extras are also fine. If an element is connected not just with itself but with other elements also, that is fine in a reflexive relation. Okay, but it has to have the elements which are required in the identity relations. That means every element has to be connected with itself. If I talk about this particular thing, let's say 1, 1, 2, 2 and 1, 2. So this is not a reflexive relation. Why? Because 3 is not connected with 3 over here. 3, 3 is not there. That's why this is not a reflexive relation. In order to have a reflexive relation, you must have all the elements required in an identity relation. That means every element of A must be connected with itself. So though 1, 1 is there, 2, 2 is there, but 3, 3 is not there, that's why this is not a reflexive relation. In a reflexive relation, extras are fine. Again, I am telling you, in a reflexive relation, extras are fine. Let's set A is given to me like this, then the total number of reflexive relations from A to A can be what? Now there is a usage of permutations and combinations, a very, very, very important thing, kids. If I want to write down reflexive relation, then 1, 1 and 2, 2, I have to take these two elements, yes or no? Apart from that, if you talk about A cross A, then A cross A will be having total 4 elements and they will be what? 1, 1, 1, 2, 2, 1 and 2, 2. If you want to write down reflexive relation, then you have to take this, you have to take this. Now there is a choice for these two. If you want to take it, you can. It does not matter, the relation is going to be reflexive only. If you take it or you do not take it, ultimately the relation is going to be reflexive only. So there are two choices for this particular ordered pair. Also for this, whether you take it or you do not take it, it does not affect. Ultimately this relation is going to be reflexive only. So there are two choices for this, two choices for this. So ultimately there are 2 times 2, that is 4 such choices possible, so that our relation becomes reflexive. So let me write down all those. One is this. Another one will be like this, 1, 1, 2, 2, 1, 2. Another one will be like this, 1, 1, 2, 2, 2, 2, 2, 1. Another one will be like this, 1, 1, the complete A cross A only. Okay, so these are the 4 possibilities so that the relation is reflexive. 1, 2, 3, 4. So how many reflexive relations can be written in this case? 4. And how to count it? That this is the way of counting, and the method that I just told you is there are 2 choices for this, whether to take it or not to take it, that is fine by us. Over here also 2 choices, so 2 times 2, that is equal to 4. So by permutations and combinations you can do the problem like this, and if you want to count it manually you can do it like this. Okay. Yeah, moving on to the next thing. It's symmetric. Just a one-liner thing. If a comma b is there, if a comma b is there, then b comma a must also be there, must also be there. If a comma b is there, then b comma a must also be there. So okay, so if you see 1 comma 1, so its opposite 1 comma 1 is also there, no issues. 1 comma 2 is there, so 2 comma 1 must also be there, it's there, no issues. 2 comma 1 is there, 1 comma 2 is also there, no issues. That's why this is a symmetric relation. I hope you understood this. Let A be a set like this and R be a relation like this. At least how many elements needed to be added so that it becomes reflexive as well as symmetric? Now 1 comma 1 is there, 2 comma 2 is there, but if you want to make it reflexive, then 3 comma 3 must also be there and 4 comma 4 must also be there. Okay, so if we add these two, the relation will become reflexive. Yes or no? Now talking about symmetric, no issue with this, no issue with this, no issue with this, no issue with this. 2 comma 3 is there, so we need to have 3 comma 2 also so that it becomes symmetric. 3 comma 1 is there, we must have 1 comma 3 as well so that it becomes symmetric. So these 4 elements must be added so that the relation becomes reflexive as well as symmetric. Can you guys think? Everyone, do let me know. Yes? Everyone, do let me know. Can you guys think on this? Yep. Yes, everyone. In order to have reflexive, you need to connect each and every element with itself. So 1 comma 1, 2 comma 2 are already there, so you must have these two as well, 3 comma 3 and 4 comma 4. Talking about symmetricity, if 2 comma 3 is there, 3 comma 2 must also be there, and 3 comma 1 is there, that's why 1 comma 3 must also be there so that the relation becomes symmetric. So these are the 4 elements required. Yep. Okay. Talking about this, if we talk about this relation, is it going to be reflexive only, symmetric only, reflexive and symmetric both? None of these. Okay. Reflexive means a comma a. If we put a and b both same, so it is going to be mod of 0 less than equal to 1. That means this is satisfied true. So it has to be reflexive, because reflexive means a and b are both same if you put whether the equation is satisfied or not. So it is getting satisfied if you put a and b both same. So it is going to be 0 less than or equal to 1 means it has to be reflexive. Okay, talking about symmetricity, if a minus b is less than equal to 1, then if we replace a by b and b by a, will the equation be satisfied? Yes, because I hope you know mod of x is nothing but equal to mod of minus x. Yes or no? So ultimately these two things are same only. So if you replace a by b and b by a, you get this very same thing. So the relation has to be symmetric as well. You can also say it like this: if you take a as 3 and b as 2, so 3 comma 2 is satisfying this. Is 2 comma 3 also satisfying it? Yes, obviously, that's why it is symmetric. If you take a as 1 and b also as 1, so 1 comma 1 is 1 comma 1 satisfying this? Yes. So it will happen for each and every value of a, whether you take a as 2, a as 3, a as 4 and so on. So ultimately this has to be reflexive as well as symmetric. Okay, transitive relation. Now the relation is transitive is not transitive only in one case. I am saying what? A relation is not transitive only in one case. If a comma b is there and b comma c is also there, look, a comma b is there and b comma c, these two things are same. If these two things are there and a comma c is not there, then we say that the relation is not transitive. Not transitive only in one case, otherwise everywhere it is transitive. If a comma b is there but b comma c is not there, don't worry, with respect to that element it has to be transitive only. If this is there but this is not there, then we don't need to check for that one. Ultimately it will be transitive only. This is the only case where the relation is not transitive. If a comma b is there and b comma c is also there, then a comma c has to be there so that the relation becomes transitive. If a comma c is not there, then the relation will not be transitive. It is as simple as that. Just remember this one, the only case where transitivity does not happen. Okay, let's say a set A is given to me like this and the relation R is given to me like this. Is it a transitive relation? Look, 1 comma 2 is there, that means A comma B is there. So 2 comma 3 is also there. If these two things are there, then 1 comma 3 has to be there. Yes, it is. So no issue with this element. Okay, talking about this element now, we have to pick element wise. Okay, 2 comma 3 is there. Now 3 comma something is there? No sir. If this is not there, we will not talk about the third one. Ultimately it has to be transitive with respect to this also, no issues. Talking about the third one, 1 comma 3 is there. Do we have 3 comma something? No sir. So if this is there and this is not there, we are not going to talk about the third one, it will be transitive only. So we can see that we have checked transitivity for each and every element and it is coming out to be transitive. So this is nothing but a transitive relation. If I talk about a relation like this, let's say I take a relation like this, is it going to be transitive? Is it going to be transitive? Yes people, because 1 comma 2 is there but 2 comma something is not there, so we are not going to talk about the third thing. It is transitive with respect to this only, because if this thing is also there, this thing is also there, then in order to become transitive this also must be there. But if this thing is not there, we are not going to check the third one. Ultimately it will be transitive only. This is what I have said people. So this is also a transitive relation only. I hope you guys are clear with this particular thing. Just remember this particular statement. If this is there and this is also there, then if this is not there, then the relation will not be transitive. Just a simple thing. Nothing else is required. Okay. I have given few more examples over here. You guys can check it out. Okay.
Is there something else I can help with?
Okay. Moving on to the next thing.
There's anything else?
Yep. Can you guys do this question? It was a question asked in JEE 2018. Come on people. A set A is given to me A comma B comma C, R1 is given to me like this, R2 is given to me like this, then whether R1 is symmetric or not transitive, we have to find out and all. Talking about R1, C comma A is there, A comma C is also there, yes, B comma B, no issues, its opposite is also there, C comma C, no issues, B comma C is there, is C comma B there? No. So R1 is not symmetric. Why R1 is not symmetric? Because B comma C is there but C comma B is not there. C comma B is not there. Are we guys clear everyone? Yes, the R1 is not symmetric. Okay, talking about R2. A comma B is there, B comma A is there, no issue. C comma C is there, okay. C comma A is there, A comma C is there, yes. A comma A, yes. So R2 is symmetric. R2 is symmetric. R2 is symmetric, no issues. Okay, let's check transitivity for R1. A lot of guys do get confused in transitivity. Again, I am telling you guys, the only case you need to remember where the relation is not transitive, that's it. If A comma B is there, B comma C is also there, and if A comma C is not there, that is the only case where the relation will not be transitive, that's it. It is as simple as that, okay. Yes, talking about R1, C comma A is there. Do we have A comma something? Yes, we do have A comma C as well as we do have A comma A. Okay, so first take these two. If these two are there, then C comma C has to be there. Yes, it is there, no issues. This C comma A has to be there, no issues. So with respect to this element, we have no issues. B comma B, C comma C, A comma A, the elements which we see in reflexive relations or we see in identity relations, we should never check transitivity for those elements so that we can save time. The elements which are there in the identity relations, don't check transitivity for them. You will save a lot of time in the examination hall. So let's talk about this A comma C. If A comma C is there, C comma A is also there, Nothing else. So a comma a must be there. It's there. No issues with respect to this element as well. Talking about b comma c. If b comma c is there and c comma a is also there, then b comma a has to be there so that it is transitive. Look, b comma c is there, c comma a is there, so b comma a has to be there, but we do not have b comma a. That's why the relation R1 is not transitive. So this is going to be wrong. This is also going to be wrong because R1 is not transitive, people. R1 is not transitive. So this is also not answer. The answer has to be this only because the answer has to be this only, right? I hope you guys are clear. Anyone is having any sort of confusion in this, feel free to reach out to me, people. Feel free to reach out to me. Yes, are we guys clear with the question? Are we guys clear with the question? Yes, I hope the question is clear to all of you guys. Anyone is having any confusion? No? Okay. This you can attempt as homework. It's a good question. Please do attempt it as part of homework. If a relation is reflexive, symmetric, transitive, all these three, then it is going to be nothing but equivalence relation. Okay. A relation needs to be reflexive, symmetric as well as transitive so that it is an equivalence relation. Okay. Yep. You can also do this question now quite comfortably. Try to attempt this question at home and do let me the answer. Question number 1. Question number 1 below the video you have to answer it, okay? Yep, below the video. This is a simple question now as I have explained so many things onto this, okay? Now, if you have understood that a relation can be function as well as it cannot be a function, then my way of telling is a story. But at this moment of time, I don't think it is going to help you much. So I'm quickly moving forward. Ultimately, the thing is this definition. Otherwise, I used to convey it through a game. Yeah. A relation R is said to be a function if every element in A has a mapping and every element in A has a single mapping. I say it like this. If you ever do have a confusion, you can follow this. My game. Let's say this is the relation, okay? Let's say this is the relation. So this is A, this is B, this is C, this is 1, this is 2, this is 3. Okay? Yeah, you can take like this. A, B, C, 1, 2, 3. This is set A, this is set B. Okay? And if I give you something like this, that A set is equal to A, B, C, B set is equal to 1, 2, 3, and the relation R is given to me like this. A, comma 1, B, comma 2, C, comma 3. Is this relation a function as well? Yes. So there should be two rules. Every member of our army shooting. This is our army, this is the opposition's army. Every member of our army is shooting and that too one bullet. So look, this member, this member, this member, all the three members are shooting and that too one bullet only. So that's why this is a function. Yep. So is this going to be a function, people? Every member of our army shooting and that too one bullet only? Yes, this is a function. If we talk about this, is this a function? Every member of our army is shooting and that too one bullet? Yes, this is a function. Every member of our army is not shooting. Look, this is not shooting. So that's why this is not a function, because every member of our army has to shoot and that too one bullet, that then only it will be a function. So over here this guy is not shooting, that's why this is not a function. This guy is shooting 2 bullets. I told you, if a relation needs to be function, then there has to be two things. Every member has to shoot, but that too one bullet only. This guy is shooting 2 bullets, that's why this is not a function. So this is the definition. Shooting means mapping. So every element in A has a mapping and that too a single mapping only. Then we say that it is this relation is nothing but a function also. Set A is nothing but domain, set B is nothing but codomain. So if a function is given to you like this, then whatever is written over here is nothing but domain, whatever is written over here is nothing but codomain. Okay? Yes. So is this relation a function? Yes. Every member of our army is shooting and that too one bullet only. So this is a function. Is this a function? Yes, because every member is shooting and that too one bullet only. Talking about this, is this a function? Yes, every member is shooting and that too one bullet only, so function. This is not a function because this guy is not shooting. Is this a function? No, because this guy is not shooting. Okay, now graphically also, how do we find out whether something is a function or not? We do vertical line test. If we get even a single vertical line which cuts the graph at 2 or more than 2 points, then it is not a function. If we get a single vertical line which cuts the graph at 2 or more than 2 points, then this is not a function. So if we talk about y square is equal to 4ax parabola, is it going to be a function? No. If we talk about ellipse, is it going to be a function? No. Because even if we get a single vertical line which cuts the graph at 2 or more than 2 points, then that particular thing is not a function. This ellipse is also not a function. Okay? Yep. Over here, is this going to be a function? No, because this guy is shooting 2 bullets. I told you what? Every member has to shoot once, and that too only 1 bullet. Our army means the values of x, opposition's army means value of y. We can also say it like this. For one value of x, we get one value of y only, then only it is going to be function. We can also say it like this. For one value of x, if we get only one value of y, then it is going to be a function. Otherwise, not. Okay, is this a function? Yes, every member is shooting and that too 1 bullet only. For one value of x, we are getting one value of y. For one value of x, for this value of x, we are not getting a y, so this is not a function because every member is not shooting. And also, for this value of x, we are getting 2 values of y, so that's why this is not a function. Or this guy is shooting 2 bullets, that's why this is not a function. Okay, image, range, this is, I have already told you. Okay, so as I told you, this is nothing but domain and this is nothing but codomain if a function is written like that. Okay, range, whosoever killed in the opposition army is nothing but range. I'll talk about this. Okay, let's talk about this relation, whether it is a function or not. So if you talk about the relation, this is 3,8, 4,8, 5,10 and 6,12. Is this going to be a relation? Yes. Every member, is this relation going to be a function? Yes, because every member of the army is shooting and that too 1 bullet only. So that's why this is a function. What is the domain of the function? Domain of the function is nothing but 3, 4, 5, 6. 3, 4, 5, 6. What is range? Whosoever killed in the opposition army. 8, 10, 12. 8, 10 and 12. What is the codomain? The entire opposition army. This is always codomain. And whosoever being shot in the opposition army is nothing but is there in my range. You can say it like this. Okay. Yep. This question you guys can attempt as homework now. There has to be no issue at all. Okay, types of functions. 1-1 function or injective function. Okay, 1-1 functions are also known as injective function. Okay. Over here, if you can see over here that this guy is getting killed by 2 people. So many guys are combining to kill a single guy. That's why it is a many-one function. Over here, the battle is going 1-on-1. Look, so you can say it like this. For one value of y, we get a unique x. For one value of y, we get a unique x. For one value of y, we get a unique x. Then it is 1-1. Otherwise, it is many-one. Or you can also feel it like this. In order to kill a single guy, we need 2 people. So many guys are combining to kill a single guy. That's why this is a many-one function. You can also remember it like this. Okay, if the function is not 1-1, it will be nothing but many-one. So is this a 1-1 function? First of all, is it a function? Yes, every member shooting that to 1 bullet. So this is a function. What kind of a function it is? 1-1 function. Because this guy is killed by 1 only. This guy is getting killed by a separate guy. Over here, if you see, this is a function. Yes, every member is shooting and that to 1 bullet. Function. Okay, what kind of a function? Many-one, because many guys are combining to kill a single guy. Or we can say 2 values of x are giving same value of y. If 2 or more than 2 values of x are giving same value of y, then it is not going to be a 1-1 function, it is going to be many-one function only. If you talk about this, y equal to x square, okay, if you take x equal to 2 or x equal to -4, -2, ultimately y will be equal to 4. That means 2 or more than 2 values of x are giving you same values of y. That's why this is not a 1-1 function, this is a many-one function. Okay, onto into. Now understand onto. If I kill all the members in the opposition army, that means range is equal to codomain. Then my army will be on top of the game. That's why I can say that the function is onto. If range is equal to codomain, then the function is nothing but onto. Onto is also known as surjective. So over here, is the entire opposition army killed? No, that's why it is into. So we can say that range includes this and this, and codomain includes this, this and this. So range is not equal to codomain, that's why it is into. Over here entire opposition army is dead, that means range is equal to codomain, means it is a onto function. Okay, over here it is into, entire opposition army is not killed, this guy is not killed. Over here this is onto because entire opposition army is killed, range is equal to codomain. Okay, is this function 1 1 and onto? Yes. Is this function 1 1 and into? Yes. Is this function 1 1? No, many 1 and onto? Yes. What kind of a function it is? Check it out, many 1 and into. Yes or no? I hope you guys are clear with these definitions. So what kind of a function it is going to be, beta? Give it a check. Every member is shooting and that too one bullet only. So this is a function. Now many guys are combining to kill a single guy. So it is a many 1 function and the entire opposition army is dead. That's why it is onto. So many 1 onto function it is. Many 1 onto function. So C for Calcutta has to be the correct answer. Yes or no, people? Yep. Moving ahead. Now this time look at the arrows. The arrows are going from x to 1, x to 2, x to 3. What is the answer? Do let me know in the chat box, everyone. What is the answer? Look at the arrows. The arrows are pointing towards these. That means x is killing 1, x is killing 2, x is shooting 3 as well. So this guy is shooting 3 bullets. Is it going to be a function? No. Because this time this is our army and this is the opposition's army. Because our army always shoots. So can a guy in a function shoot more than once? No. That's why this is not even a function. This is not even a function. Okay? Be clear with this. Okay. Now if I need to find out 1 1 and many 1 function, I do horizontal line test. Horizontal line test. If you draw the graph of this particular thing, the graph is coming out to be how? The graph is coming out to be something like this. If you get y equal to x square, if you get even a single horizontal line which cuts the graph at 2 or more than 2 points, then the function is going to be nothing but many 1 function. So this is a many 1 function. Also you can see over here at x equal to 2 and x equal to minus 2, we are going to get the value of y as same only. So at 2 values of x we are getting same values of y, that's why this is going to be a many 1 function only. So in order to find out whether the function is 1 1 or many 1, we do horizontal line test. If a single horizontal line cuts the graph at 2 or more than 2 points, then the function is many 1. Okay. Okay, over here the domain was all real numbers. Look, the domain was all real numbers, the codomain was R. Let's take this question up. Here the domain is R plus. So the graph, if you draw for this particular function, the graph will be drawn this much only, because the domain is positive real numbers only. So if you do horizontal line test over here, don't you think that the function is going to be 1 1 over here? Yes. Okay, moving on to the next thing. Over here if you do, the range, the domain is all real numbers, so the graph will be drawn like this, y equal to sin x. I hope you know that the graph of y equal to sin x will be drawn like this. Okay, is this a 1 1 function or many 1 function? You can draw even a single horizontal line which cuts the graph at 2 or more than 2 points, then the function is nothing but many 1. So is it going to be a many 1 function? Because if you draw a horizontal line like this, the graph will be cut at multiple points. Yes, a function which is 1 1 as well as onto is nothing but bijective, and for bijective functions only inverse can be written. Inverse can be written, kids. Yes, moving on to the next thing, domain of a function, permissible values of x for which we do get an output. In mathematics, denominator can never be equal to 0. I hope you are aware of this. Whatever is written inside the under root has to be greater than or equal to 0. In log, if you see, whatever is written over here has to be greater than 0, whatever written over here should be greater than 0 and not equal to 1. These are the 3 very basic requirements which should be there in each and every question of domain. Yes or no? Okay, so what will be the domain of this? The denominator can never be equal to 0, that means x should not be equal to 0, means x can be real numbers excluding 0. Talking about this, denominator can never be 0 means x cannot be equal to 1. Apart from that, x can be any real number. So x can be any real number except 1. If we talk about this, then x square minus 9 cannot be equal to 0, means x cannot be equal to 3 and minus 3. Rest x can be anything. So x can be any real number except minus 3 and 3. I hope you guys are clear with this. Okay, let's do this question. Come on kids. Come on kids. If this question comes in your examination, I want to see how you guys gonna solve this particular question. how you guys gonna solve this particular question? You have to solve this question as fast as you can. Try to see this question. Look, every question of domain can be solved objectively. If this is the answer, let's take any value from this particular option and let's try to put it over here. You can take x equal to 1, 2, 3, 4, 5, 6, anything. Let's take x equal to 5 and put it over here. If you put it over here, ultimately the expression is going to be like this. Okay, that is going to be nothing but under root of 5 minus 5, that is 1 upon under root of 0. In mathematics, denominator can never be equal to 0. Yes or no? That means x equal to 5 is not there in my domain. Yes or no? Because at x equal to 5, the denominator is getting equal to 0. So x equal to 5 can never be my answer, means whichever options are having x equal to 5 in it should not be my answer. So this is not my answer. This is also having x equal to 5, so this is not my answer. This is also having x equal to 5, so this is not my answer. This is the answer in that case, because x equal to 5 cannot be my answer. Also, I would like to tell you a few points which you must remember, If I tell you what is the answer of this, the answer of this has to be x belonging to minus infinity to 0. If I tell you the answer of this particular thing, then you must remember that it can be x belonging to any real number. If I tell you that mod of x equal to x, then you must know that x belonging to 0 to infinity is your answer. These are very, very, very basic things and you must know all these. Okay, if I tell you this, then x belongs to no solution. Fine. You must remember these important results. Do note it down, everyone, in case you are not aware of these results. Do note it down. So this is the art of eliminating the options. This trick is always applicable in the questions of domain, so you can definitely solve this solve your domain questions like this. Okay, you must remember these results, as these results are very, 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 very important. Moving on to the next thing, if I talk about the domain of this, then whatever is written inside the under root has to be greater than or equal to 0, so the answer will be 0 to infinity. If I talk about this, then whatever is written inside the under root has to be greater than or equal to 0. If you solve this through wavy curve method, you can get the answer, or there are multiple ways as well. You can do it like this as well, taking the under root, over here mod x will come, over here 3 will come. The answer of this is going to be what? Minus infinity till minus 3 union 3 to infinity. This is one way. The another way is what? The another way is you can write it like this and you can apply a square minus b square. So it is going to be x plus 3 into x minus 3 greater than or equal to 0. The solution of this through wavy curve method is going to be minus infinity till minus 3 union 3 to infinity. Yes, both methods are fine. You can follow any of the method, whichever method you like, you can follow and your question will be solved. Okay, let's do this question up. 2 minus x times x minus 3 has to be greater than or equal to 0. Solve this by wavy curve method. You can do it objectively as well. X equal to 2 and x equal to 3 both needs to be your answer. If this is your answer, then x equal to 0 is also your answer. So if you put x equal to 0 into this, is this inequality getting satisfied? No, that's why this is not the answer. If this is the answer, look, x equal to 2 is getting satisfied and over here 2 is not included, that's why this is not the answer. If you see over here x equal to 1, is x equal to 1 satisfying this inequality? No, that's why this is not the answer. So the answer has to be C for Calcutta. The objective way of solving the question. Or another way is what? Another way is using the wavy curve method. You can definitely solve it. The answer is going to be C for Calcutta. Okay. So again I am telling you what? The art of eliminating the options. You have to apply this in the examination so that you get more questions correctly. Over here, in the case of logarithm, I told you whatever is coming over here has to be greater than 0, whatever is coming over here has to be greater than 0 and not equal to 1. These are the three conditions that you have to apply in every question of logarithm to get to the correct answer. So over here, the domain, if you see, it is going to be x greater than 1 because E is Napier's constant and it is already 2.71 roughly, so has to be greater than 0 and not equal to 1. Okay, so x has to be greater than 1 over here. Over here, if you see, then x has to be greater than 0 and not equal to 1. Means x belongs to 0 to infinity excluding 1, and in the B part if you see, then x square minus 5x plus 6 has to be greater than 0. If you factorize it, it is going to be x minus 2 times x minus 3 greater than 0, and if you solve it, it is going to be x belonging to minus infinity to union 3 to infinity. Right? I hope you are aware of all these problems and you know how to solve these questions. Okay. if such kind of a thing is given to us, so if let's say two functions are there and in between plus minus is written and I need to find out the domain of the entire expression, we will solve this one individually. So its answer we got 2 to 3, and we gonna solve this question also individually. So over here the answer is going to be what? Over here the answer is going to be x belonging to 0 to infinity excluding 1. Okay, so the intersection of these two is what we're gonna take to write down the answer. So 1 intersection 2 is going to be the domain of the entire problem, the domain of this intersection domain of this. So the domain of the original question over here is going to be the intersection of these two things, the domain of this and the domain of this. You must remember this. Okay, these are different expressions, because over here for x belonging to R it is going to be 1, but here x equal to 0 it is not defined, because denominator will be 0 at x equal to 1. So 1 and x by x are two different things, because at x equal to 0 the denominator is 0, that's why it is not there in the domain. So over here the domain is x belonging to all real numbers excluding 0. So the domain of these two expressions are different, so that's why the expressions are also different. Talking about this, if you want to solve this particular problem, then we can say that whatever is written inside the under root has to be greater than or equal to 0. So if you factorize it, you're going to get greatest integer of x minus 1 times greatest integer of x minus 3 is greater than or equal to 0. If you solve this wavy curve method, it is going to be greatest integer of x minus greatest integer of x should be lesser than or equal to greatest integer of 1, or x should be greater than this. So the answer of this problem is going to be what? X belonging to 3 to infinity, and the answer of this is going to be what? X belonging to minus infinity say 0. No, minus infinity say 2 open. This is a very important thing. I have already explained you in this today's session only. So the answer is going to be what? The answer is going to be the union of these two, because or is written in between them. So 1 union 2 is the final answer. So what will be the final answer? The final answer is going to be x belonging to minus infinity say 2 union 3 say infinity. Any issues in this, do let me know. I have explained this thing in the, yes, I have explained this thing when I have taken greatest integer function earlier in this session itself. Yes, you must be able to solve these kind of problems of greatest integer, kids. Yes, talking about this, the domain of this, look, fractional part of x always goes from 0 to 1 only. So it is a positive number in any case. So whatever it is written inside the under root has to be greater than or equal to 0 only, no matter what is the value of x. So over here x can be any real number. So the domain is x real numbers, because ultimately fractional part of x is going to be closed 0 till 1 open only. Okay, the domain of this, look, this thing has to be greater than 0. Okay, this thing also needs to be greater than 0. Okay, this thing also needs to be greater than 0. So all these three things has to be there, yes or no? Now let me tell you one important thing about logarithm. If let's say log a to the base b greater than equal to c is written, now how to solve this inequality? It depends on the value of b. If b is greater than 1 and if b is between 0 to 1, there are two important scenarios. The number one is, if base is greater than 1, then sign of inequality remains same. If base is between 0 to 1, then sign of inequality changes. This is a very important thing. So if you want to solve this, then this thing, since the base is greater than 1, so this thing log of x to the base 10 will be greater than 10 to the power 0. That means log of x to the base 10 will be greater than 1. Over here again, if you apply the base is greater than 1, that's why you can write x should be greater than 10 to the power 1. So this is the solution of 1. Talking about this, over here if you do x should be greater than 10 to the power 0, because 10 is greater than 1, so the sign of inequality will remain same. So over here you're going to get x greater than 1, and over here x greater than 0. So in this question you're going to take the intersection of all these three, because all these three things has to be there in a single question. So ultimately you're going to get x belonging to 10 to infinity. This is your domain. Anyone is having any confusion in this, feel free to reach out to me, kids. let's do this question which was asked in JEE 2019. Come on kids, let's see how many of you guys get the correct answer. Now if we try to solve this question objectively, over here we can say that the denominator can never be equal to 0, means x cannot be equal to 2n minus 2. Okay, over here x is not equal to 2n minus 2, this can be our answer. Over here also x is not equal to 2n minus 2, this can also be our answer. Over here also if you see x is not equal to 2n minus 2, this can also be our answer. Over here also if you see x is not equal to 2n minus 2, so this can be our answer. So we are not able to eliminate based on this particular thing that the denominator should be equal to 0. We are not able to eliminate any of the options. No worries. Let's talk about this. If it is written over here like this, log of x cube minus x, then whatever is written over here should also be positive. That means x cube minus x should be greater than 0. Yes or no, people? Over here 3 by 2 is included, or let's say 3 is also included, right? So x equal to 3 is my answer or not? Let's check it out. X equal to 3 if you put over here, then it is getting satisfied. That means x equal to 3 is my answer, right or not? Over here x equal to 3 is not included, but x equal to 3 if I put over here, I am going to get a value greater than 0 only, so this is not my answer. Over here also x equal to 3 is included, look, so this can be my answer. Over here also x equal to 3 is included, so this can also be my answer. I said okay, no issues. Let's talk about some other values then. If I talk about this, then 3 by 2 is included over here, but 3 by 2 is not included over here, look. Between 1 and 2 there lies 3 by 2, that is 1.5. So is a 3 by 2 going to satisfy this? Yes. Check it. 1.5 ka whole cube minus 1 is going to be a positive number only. So 1.5 also needs to be my answer. So 1.5 is not included in this, that's why this is not my answer. Talking about this and this, 1.5 is also included in this, 1.5 is also included in this. Okay, but over here negative values are also there and here negative values are not there. So I said let's talk about x equal to minus half. X equal to minus half is included over here and x equal to minus half is not included over here. So let's check for x equal to minus half. If we talk about x equal to minus half, then this expression is going to be how much? Minus 1 by 8 plus 1 by 2. So is it going to be a positive number? Yes, that means x equal to minus half should be our answer. So C for Calcutta is our answer, but A is not our answer. Like this, if you do, you can solve JEE questions in an objective manner, and believe me, in every question of domain this thing is going to be applicable. Okay, let's talk about this, kids. Let's talk about this, kids. Now you must know the domain of the definition of the function. Okay, the domain means we need to find out what? We need to find out the values of x. I said okay. So 2 to the power y can be written as 2 to the 2 minus 2 to the power x. Okay. Now I want to tell you one thing. This is an exponential function because base is constant and power is variable. Yes or no? So exponential function is always greater than 0. Is always what? Is always greater than 0. So if the left hand side is greater than 0, then the right hand side must also be greater than 0. Yes or no? So if you do this, then you're going to get something like this. And let me tell you one thing, that whenever the base is greater than 1, whenever the base is greater than 1, if the power is lesser, the number is going to be lesser. Whenever the base is greater than 1, if the power is lesser, then only the number is going to be lesser. So x has to be less than 1 or not. Do let me know. Yes? Okay, so x has to be ultimately less than 1. It can go where? It can go till infinity, there is no issue. But x cannot be equal to 1 because the thing can never be equal to 0. This thing will never be equal to 0 because this will tend towards 0, but this thing will never be equal to 0, because if you look at the graph of 2 to the power y, the graph will be drawn like this. Y equal to 2 to the power x's graph will be drawn like this. Yes or no? So this value is never equal to 0. It tends towards 0. Right? So there will be no equality. There will be no equality means x will never be equal to 1. If x is never equal to 1 means this and this will never be your answer, means the answer has to be D for Delhi. You understood, people? Yes? Look, if x is equal to 1, as you can see in option B, A, B and C, if x is equal to 1, then the value of y, can you get? The value of y will come out like this. So 2 to the power y equal to 0. Can this value ever be equal to 0? Tell me. No. So x equal to 1 will never be possible in our domain. So and options A, B and C are all eliminated. Option D has to be your answer. You understood or not, people? Look, objectively, just a single thing you have applied and your question is solved. Easy or not, everyone, do let me know. Yep. At x equal to 1, if you see, which is included in option A, B and C, the value of y will be what? There is no such value of y possible, so that you get 2 to the power y equal to 0, yes or no? So ultimately there has to be no such value of x equal to 1 possible. So x equal to 1 is not there in my domain, so the answer has to be option D. That's it. Range of a function, I hope you are aware that sin x goes from -1 to 1, so mod of sin x will go from 0 to 1. Mod of cos x will also go from 0 to 1. This will go from 0 to infinity because tan x goes from -infinity to infinity. Cosec x goes from 1 to infinity. Mod of this will go from 1 to infinity because cosec x goes from -infinity to -1 union 1 to infinity. Cot x will also go from 0 to infinity because cot x goes from -infinity to infinity. Similarly, sec x goes from -infinity to -1 union 1 to infinity. So this will go from 1 to infinity. I hope you are clear with this. Okay, 2 sin x, 2 times of this will go from where to where, kids? -2 to 2, that means 0 to 2 it will go, because ultimately you have applied modulus over here. So look, how exactly we find out the value? We know that sin x goes from where to where? We know that sin x goes from -1 to 1. So 2 sin x means we need to multiply each and everything by 2. 2 is a positive number, so sign of inequality is going to remain same. So 2 sin x is going from where to where? -2 to 2. Now if 2 sin x is going from -2 to 2, their modulus is going to be from 0 to 2 only. Yes, okay. 2 times of mod tan x. Mod tan x will go from 0 to infinity. So ultimately this will also go from 0 to infinity only. Give it a check. Tan x ka mod will go from 0 to infinity. So 2 times of 0, if you do, you can get 0 only. 2 is a positive number, sign of inequality will remain same. Yes or no? 2 into infinity will be infinity only. So ultimately it is going from 0 to infinity only. Okay. 2 cos x ka modulus will go from 0 to 2. Yes or no? How many of you guys are aware of this? Okay. Over here plus 3 is also there. So if you do plus 3 in all these 3, what you're going to get? You're going to get the value from 3 to 5. So the answer of this is going to be 3 to 5. Here also if you do, what will be the answer of the fourth one, kids? Come on. The fourth one's answer is going to be what? 3 mod cos x will go from 0 to 3. And if you do -3 in all the 3 sides, what are you going to get? -3 till 0. So the answer of this option is, this question is -3 till 0. Yes or no? Yep. Okay. Talking about the next things, I hope you have, we have just done this 0 to 2. This is what 0 to infinity. This is what 3 to 5. This is what -3 till 0. Okay. Okay. Talking about this x square minus 4x plus 3. Since this is a quadratic opening upward, I hope you are aware that the graph is looking something like, is going to look something like this. The two roots are 1 and 3. Yes or no? If you can factorize it, it is going to be x minus 1 times x minus 3. Yes. So the graph will be looking like this, opening upwards. This is going to be 1, 0. This is going to be how much? 3, 0. Right? Okay. The vertex always is minus b by 2a, minus d by 4a. The coordinates of a vertex in quadratic is nothing but minus b by 2a, minus d by 4a. So I hope you can get the value of minus d by 4a. D is discriminant, by the way. Okay. So minus 1 is going to be the value of minus d by 4a. So ultimately this will go from -1 to infinity. Yes or no, people? Okay, the modulus will go from 0 to infinity. Okay, if we talk about this, then this will also go from -1 to infinity only. Because I would like to tell you the graph of, this is how the graph of y equal to this looks like. And the graph of y equal to mod of x square minus 4x plus 3. We just remove this one and we take its mirror image along the x-axis, so that we get the graph of this particular expression like this. This is 1, 0. This is 3, 0, and this point is 2. So this point is going to be 2, something. So how much? 2, 1. Earlier it will be 2, minus 1. Okay. If we talk about the graph of the third one, let me tell you. The graph of the third one is going to be what? Whenever x is replaced by mod x, we just need to Draw the graph for positive x first. So the graph for positive x will be coming out like this, and just take its mirror image about y-axis as well. Yes, so this is how the graph of this expression will be looking like. So ultimately it will also go from minus infinity to plus infinity only. Yeah, graph drawing is a very important art. I hope you are aware of this. Okay, x plus 1, the range is going to be what? X goes from minus infinity to infinity, so it will also go from minus infinity to infinity, that is all real numbers. This will go from 0 to infinity because modulus has been applied. Over here, it is going, it will go from minus 2 is also there, so minus 2 to infinity it will go, right? Because x plus 1 will go from minus infinity to infinity, the modulus of x plus 1 will go from 0 to infinity. And if you do minus 2, so you do minus 2 from all the three sides. So it is going to be infinity only, and this is going to be minus 2 ultimately, right? Okay, talking about this, the greatest integer of sin x. Look, sin x goes from minus 1 to 1. So how many integral values that sin x can take? Minus 1, 0 and 1. So greatest integer is nothing but the integer value only. So there are only three values which can be taken by greatest integer of sin x, and that is minus 1, 0 and 1. Similarly, minus sin x will also go from minus 1 to 1 only. So how many integral values it can take in between? Minus 1, 0 and 1. 2 minus sin x, we need to think this. Minus sin x will also go from minus 1 to 1 only. If we add 2 to all the three sides, plus 2, plus 2, plus 2. So this is going from 1, say 3. So how many integral values are possible between 1 to 3? 1, 2 and 3. Yes or no? So 1, 2 and 3, these values are possible. Yep. Okay, talking about this, I have just told you that 2 minus sin x. 2 minus sin x will go from 1 till 3. So its modulus will also go from 1 to 3 only because it is already a positive number. Yes or no? And the greatest integer of that is again going to be the same thing only, so it is going to be 1, 2, 3 only. Okay, and if you multiply it by 2, so if you multiply it by 2, so all these values will be multiplied by 2 ultimately, so it is going to be 2, 4 and 6. Everyone think over it. These are very, very, very important things and very basic things that you must master and clear if you want to score good in the JEE examination. Okay, talking about this, we need to find out the range for this. This will always go from 0 to 1. Fractional part of any number will go from 0 to 1 only. So the answer of this is also going to be 1 only. Fractional part of x goes from 0 to 1, including 0, excluding 1. So 2 times of this. That means we need to multiply everything by 2. So over here 2 is a positive number. Sign of inequality will remain same. So it will go from 0 to 2. Have a check, people. Have a check. Okay, talking about this, fractional part of any number will go from 0 to 1 only. So 2 times if you do, it is going to be nothing but 0 to 2 only. Okay, so 2 times of fractional part of x plus 1 will go from 0 to 2 only. If you do minus 3 if you do all the three sides, so it is going to be minus 3 se lekar ke minus 1. So this is going to be the answer. Yep. Okay, talking about this, if x is going from 0 till 3, then x square will go from where to where? Okay, the greatest integer of x square it is talking about. Okay, this is a very, very, very important thing. This will be coming in use in integration as well. So if x is going from 0 to 3, x is going from 0 to 3, so x square will go from where to where? 0 to 9. If x square is going from 0 to 9, including 0 and 9, so what are the integral values? Because this is greatest integer function. So the integral values only it is going to take. So it is going to take 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the integral values that this expression is going to take. Okay, if x is going from 1 to, if x is going from 1 se lekar ke open 9, then if you put a under root on all these three things, so you're going to get under root of x, over here under root of 9, so over here 3 you're going to get under root of x, and over here 1. So what are the integral values being taken by root x? Only 1, 2 but not 3. So root x can take integral values 1 and 2, so the greatest integer can take only values 1 and 2 only. So the answer of this is nothing but 1 and 2. Yes, everyone, have a look at this. These are very, very, very basic things and very important one as well. Okay, 3 to the power x is given to you, where x is going from this to this. What will be the value of range? So 3 to the power 1, 3 to the power 2, 3 to the power 3, 3 to the power 4, because these are discrete points. Okay, now let me tell you that there are two kinds of exponential function. Let me tell you there are two kinds of exponential function. One is such kind of an exponential function, another one is such kind of an exponential function. Let me tell you. This is the graph of y equal to a ki power x when a is greater than 1. Like y equal to 2 to the power x, the graph will be like this. Y equal to 3 to the power x, graph will be like this. Y equal to 10 to the power x, graph will be like this. This is the graph when y equal to, this is the also the graph of y equal to a ki power x only, but it comes when a is between 0 to 1. That means this is the graph for 1 by 2 to the whole power x. This is the graph for y equal to 1 by e to the power x. By the way, 1 by e to the power x can also be written as e to the power minus x. Give it a check. Okay. Yeah. So if you look closely over here, this is an increasing function. Yes or no? If you are not aware about increasing function, let me tell you increasing functions as well. You might have studied in application of derivatives. If you stand on the leftmost part of the x-axis and if you move into the right positive x-axis, is your y increasing? If yes, then we say that it is an increasing function. If you stand on the leftmost part of the x-axis and if you travel towards positive x-axis, is the value of y decreasing? Yes, that's why you do call it as decreasing function. Now in increasing function, what happens? At greater x we get greater y, because x increases along the positive x-axis. So the value of y is continuously increasing. That means at greater x we get greater y. Whereas in case of decreasing functions, at greater x we get lesser y. We get lesser y. If you are aware of this much, then you can solve all these questions quite comfortably. Talking about the B part, kids, x is going from 0 to 2. So 3 to the power x is an increasing function. So at x equal to 0, we're going to get the least value, and at x equal to 2, we're going to get the greatest value of 3 to the power x, because 3 to the power x is an increasing function. So at least x, we're going to get least x, and at greatest x, we're going to get greatest y. Yes or no? So the range is going to be 3 to the power 0 till 3 to the power 2. That is 1 till 9. Okay, talking about this, the range is going to be 3 to the power 0 till 3 to the power infinity. So the answer is going to be 1 till infinity, because 3 to the power infinity is again going to be infinity only. Talking about this, the least value is going to be 3 to the power minus infinity, that will be moving towards 0, and the greatest value will be 3 to the power 0 only. Okay, over here the least value will be 0 and the highest value will be infinity. That's why the graph of y equal to 3 to the power x comes something like this. The range goes from, the value of y goes from 0 to infinity, as you can see over here. Yes? Okay, if I have been talked about 3x square plus 2, now listen to me very carefully. These are the values of x, and I have been talked about 3 to the power x square plus 2. So I must know first what is the value of x square plus 2. So if x is equal to 1, then x square plus 2 will be what? 1 square plus 2, that is 3. If x is equal to 2, then it is 2 square plus 2, that is equal to 4. 2 square plus 2, that is 6. If x is equal to 3, then it is 9 plus 2, 11. If x is equal to 4, then it is nothing but 18. So these are the values of x square plus 2. If you put it over here, then you're going to get nothing but the range. So your range is coming out to be what? Your range in this question is coming out to be 3 to the power 3, 3 to the power 6, 3 to the power 11, 3 to the power 18. Yes or no? Okay, talking about this, look. X square plus 2, if you see x square plus 2, the graph of x square plus 2, I'm talking about the graph of x square plus 2, okay? The graph of x square plus 2 looks something like this. Now over here, if you see, x equal to 0 is coming over here, and x equal to 2 will be coming somewhere over here. Look, in this portion if you see, between 0 to 2, x square plus 2's value increases or not? That means in these values of x, the power is going to increase, and we know that at a higher power of 3, we're going to get higher value of that expression. At lesser power of x, we're going to get lesser power of 3, we're going to get lesser value of this expression. Yes or no? So ultimately, at x equal to 0, the value of this expression is 2. And the value of this expression at x equal to 2 is 6. So this point is 2, 6. So when you put x equal to 2 over here, you're going to get 6, and at x equal to 0, you're going to get this expression as 2. So ultimately the answer is going to be 3 to the power 2 till 3 to the power 6 or not, because at x equal to 0, this expression is going to be least, and at x equal to 6, this expression is going to be greatest. So at greatest power, we're going to get greatest value of this expression. At least power, we're going to get least value of this expression. Yes or no? Okay, talking about this this expression, 0 to infinity. So 0 to infinity, the graph will be drawn like this. So the least value will be at x equal to 0, and the greatest value will be at x equal to infinity. So it is going to be 3 to the power 0 square plus 2, comma 3 to the power infinity square plus 2. So ultimately it is going to be 3 to the power 2, comma infinity only, that is 9 till infinity. It is a very, very, very important thing that I have just talked about, kids. Over here, as you can see, the graph of x square plus 2 from minus infinity to 0 will be drawn like this. So this is a decreasing function. This particular thing is a decreasing value when I am talking about minus infinity to 0. So at x equal to minus infinity, you're going to get the greatest value, that is 3 to the power infinity, that is infinity. And at x equal to 0, you're going to get the greatest value, so the least value, the least value will be like this. At x equal to 0, you're going to get the least value, because this is a decreasing function, this power. Okay, talking about this, so it is going to be what? It is going to be it is going to be 3 to the power 2 till infinity only, because it's an even function, and even functions are symmetric about what axis? It's an even function are symmetric about what axis? Even functions are symmetric about y axis, people. Symmetric about y axis. Yes, you must know this. So from there also you can have an idea that these two problems are going to be same only, since it is an even function. So last, this C, D and E are all same problems, because I am talking about an even function in this particular graph, right? Okay, talking about this now, it is decreasing function, isn't it? It is decreasing function, yes or no? So over here it is very simple, 1 by 3 to the whole power 1, 1 by 3 to the whole power 2, 1 by 3 to the whole power 3, 1 by 3 to the whole power 4. This is quite easy, but this is a decreasing function. Decreasing function means at x equal to 2, I am going to get the greatest value of this, least value of this, and at x equal to 0, I am going to get the greatest value of this. So the answer is going to be what? 1 by 3 to the whole power 2 till 1 by 3 to the whole power 0, means the answer is going to be 1 by 9 till 1. Over here also, if you do at infinity, you're going to get the least value. So the least value is going to be 0, and at x equal to 0, you're going to get the greatest value. So the greatest value is going to be 1 by 3 to the whole power 0, that is 1, since it is a decreasing function. Over here also, at x equal to 0, you're going to get the least value, and at x equal to minus infinity, you're going to get the greatest value. 1 by 3 to the whole power minus infinity means 3 to the power infinity, that will be equal to infinity only. So this will be the answer. Talking about this, if you draw the graph of this expression, the graph of this expression will be looking something like this. So the least value will be nothing but 0, and the greatest value will be infinity. So the answer is going to be 0 to infinity. Yes or no? Okay, talking about this, whenever in place of x power is there, we first need to deal with this power. Okay, so over here it's quite easy, put x equal to 1, 2, 3, 4 and get the answer of this question. There has to be no issues. But if we draw the graph of x square plus x plus 1, the graph will be opening upward, the discriminant is negative, so the graph will be of this shape, people. Yes or no? I am talking about the graph of y equal to x square plus x plus 1. I am talking about this power only, okay? Okay, so as you can see, the least value will be at minus b by 2a. Minus b by 2a is how much? Minus 1 by 2. Okay, so the graph will not be looking like this actually. Minus b by 2a, that means the graph will be on the graph of y equal to, the graph will be drawn something like this. I am saying that this expression is g, so I am drawing the graph of g equal to x square plus x plus 1. Okay, okay, so this is the least point, minus b by 2a. Minus b by 2a is going to be minus 1 by 2. If you put minus 1 by 2 over here, so 1 by 4 minus 1 by 2 plus 1 means 5 by 4 minus 1 by 2 means 3 by 4. 3 by 4 is the least value. Yes, 3 by 4. So this point is 3 by 4. Okay. Yep. So understand it, between 0 to 2, if you see, this is 0 and this is 2. Between 0 to 2, if you see, this function is increasing, isn't it? So if you increase the value from 0 to 2, the power is going to increase, because x square plus x plus 1 is going to increase. So at x equal to 0, you're going to get the least value for this expression, 0 square plus 0 plus 1, and you're going to get the maximum value of this expression when x is equal to 2, because it is increasing in this interval. So 1 by 2, 3 to the power 2 square plus 2 plus 1. This is going to be your range, including these 2 points. Yes, between 0 to infinity, if you see, this is again increasing. So you can say that you're going to get the least value at x equal to 0. So 0 square plus 0 plus 1, and highest value will be at infinity, which is going to be how much? Okay, wait a minute. The power is increasing, but the overall number will be decreasing, right? The overall number will be decreasing, so this has to interchange. So let me tell you this. So the answer is going to be something like this: 1 by 2, 2 square plus 2 plus 1, comma 1 by 3, 0 square plus 0 plus 1. This is going to be a range. If we talk about this, the answer is going to be how much? 0 till 0 also not included, because if you put x equal to infinity, then this will be 1 by 3 to the power infinity only. 1 by 3 to the power infinity will move towards 0. So 0 till, it will go where? It will go till 1 by 3 ki whole power 0 square plus 0 plus 1. So this is going to be your range for the third one. Okay. Similarly, you can do the fourth one as well, and this as well. There has to be no issue at all. Okay. So these 2 things you can do as homework. Okay, talking about this logarithmic expression, just like the exponential thing, the graph of the logarithmic expressions are also 2. One looks something like this, and another one looks something like this. This is the graph of y equal to log x base a. Whenever a is between 0 to 1, it's a decreasing graph, yes or no? And this is the increasing graph. This is also the graph y equal to log x base a, but when a is greater than 1, this is an increasing graph. Okay, so at greater x we can get lesser y over here, and at greater x we can get greater y over here. So talking about this particular graph, so first question is quite easy. We simply need to put x equal to 1 by 10 and so on. Log 1 by 10 base 10, log 1 base 10, log 10 base 10. I hope you know these values. Log 100 base 10. Quite easy. Okay, since it is increasing graph, so at x equal to 1 you can get the least value, and at x equal to 100 you can get the greatest value. Since it is increasing graph, at least value you are going to get the least value of the expression, and at greatest value you are going to get the greatest value of the entire expression. So I hope these questions are quite comfortable and easy for you people. Over here also, if you see, 0 is not defined, but if you see, it is minus infinity, and this is going to be log 1 base 10, because I hope you know the graph was coming out to be like this, no? So as x is not 0, but as x approaches 0, the value move towards minus infinity. Okay. Over here also, if you see beta, it is going to be log 1 base 10 till infinity only, because at infinity the logarithm goes, this logarithm goes till infinity only. Yep. Okay, I didn't tell you over here few examples. Whenever base is greater than 1, this is the graph. So this graph will be done for log x base 2. This graph will be drawn for log x base 3. The very same graph will be drawn for log x base 10. This graph will be drawn for y equal to log x base 1 by 2, y equal to log x base 1 by 3, because whenever the base is less than 1, the graph will be drawn like this. So I hope you are clear with this. Okay. So this graph, that means increasing graph. At greater x you're going to get greater y, at lesser x you're going to get lesser y. This is happening in all these options, right? Talking about this now, this is not log x base 10. So you always need to check about this as well. Okay, this is a very important thing. So as I just told you on the previous page, if I call this thing as G and if I draw the graph of this expression G, then the graph will be drawn like this: G equal to x square plus x plus 1. The minimum value is coming at x equal to minus half, and that value is nothing but 3 by 4. Yes or no? So understand that x square plus x plus 1 goes from 3 by 4 till infinity. Number 1. It goes from 3 by 4 till where? It goes from 3 by 4 till infinity for x belonging to real numbers. So talking about this expression, the least value of this expression is going to be log 3 by 4 base 10 till infinity. Yes or no? Okay, talking about this 0 to infinity, if you see 0 to infinity, if x is going from 0 to infinity, then the graph, this particular graph goes from where to where? It goes from 1 to infinity. So x square plus x plus 1 belongs to 1 till infinity for x belonging to 0 to infinity. So in that case, you can see that this particular thing is going from 1 to infinity. So the overall question will be going from log 1 base 10 till log infinity base 10. So it is going to be how much? It is going to be 0 comma infinity, people. Talking about the next thing, I think these things can be quite comfortably written. Over here, this is going to be decreasing. The graph is going to be like this. Yes, so at this x you're going to get the least value, at this x you're going to get the greatest value. So let me write it down over here: log 100 1 by 10 comma log 1 base 1 by 10. Okay, over here also if you do log 10 base 1 by 10 and log 1 by 10 base 1 by 10. Okay, and these are just the values, directly put it over here in the x. So log 1 by 10 base 10 comma log, okay, 1 by 10 only, log 1 base 1 by 10, log 10 base 1 by 10, log 100 base 1 by 10. Clear hai bhai? Okay, talking about this, if you see this decreasing function, it is going to be, so your least value will come at x equal to 1, least value will come at x equal to 1 means this is going to be the thing, and the greatest value will come at x equal to, so this is 0, that will be infinity. Okay, least value will be at x equal to infinity, that is 0, and greatest value will be at x equal to 1, so the expression will be looking something like this. Any issues of whatsoever kind? There has to be none. Talking about this, again we need to take this thing as g. If we draw the graph of g equal to x square plus x plus 1, the graph will be coming out to be like this. So this is the least value, how much? Minus 1 by 2. And it is how much? 3 by 4. So if you see over here in the first part, x square plus x plus 1 belongs to 3 by 4 till infinity for x belonging to all real numbers. So if you see at x equal to infinity, the value of this expression is going to be 0, entire expression, because if this becomes infinite, then the overall expression becomes 0 because it is a decreasing function. And at x equal to 3 by 4, the value is going to be how much? We can get it quite comfortably, right? Log 3 by 4 base 1 by 10, and it will go till where? At infinity it is going to be 0. So it is a decreasing function, so 0 comma this is what we gonna have, right? Okay, similarly over here also, if you see, this value is going from 0 to infinity, that means this value is going from 1 till infinity. So x square plus x plus 1 belongs to 1 से लेकर के infinity for x belonging to 0 to infinity, these values. So the answer is going to be how much? 0 till log 1 base 1 by 10. This is going to be your answer since it is a decreasing function. Okay, yep. Over here all real numbers should be your answer. Over here, if such kind of things do come, how do we find out the range? First of all, we can write down this particular question. I am telling you a method to find out the range. First of all, we write down x in terms of y. So how do we write down x in terms of y? Like this we can write down. So the moment you do this, you're gonna get something like this. Now do just as we do in domain. So in domain we have seen what? The denominator should not be equal to 0. That's it. So y should not be equal to 0. Rest y is every value possible. Okay, talking about this, Over here also we do the same thing. We can write it like this. So x square can be written as 1 by y minus 1. So x square can be written as 1 minus y upon y. So x can be written as what? X can be written as plus minus under root 1 minus y upon y. So just follow the domain thing. Domain thing means whatever is written inside the under root has to be greater than or equal to 0. So if you do this Wavy-Curve method, if you apply, you can get something like this. So your y goes from 0 to 1 only, not including 0 but including 1. This is your answer. So this is the method of finding out range. What's that? First of all, whatever is given to us, write x in terms of y. So look, this was the expression given to me. I have written x in terms of y and I have just applied the domain thing, nothing else. Here also I have done the same thing. Y in terms of x was given to me. I have done nothing but x in terms of y and I have applied the domain thing. Domain means denominator should not be equal to 0. Whatever is written inside the under root should be greater than or equal to 0. That's it. These things, and the range is absolutely clear. Okay, over here also you can apply multiple things as well, but multiple things you guys can apply. You can also write it like this: 1 plus x square minus 2 upon 1 plus x square. So the similar expression can be written as x square minus 1 upon 1 plus x square, and then x can be written in terms of y by multiple methods. You can write it like this as well, taking along x square terms together, and this is what you're gonna get. So x square will be equal to what? It will be equal to 1 plus y upon 1 minus y. So x will be equal to what, bete? Plus minus under root 1 plus y upon 1 minus y. Now just apply the domain thing. So 1 plus y upon 1 minus y should be greater than or equal to 0. If you do the Wavy-Curve method, it is going to be something like this. So the answer has to be between minus 1 to 1. So the answer of this is nothing but minus 1 to 1. Any issues? Both the questions are same. We have just seen this question can also be written like this after taking the LCM. Same questions. Right? So I hope the method of finding out the range is clear to all of you guys. We just need to find out x in terms of y and just apply the domain thing. Just write down x in terms of y. Just find out x in terms of y and write down the domain thing. Your question will be done. Right? Always, always. Okay. This under root x square is nothing but mod of x only. So the range is going to be 0 to infinity. Okay. Okay. X square, sometimes what happens, you can also do this question in multiple methods. Let me tell you. One method is x square is always greater than equal to 0. So x square plus 1 will always be greater than equal to 1. If you take under root here, you need to take under root here. This is nothing but y. Y has to be greater than 1. This is one method of finding out the range. Another method, as I just told you, y square can be written as x square plus 1. Okay, now you can see that y square minus 1 is nothing but equal to x square. So x can be written as what? Plus minus under root y square minus 1. So y square minus 1 has to be greater than or equal to 0, means y square has to be greater than 1, means what? You need to take from here you can do what? You can say that mod of y should be greater than 1. From here you will be having two things, y belonging to minus infinity, say minus 1, including as well, y belonging to minus infinity to minus 1, union 1 to infinity. But you should also see that over here y is nothing but under root of something. That means y has to be positive only. Y can never be negative, because y is equal to under root of something, can never be negative. So you can remove these negative values and ultimately these positive values are your answer. So your range is 1 to infinity. So either you can apply that method, either you can apply that method. Whichever method you are comfortable in, you can apply easily and can get the answer. Over here the answer will be 3 to infinity. Over here if you see how much will be the answer, I hope you can find it. Root x is equal to 1 by y can be written. X can be 1 by y square. So obviously y square should not be equal to 0, means y should not be equal to 0. Also y can never be negative. So the answer has to be this, 0 to infinity. Negative values will be removed because y can never be negative, as it is 1 upon under root of something. Okay, talking about this will go from 0 to 3. How to calculate it? Multiple ways. Again, as I told you, method 1. X square goes from 0, minus x square will be less than 0. If you do 9, so 9 will be added over here as well. So 9 minus x square should be less than or equal to 9. If you apply under root in both the sides, so you're going to get over here like this. This value has to be greater than or equal to 0 only, as it is under root of something, has to go from 0 to 3. This is method 1. Method 2, if you want, let me tell you that as well. Method 2. First of all, you can write it like this, 9 minus x square. So you can see that x square can be written as 9 square minus 9 minus y square. So x can be written as plus minus under root 9 minus y square. So your 9 minus y square has to be greater than or equal to 0. You can apply the Wavekar method or multiple methods. You will get y going from minus 3 to 3. But you know that y can never be negative. That's why y will go from 0 to 3. You can also do this, right? Over here it will go from 0 to infinity, no issues, okay? Because whatever is written inside the under root has to be positive, so x has to be ultimately greater than or equal to 2 only. This is the domain. If this is the domain and if you subtract 2 from both the sides, so you can get x minus 2 greater than or equal to 0 only. If you put under root, this is also under root, this is y, nothing but greater than or equal to 0 only. So the answer has to be 0 to infinity only, people. Yep. So these are another important things that you must know how to solve. If you do cross multiplication over here, you're going to get yx square minus yx plus 1. Assume y as constant, because if you do that, it is going to be 1 minus yx square plus x times 1 plus yx. Okay, over here also this will come. Right? Okay. Over here you always need to make discriminant greater than equal to 0 so that you can find out the range. So it is going to be 1 plus y ka whole square minus 4 times of 1 plus y. Sorry, 1 minus y into 1 minus y is greater than or equal to 0. So ultimately you are having 1 plus y ka whole square minus 2y ka whole square. Feel it? A very important step I have done so that calculation can be minimized. And now you can apply a plus b into a minus b. A plus b times a minus b greater than or equal to 0. Just solve this inequality, you will get your range. This is a very, very, very important method. Whenever quadratic upon quadratic's range you need to find out. Quadratic upon quadratic's range can be find out how? You need to equate, you need to cross multiply, as I have done it. Form a quadratic in x, assuming x as a constant, and you do what? You do discriminant greater than or equal to 0. The moment you solve it, you get such kind of a thing, and from here you will get nothing but the value of y. Okay? Always, whenever quadratic upon quadratic is there, you can follow this method. Okay? There are other multiple methods as well, as I can apply in this particular question. This question can be done by another method as well, because this can be written as 1 plus 1 upon x square plus x plus 1. Now I know that this goes from 3 by 4 to infinity. So I know that x square plus x plus 1 goes from 3 by 4 to infinity. So its reciprocal will go from where to where? Its reciprocal will go from 0 to 4 by 3. Then I need to add 1 to all the three sides. So the answer is coming out to 1 se lekar ke 7 by 3. Orally we can do this. So that can also be done. X square plus x plus 4 will go from 3 by 4 to infinity. So its reciprocal will go from 0 to say 4 by 3. And then add plus 1. You will be able to get to your answer, kids. Okay, 1 is not included, but 7 by 3 is. So this is another method, but this method is not applicable in each and every question. That method is applicable in each and every question. So follow that as well. Okay, kids. Okay, here also same things can be applied. Okay, once you get this, then you can find out the value of modulus as well. So there should be no confusion now in order to solve these questions as well. So I am giving you these questions as part of homework. Now sin x ka value, you know, it goes from minus 1 to 1. 3 sin x will go from minus 3 to 3. If you do plus 3 plus 2 in all the three sides, you will get minus 1 till 5. Okay, yes. You know that 3 sin x plus 2 goes from minus 1 till 5. So the reciprocal of that is going to be what? Is a very, very, very good thing to focus on. Let's do this. 3 sin x plus 2 will go from minus 1 till 5. Okay, its reciprocal will go from where to where is a very good question. So we split it like this. Minus 1, 3 sin x plus 2 is lesser than equal to 0. and 0, 3 sin x plus 2. We split around 0. Why do we split around 0? Is because this is the negative number written and this is the positive number. Whenever this kind of a thing is happening, that one side is negative, one side is positive, and we need to take the reciprocal, then we need to split it around 0. Always do this, okay? If you do the reciprocal of this, it is going to be -1. If you do the reciprocal of this, it is going to be infinity, okay? And that too, positive or negative, it is going to be minus infinity. Why? Because it is 3 sin x plus 2 is always negative only, right? So it is tending towards 0, that too from the negative x-axis, right? So minus tending to -0. So that is minus infinity if you do the reciprocal, okay? So over here it is going to be 1 by 3 sin x plus 2. So the sign of inequality is going to change, okay? Over here at infinity and minus infinity, you do not apply equality symbol, okay? So this is what you're gonna get. Over here, if you do, over here 3 sin x plus 2 is slightly greater than 0, right? Slightly greater than 0 means 1 by, if you do the reciprocal, infinity will come. Over here 1 by 5 will come. Over here 1 by 3 sin x plus 2 will come. And at infinity and minus infinity, no equality is there. So the answer of B part is going to be this as well as this. So this is nothing but your y only. So y goes from 1 by 5 till infinity, and y also goes from minus infinity till -1. So I can write it like this. Y goes from minus infinity till -1 union 1 by 5 till infinity. A very good question this B part is. Talking about the C part, it is quite easy. 3 sin x will go from -1 to 1, -3 to 3. If I add 7 in all these three numbers, what do I get, beta? This is going to be 10, this is going to be 3 sin x plus 7, and this is going to be how much? 4. So this is going from 4 to 10. Over here I don't need to split around 0 in order to take the reciprocal, because both the sides positive numbers are written only. So directly it can be, we can take the reciprocal, right? Directly we can take the reciprocal. So it is going from where to where? 1 by 10 till 1 by 4. Understood? Here we don't need to split around 0, because 0 is not coming in between. Both the sides positive numbers are written. That's why we can directly take the reciprocal. There will be no issue, bacha party. Okay? Yep. Sin x goes from -1 to 1. Sin x goes from -1 to 1. As I told you, 3 to the power x. Yeah, 3 to the power, that is an increasing function. So at least value of power, this expression is going to be least, and at the greatest value of power, this expression is going to be greatest. Yes or no? So the least value is going to be this, and the greatest value is going to be this. We have also seen what is the value of this expression. You can first find it out. At the least value of this expression, the overall value is going to be least. At the greatest value of this expression, the overall expression will be taking its greatest value. I hope you can evaluate it now. There has to be no difficulty at all. We know that fractional part of x goes from 0 to 1, and 3 to the power, at greater power we get greater number, at lesser power we get lesser number. So you can write down the answer of this problem like this quite comfortably. The answer is going to be this, right? At lesser power you get lesser number, at lesser power you get lesser number, at greater power you get greater number, right? That's it. Okay, over here I hope you remember one thing. Whenever a sin theta plus b cos theta is there, this expression goes from minus under root a square plus b square till under root a square plus b square. It's a very, very, very important thing. So this thing, as you can see over here, is following that a sin theta plus b cos theta kind of a thing. So this will go from -5 to 5. Okay, if I want to ask you the modulus of this, then it will always go from 0 to 5 only, as you can see over here. The modulus is always non-negative, that's why. Talking about this, we know that this value is going from 0 to 5. So mod of 3 sin x plus 4 cos x is going from 0 till 5. And if I subtract 2 from all the three sides, we can say that this expression is going from where to where? -2 till 3. Yes or no? Okay, and if I am saying that 3 to the power that, so you know that mod of 3 sin x plus 4 cos x goes from where to where? 0 till 5. So this is an increasing function, 3 to the power anything, yes or no? So at greatest power of x, you're going to get greatest number overall. and at least power you can get least value for this entire expression. So the answer is going to be 3 to the power 0 till 3 to the power 5. This is the answer. Right, over here if you see the range of the function, this is going to be what? It is going to be 0 till infinity. If you talk about this, then x square plus 1 is always greater than or equal to 1 till infinity. So it is going to be 3 till infinity. 3 to the power infinity will again be infinity. Yep, talking about this, x square minus 1, the least value is going to be minus 1 for this, and otherwise infinity, so 3 to the power minus 1 till 3 to the power infinity, it is going to be 1 by 3 till infinity. Over here if you see, the least value of x square plus x plus 1 is 3 by 4, as we have seen earlier as well, if you remember. So the least value of this expression is going to be 3 to the power 3 by 4, and the maximum value is going to be this. So 3 to the power infinity is going to be infinity only. These are some basic graphs. Y equal to root x, y always needs to be positive only, as it is y is equal to under root of x, that's why. Y equal to x will be a straight line like this. Y equal to x square will be this blue shaped figure. This is y equal to x, this is y equal to root x. All of these cuts at x equal to 1 and y equal to 1. Yes or no? Can you guys feel it? Okay. Okay, y equal to x cube is this yellow graph. Y equal to x cube is this yellow graph. Right, as you guys can see it. Okay, I hope you know the linear functions and you know how to draw the graph of straight lines. Y equal to mx plus c or ax plus by plus c is always a straight line. Okay, these two graphs are always a straight line. I hope you know how to draw the graph of any straight line. Yes or no? Yes. Okay, y equal to mod x. I hope victory shaped graph is there. I hope you remember the graph of this. Can we draw the graph of y equal to mod of x minus 2? Yes. It will form a V shape at x equal to 2 kids. This is nothing but the graph of y equal to mod of x minus 2. I hope you people are aware of this. Okay, y equal to x square parabola opening upwards. Y equal to x to the power 4. Out of these graphs, which one is y equal to x square, which one is y equal to x to the power 6, which one is y equal to x to the power 4? Do let me know, people. This is y equal to x square, this one is y equal to x to the power 4, this one is y equal to x to the power 6. Have a look at these graphs, as it is a very, very, very important thing that you have to learn. Talking about this, y equal to x cube looks something like this, y equal to x5, x to the power 5, y equal to x to the power 7, all look something like this only. Do let me know, this yellow graph is for y equal to what? Y equal to x to the power 7. This blue graph is of y equal to x to the power 5. This green graph is for y equal to x to the power 3. You must see y. You must see y. Okay, y equal to root x, as I told you, there has to be no difficulty at all. This is y equal to 1 by x, a rectangular hyperbola. Yes, you must remember this graph. Y equal to 1 by x square, whether x is positive or negative, it is an even function. Look, even functions are symmetric about y-axis. So onto the right of the y-axis, same graphs are getting formed. Yes or no, people? Yes. Exponential functions, as I told you, whenever a is greater than 1, increasing kind of graph is going to form. Whenever a is between 0 to 1, decreasing graph is going to form. Yes or no? Logarithmic function, exponential functions, e to the power x and e to the power minus x. Which one is e to the power x? This one is e to the power x. This one is e to the power minus x, as it can also be written as 1 by e to the whole power x. I hope you are aware. Both intersects at x equal to 0. The value is 0, 1. The point where at which these two graphs intersect. Okay, logarithmic functions, whenever a is greater than 1, increasing function is going to form. Whenever a is between 0 to 1, decreasing function is going to form. So this graph is formed for y equal to log of x to the base 1 by 2, y equal to log of x to the base 1 by 10, and so on. Whenever base is between 0 to 1, this graph is formed. Okay, y equal to ln x. Y equal to ln x means it is log of x to the base e. So e is 2.71, which is greater than 1. That's why the graph will be formed like this. Okay, greatest integer function. I hope you know stairs kind of a graph do come. If you don't know, then you must, because this is a very, 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 this graph is discontinuous at all integers. Yes or no? discontinuous at all integers. Yes, you must know this graph. Okay, fractional part of x, these are all the lines are having slope 1. All the lines have slope 1. Remember these basic graphs. All the lines do have slopes 1 only. Signum, this is the graph. Okay, this is the graph of y equal to sin x. The domain is all real numbers, range is -1 to 1. This is the graph for y equal to cos x. The domain is all real numbers, range is -1 to 1. I hope you remember these graphs. This is the graph of y equal to tan x. The domain is all real numbers excluding odd multiples of pi by 2. And the range is all real numbers, because at odd multiples of pi by 2, cos x becomes 0 and tan x is nothing but sin x upon cos x. So tan x will become undefined at those values. Domain over here is all real numbers excluding n pi, because at x equal to n pi sin x becomes equal to 0. The range is -infinity to -1 union 1 to infinity. Similarly, if you talk about this, the domain is all real numbers excluding 2n plus 1 pi by 2. Okay, the range is what? -infinity to -1 union 1 to infinity. The graphs also you must remember, okay? I hope you remember the graphs well. Okay, cot x, if you see, the domain is all real numbers excluding n pi. All real numbers excluding n pi, n belongs to integer, okay? The range is all real numbers. Okay, so these are some basic figures I have attached for you guys, so that if you want to learn graphs in a dance fashion, you can definitely do that as well, okay? Yep. Okay, let's do this question up. Come on, let's try this everyone, try this. I'll be back in 10 minutes. Try this meanwhile. I'm taking a break of 10 minutes or 10 minutes. I'll be right back. Try this meanwhile, break of 10 minutes. Let's see how many of you get the correct answer. Let's see how many of you get the correct answer. Okay, plot this particular graph. Okay, let's meet at 11:37 again. Okay, let's meet at 11:37 again. It is 11:27 as of now. Let's meet at 11:37 p.m. again. Okay, yep, I'm taking a break for 10 minutes, people. Hello. Yes. All right. Okay, how many of you people have drawn the graph? How many of you people have drawn the graph? How many of you people have drawn the graph? Tell me. Okay. Yes, I think I'm audible. Let me check. Yes. Have you guys tried drawing the graph? Okay. So first of all, we can draw the graph of y equal to x square. The graph will be coming out to be like this. Then we can draw the graph of y equal to x square minus 1. The graph can be drawn like this. Then we can draw the graph of y equal to mod of x square minus 1. The graph can be drawn like this. Okay. This is nothing but 0 comma minus 1. Yep. So this point will now become 0 comma 1. This point was earlier minus 1 comma 0 and this one was 1 comma 0 because y will be equal to y will be equal to 0 at x equal to 1 and x equal to minus 1. So these points will remain same. Okay. Then if you draw minus 1 of this once again, so y equal to x square minus 1 if its graph if you want to draw. So the graph will be coming out to be how? The graph will be coming out to be something like this. Yes, this point will now become 0 comma 0 because ultimately you have to go 1 unit down because of this minus 1. So 0 comma 1 will come to 0 comma 0. This point will be minus 1 comma 1. This point will be 1 comma minus 1. Okay. And if its modulus you need to take again so that ultimately you get the graph of this. So what you do is you remove the graph which is coming below x-axis and you take its mirror image. So ultimately the graph is coming out to be how? The graph is coming out to be this particular thing. Yes or no? Yes. This is how the graph will be looking like. So this and this is how the graph will be looking like. So this point is going to be 1 comma 1. This point is going to be minus 1 comma 1. So ultimately this green graph will be of the desired question. Yes, you got the graph, people? Very, very, very important one. So that is what I have shown, y equal to x square minus 1. Then this one, and this is how the graph was coming ultimately. Yes, absolutely. Okay. Okay, the beauty of this graph is this point was 1 comma 1, this one, sorry, minus 1 comma 1. This point was 1 comma 1. Now listen, if I take any value of y between 0 to 1, that means in between this range, the number of solutions that I am going to get is how much? 1, 2, 3, 4, 5, 6. If I take any value between 0 to 1 over here, between 0 to 1, I am going to get 6 solutions for this equation. If I take any value greater than 1, I am going to get 2 solutions. Yes or no? If I take any value less than 0, I am going to get 0 solution for this particular equation. This needs to be clear. So this is what I have done. Transformation of graphs. I am telling you a few quick things over here. Y equal to f of x. If the graph you know and c is always you are taking as positive only. So if you want to draw the graph of this, then ultimately what is happening is y needs to be replaced by y minus c. So over here what will happen is that you need to shift graph up by c units. Over here you need to replace y by y minus c. If you replace y by y minus c, y plus c, sorry. If you replace y by y plus c, this expression will become nothing but y equal to f of x minus c. So here shift graph down by c units. If you replace this x by x plus c, you get this expression. So over here you do what? Shift left by c units. And if you want to get this, so here you need to replace x by x minus c. I'm taking c as positive only, okay? So shift right by c units. If you replace here x by minus x, reflection about y axis you need to take, reflection about y axis, so that you can get the graph of y equal to f of minus x. If c is greater than 0, then here are two cases: if c is greater than 1 and if c is between 0 to 1. If c is greater than 1, then stretch graph along y-axis, and if c is between 0 to 1, then you need to compress graph along y-axis. And here also two things can happen, that if c is greater than 1 and c is between 0 to 1. If c is between 0 to 1, तो stretch करना है along x-axis. And if c is greater than 1, then compress along x-axis. Okay. So these are for transformation of graphs. I have taken a separate lecture on this particular thing a few days back. You can definitely watch that as well. Okay. Composition of functions is what we're gonna study now. If you have been given two functions, f of x and g of x, then you can get these four functions: fog, fof, gog and gof quite comfortably. Let me tell you how we're gonna get it. In the g function, if we are putting x, ultimately we are getting g of x, and if we are putting this g of x in f, what we get is nothing but fog of x. I think these are quite easy things. You are already aware of this. Okay. So let me take you directly to the question solving only. If f of x is equal to cos x and g of x is equal to 2x, and I need to find out fog, that is f of g of x. So what I need to do is, in place of this x, I need to put g of x. So here also I will put g of x. So ultimately it is going to be cos of g of x. Now cos of g of x is going to be how much? Cos of 2x. Okay, if I need to find out gof of x, so gof of x means g of f of x. So here in the place of this x, ultimately we need to put f of x. So here also we will put f of x, means twice of f of x. Now f of x is how much? Yeah. So fog and gof are two different things. Talking about the second one, the fog is going to be how much? Tell me people directly. It is going to be cos of sin x. And what is going to be gof, people? It is going to be sin of cos x, right? Yes. All right. Moving on to the next thing, people. If f of x is this, and I need to find out f of x. So first we can find out f of x. So it is going to be f of x minus 3 upon f of x plus 1. So it is going to be x minus 3 upon x plus 1 minus 3 upon x minus 3 upon x plus 1 plus 1. So if you take the LCM, it is going to be x plus 1 x minus 3 times minus 3 x plus 1 upon x minus 3 plus x plus 1 upon x plus 1. So x plus 1 cancelled. Over here what you get is nothing but minus 2x, and over here is minus 6. Over here is 2x minus 2. So you can see that x can be cancelled. So minus x minus 3 upon x minus 1 is what you get, and over here x plus 3 upon 1 minus x. Okay, this is f of x. Now if I tell you to write down f of x, how much it is going to be? Ultimately you should take this value and put in place of this. So if you take this up, how much it is going to be? X plus 3 upon 1 minus x minus 3 upon x plus 3 upon 1 minus x plus 1. How much is this value coming? Let's check it out. X plus 3 minus 3 plus 3x divided by x plus 3 plus 1 minus x. x and x cancelled, 4 is coming over here, 3 and 3 cancelled, so 4x upon 4 means x is coming. So the answer is going to be what? The answer is going to be option A. Any issues of whatsoever kind, do let me know beta. There has to be no issue. Okay, talking about f of g of x, if I'm talking about f of g of x, so here in place of this I need to put g of x, so g of x here as well as g of x here. So ultimately it is going to be how much? X to the power 2x divided by x to the power 2x. X to the power 2x, sorry. Right, this is what we're going to get. Now you can write down this particular thing as 2x into x to the power 2x. So ultimately it is going to be what? Ultimately it is going to be x 2 into x ki power 2x plus 1. Yes or no? Yes, so this has to be your answer. This one, D for Delhi, is going to be your correct answer. Yep. Okay. Fog of 3 is asked, means can we first find out g of 3? G of 3 will be, we can find out g of 3 by using this definition, right? So g of 3 will be how much? G of 3 will be how much? 10. So f of 10 it will become, f of 10 we will write down by this definition. So it is going to be how much? No, not by this definition, sorry. Wait a minute. Okay, this has to be, there is some sign should be like this. Okay, yes, so we will write down f of 10 by using that definition. So 5 minus 10, that is minus 5 will come. So this is first part. Second part, f of g of minus 1. So first we need to find out g of minus 1. G of minus 1 will be written by this particular thing. So g of minus 1 will be nothing but 1 only, right? Okay, so f of 1 will be written by this, that is 1 minus 1, that is equal to 0. Third, if I ask you what is f of g of 2, so g of 2 will be written by this particular thing. So f of 7 it is asking, f of 7 will be written by this particular thing, that is 5 minus 7 equal to minus 2. Fourth one, f of g of 3 plus means slightly greater than 3. So this definition will be used. So this is going to be f of slightly greater than 10 plus. So that definition will be used. It will be nothing but equal to minus 5 only. I hope you guys are clear with these values. And similarly, you guys can do these things as well. Similarly, you guys can do these values as well. There has to be no difficulty at all. Okay. Do try this question as well at homework as homework. Okay. This is a good question. Okay. Moving ahead. Inverse. If fog of x, gof of x are both coming equal to x, then we say that f and g are inverse of each other. What am I saying? If fog and gof are both coming equal to x, then we say that f and g are inverse of each other. Okay. Yes, so that is what you need to understand. There is an important variety of question that f of x is given to us and it says find out its inverse. This is a process, two-step process. First we replace x with y and then y with x, okay, and then we write down y in terms of x, that is nothing but the value of f inverse of x. Let's say we take this question. So let's say this is given to us and the question is asking us to write down what? The question is asking us to write down its inverse function. So first step 1 is we replace x with y and y with x. So what we're gonna get is nothing but this. Okay, then we need to write down the value of y in terms of x. Okay, so we can write down this particular thing as 1 by 8 to the power 2y. This also is 1 by 8 to the whole power 2y. So ultimately it will become something like this: 8 to the power 4y plus minus 1 upon 8 to the power 4y plus 1. Cross multiplying it, we can write it as x to the power this plus x equal to 8 to the power 4y minus 1. Okay, we can take this 8 to the power 4y terms together. Okay, and then it is going to be x plus 1 upon how much? 1 minus x. Okay, now here what we can do is we can take log to the base 2 both the sides. So log of 8 to the power 4y to the base 2, if you do, it is going to be log of 1 plus x upon 1 minus x to the base 2. Now this 4y will come in front. So this is going to be how much? 4y times 3 is equal to log of 1 plus x upon 1 minus x to the base 2. And also you can do one thing, this has to be base 8. I think there is some typing error in this problem as far as I remember. Yes, if I take base as 8, let's say, then it is going to be how much? 4y equal to log of 1 plus x upon 1 minus x to the base 8. So it is going to be y equal to 1 by 4y log of 1 plus x upon 1 minus x to the base 8. So this has to be the answer. So these are all 8 in the base. Okay, these are all 8 in the base. So it is going to be 1 by 4 log 1 plus x upon 1 minus x. So option A is the correct answer. All right. Two-step process. Step 1 is write x in place of y and y in place of x, and step 2 is write y in terms of x. That's it. This is how we get the inverse of any function, kids. Okay. Identify those values of which for which the function is the inverse of itself. If you write down the inverse of this, if you want to write down the inverse of this, first you have to do what? Replace y with x and x with y. Okay, so y is coming out to be how much? Y is coming out to be x plus 2 upon a. So it is nothing but x by a plus 2 by a. So it is saying that the function is inverse of itself. That means both of these things has to be equal. That means the coefficient of x in both of these equations has to be same. That means a has to be equal to 1 by a, and also constant terms needs to be equal. So over here a is nothing but equal to minus 1. Over here a is equals to plus minus 1. So we have to take the common values. Therefore a is equal to minus 1 has to be the answer, because a is equal to minus 1 is that value for which the inverse of this function will be coming out to be equal to itself only. Put x equal to minus 1. Sorry, a is equal to minus 1. It is going to be minus x minus 2. This is also minus x minus 2. So function is coming equal to inverse whenever a is equal to minus 2. That's why we say that the answer is a is equal to minus 2. Okay. Alright, so a function is invertible only when it is 1 1 as well as on 2, right? Otherwise the inverse cannot be written, or we can say it is bijective. Inverse of a function is unique. Let's do this question. Y is equal to 2 to the power x times of x minus 1 is given, and we need to find out its inverse. So how we can find out its inverse is taking log to the base 2 both the sides. It is going to be x times x minus 1. Okay, now it is a quadratic in x, isn't it? So we can assume y as a constant, and we're gonna do what? We're gonna do discriminant greater than or equal to 0. So 1 plus 4 into, so how can we write down the roots of this equation? We can write down, because ultimately our agenda was to write down x in terms of y, y in terms of x, yes or no? So what you can do is you can first replace, if you want to find out the inverse, step 1 is x equal to 2 to the power y minus 1. Then taking log both the sides, it is going to be log x base 2 is equals to log of 2 to the power y minus 1 to the base 2. This thing will come in front. So you can say that y square minus y minus log x base 2 equal to 0. Now this is a quadratic in y. Assuming x is constant, we can write down the roots. 1 plus minus under root 1 plus 4 into a into c by 2a, right? So there are two inverse comings, but inverse of a function is unique. So you have to see what? You have to see it that your range, and if you see f inverse x will also go from 1 to infinity to 1 to infinity. So if you take any one value, I think if you need to ignore this minus sign, because if you don't ignore this minus sign, then your range will not be in the desired expression. So this is rejected, because your range should also always come into 1 to infinity range thing only. So if you, let's say, take any of the value, let's say x equal to 2, if you take x equal to 2, then y's value will not be coming between 1 to infinity whenever minus sign you are taking. So that minus sign wala thing is rejected. Ultimately your answer will be what? 1 plus under root 1 plus 4 log x base 2 divided by 2. That is option B for Bombay is going to be the correct answer. Okay? Yes. Because inverse of a function is unique. If a comma b is lying on the graph y equal to f of x, then b comma a will be lying on the graph y equal to f inverse of x. This can be used in objective tricks quite a lot. Okay, yes, because these two functions are inverse of each other. Look, if 1 comma 2 is lying on this, then 2 comma 1 will be lying on this. Look, you'll see if 2 comma 3 is lying on this, then 3 comma 2 will be lying on this, because these two functions are inverse of each other. That's why. Okay, yes, okay. Y equal to e to the power x and y equal to ln x are inverse functions of each other, so their graphs are symmetric about the line y equal to x. Always remember this. The graph of inverse functions are symmetric about the line y equal to x. Y equal to x square and y equal to root x, these are inverse functions of each other. Look, their graphs are symmetric about the line y equal to x. Inverse functions graph are symmetric about y equal to x line. Okay, yep. Okay, even functions, if f of x is equal to f of minus x, then we say that this function is nothing but even function. Even functions are symmetric about y axis. Even functions are symmetric about y axis. Achha, what do we understand when we say that symmetric about y axis? It means that if a comma b is lying on the graph, then minus a comma b will also lies on the same graph. This is what the meaning of symmetric about y axis. Okay. Okay, odd functions, if f of x is equal to nothing but minus times of f of minus x, then we say that the function is nothing but odd functions. Odd functions are symmetric about origin. They are symmetric about origin. They are not symmetric about x-axis. They are symmetric about origin. What is the meaning of symmetric about origin? If a comma b is lying on the graph, then minus a comma minus b will also lie on the graph. Minus a comma minus b will also lie on the graph. Now a function can neither be even nor be odd, like this function is neither even nor odd. It is not necessary for a function to be either even or odd. It can also be neither even nor odd. Okay, yes, you have to check out whether this function is even or odd. So you need to calculate f of minus x. If you do that, you need to replace x by minus x. So minus x ka whole square will also be x square only, and over here this will come. Now if you add these two, 1 plus 2, if you do equation 1 plus 2, if you do on the left hand side f of x plus f of minus x equal to on the right hand side ln a plus ln b wala property you guys can apply. So it is going to be x square plus 1 minus x square only, so it is going to be ln 1, that is equal to 0. So f of x is coming out to be minus times of f of minus x. That means the function is going to be nothing but odd, right? Okay, properties of even and odd functions. Even plus even is always a even function. Even plus odd is neither even nor odd, right? Odd function plus even function is neither even nor odd. I am talking about functions, not numbers. Okay, odd function plus odd function is always an odd function. Similarly, even function minus even function is always an even function. Even function minus even is neither even nor odd. Odd function minus even function is neither even nor odd. Odd minus odd function is odd only. The only function which is defined on the entire number line and is even and odd at the same time is nothing but f of x equal to 0. Must remember this particular thing. Even into even function is always even function. Even into odd function is always odd function. Odd into even is always odd function. Odd into odd is always even function. You must remember this as well. And this happens in division as well. Okay. The square of an even or an odd function is always even function. If a square of an even or odd function is written, it will always be an even function only. Okay, let's observe that, okay, this is nothing but, if we write down our function like this, then this is nothing but even function and this is nothing but odd function. So any function can be written as the sum of even and odd functions. Okay, so this is also one such thing. Periodic function means if f of x plus t is equal to f of x for all values of x, then t is nothing but a period. Okay, just say f of x, if you see sine of x plus 2 pi, it will be equal to sine x only. If you see sine of x plus 4 pi, it will be equal to sine x only. If you see sine of x plus 6 pi, it will be equal to sine x only. So 2 pi, 4 pi, 6 pi and so on, these are nothing but period of sine x only. The least period is known as fundamental period, and that is nothing but 2 pi in the case of sine x. For the case of tan x, if you see tan of x plus pi is equal to tan x always. Tan of x plus 2 pi is also equal to tan x only. Tan of x plus 3 pi is also equal to tan x only. So here pi, 2 pi, 3 pi are all periods of tan x, and the fundamental period, the least value is pi. Okay, all right. If I ask you as I told you earlier as well. Okay, this is a very important thing, that if the graph of f of x equal to a sin x represents after an interval of 2 pi, repeats after an interval of 2 pi, so this is periodic with period 2 pi. Okay, yes, I hope you guys already know this. Graph of tan x repeats after pi interval, that's why its fundamental period is pi. Okay, now a very important slide as far as period is concerned. Whenever sine to the power, cos to the power, sec to the power, cosec to the power, if even number is written, then the fundamental period is going to be pi. If odd number is written, then the fundamental period is going to be 2 pi. In tan x and cot x, it does not matter whether the power is odd or even, ultimately the fundamental period is always going to be pi only. That means if I ask you what is the period of sine cube x, then we know that n is odd in that case, so the period is going to be 2 pi. If I ask you what is the period of sec to the power 100x, 100 is even, that's why the period is going to be pi. I hope you guys are clear with this. Mod of any trigonometric ratio is having a period equal to pi only. Okay. Fraction part of x has a period 1. Algebraic functions are not at all periodic. Constant function is periodic, but its fundamental period cannot be defined. Okay. A function may or may not be periodic, like this is an algebraic function, this is not a periodic function, this is also not a periodic function, this is also not a periodic function. A lot of guys feel that greatest integers graph is also periodic, but let me tell you, this is not a periodic function. Okay. Yep. If you know that f of x has a fundamental period t, if you know that f of x has a fundamental period p and t, and you have been asked to find out the fundamental period of a times f of dx plus b plus minus c, then the fundamental period is going to be nothing but t divided by modulus of d, that is the coefficient of x is what by which you have to divide the earlier time period. This is a very important thing. If I ask you what is the period of this particular thing, okay, yeah, so you know that the period of sin x is what, 2 pi, so simply divide that 2 pi with the coefficient of x, that's it. So 2 pi by 3 is the fundamental period of this thing. Okay, yep. Every constant function is always periodic, but with no fundamental period, as have been told earlier as well. Okay. If let's say two functions are given and their addition or subtraction has been done, then the resultant, let's say this is having a fundamental period t1 and this one is having fundamental period t2, then we need to calculate LCM of t1 and t2, that will be nothing but the period of h of x. Okay, it need not be a fundamental period, you should also remember this. LCM of fractions, how do we take the LCM of fractions? We take the HCF of denominators and we take the LCM of numerators, that is going to be nothing but LCM of fractions. Okay, I hope you know this. LCM of irrational with irrational is only possible, irrational with irrational is possible, but LCM of two irrational number of different kind does not exist. Yes, like if I ask you the LCM of pi and 2 pi, it is going to be nothing but 2 pi because the irrational numbers are of same kind. But if I ask you LCM of root 2 and root 3, so these are not of same kind, so LCM does not exist. Okay, like I have written over here as well. LCM of a rational and irrational number never exists. Whenever we have complementary functions like sine and cos, tan and cot, sec and cosec together with modulus or having same even powers, then the fundamental period will be half of the value we got from previously learnt method. Let me talk about this. If I ask you the fundamental period of this, it was pi, so LCM of pi and pi will be pi, but the answer over here is not pi. The fundamental period will be rather pi by 2. Why? Because complementary functions tan and cot have been written by using modulus, so whenever this happens, so the method says pi should be the answer, but we need to divide it by 2 as well. So the fundamental period over here is going to be pi by 2. Over here also, if you see, this will be having period pi, this will be having period pi. So the answer will be what? The fundamental period in this case will be, we need to multiply or divide it by 2. Because same even powers are there. Same even powers are there on the complementary functions. So whenever complementary functions are there, in which two things can be there, either with the modulus or with same even powers. Like over here, sine and tan and cot are coming with modulus, or also you can see over here secant, cosec are coming complementary functions with same even powers. So you need to divide by 2 so that you get the fundamental period. Okay. All right. So we guys are done with one of the chapter, sets, relations and functions, and in which we have done so many things. I hope you guys are clear with what we have learnt so far. Moving on to this thing quickly, iota is nothing but equal to under root of -1, iota square is -1, iota cube is minus iota, iota to the power 4 is 1. Okay, and by the usage of this, we can write down that iota to the power 1 is equal to iota to the power 5, iota to the power 9 is equal to iota to the power 13, and so on, is equal to iota to the power 4k plus 1. These are all equal to iota only. If I talk about this, iota to the power 2, iota to the power 6, iota to the power 10, iota to the power 14, iota to the power 18, and so on, these are all equal to iota to the power 4k plus 2, where k is an integer. Okay, iota to the power 3 is equal to iota to the power 7 is equal to iota to the power 11 is equal to iota to the power 15, and so on. These are all equal to iota to the power 4k plus 3, where k is an integer. Iota to the power 4 is equal to iota to the power 8 is equal to iota to the power 12 is equal to iota to the power 16. These are all equal to iota to the power 4k only. This is equal to iota, this is equal to -1, this is equal to minus iota, this is equal to 1. You must remember this particular thing, as it is very important. The sum of 4 consecutive powers of iota is always equal to 1. Iota to the power k plus iota to the power k plus 1 plus iota to the power k plus 2 plus iota to the power k plus 2 k plus 3 is always equal to 0, where k is an integer. Okay. Reciprocal of 1 by iota is nothing but minus iota, because 1 by iota, if you do iota and iota over here, it will become iota square over here iota upon -1, that is equal to minus iota will come. Okay. Yep. Okay, so that is what I have just explained you. Okay, can we simplify this? It is nothing but iota to the power 4k, so its value is nothing but equal to 1. Over here it is iota to the power 3. Look, 2012 is divisible by 4, so this is equal to minus iota only. Yes or no, people? Yes. Okay, equality of two complex numbers. As if let's say z1 is a plus ib and z2 is equal to c plus id, where a, b, c, d are real numbers. This is a very important thing. If these two complex numbers are equal, then their real parts has to be equal and their imaginary parts has to be equal. Okay, then only the two complex numbers will be equal. There is no inequality in case of complex numbers. Inequality is not defined in case of complex numbers. Geometrical representation of complex numbers, the point which is in Cartesian plane x comma y, that point in complex plane is represented by x plus iy. You know how to plot 2 comma 3 in the Cartesian plane. That very same point is nothing but 2 plus 3i in the Cartesian, in the Argand plane or in the complex plane. Okay. Yep. So modulus of a complex number is what? The distance between 0 and that complex number. 0 is what? 0 comma 0. Yeah, 0 plus 0i. X comma y is nothing but x plus iy. So the distance between these 2 points x comma y and 0 comma 0 is nothing but the modulus of this complex number, right? Okay, so that is what written over here, the modulus. So modulus of z is nothing but real part of z ka whole square plus imaginary part of z ka whole square, right? Okay. Let's talk about a few properties of conjugate. Z plus z bar. Z bar, how do we get z bar? Replace iota by minus iota. Replace iota by minus iota in z. If you replace iota by minus iota in z, you get nothing but z bar. If you do z plus z bar, it is going to be always equal to twice of real part of z. If it is given to you in problem that your number is purely imaginary, then its real part has to be equal to 0. So in that case, z plus z bar has to be what? Z plus z bar has to be equal to 0. Z minus z bar is always equal to 2 iota y, that is equal to 2 iota imaginary part of z. If it is given to you that your number is purely real, if my number is purely real, then the imaginary part of z will be equal to 0. So for that case, z will always be equal to z bar. Z into z bar is always equal to mod z square. Z into z bar is always equal to mod z square, and it will be equal to real part of z ka whole square plus imaginary part of z ka whole square. Whenever you see mod z and you can feel that it can be squared, so this property will be used. It is a very important property. If z is real, then imaginary part will be equal to 0, means z will be equal to z bar. So that is what written. If z is purely imaginary, then real part will be equal to 0. In that case, z plus z bar will be equal to 0, that is z is equal to minus z bar. Okay, yes. In conjugate can be splitted about plus. Look, the bars have been splitted about minus, about multiplication, about division. The conjugate can be splitted in all the four cases: plus, minus, multiplication, divide. Okay, a conjugate is nothing but the very complex, same complex number that only. It's just like complement is nothing but that particular set only. Okay, yep. Okay, the modulus of z bar and modulus of z are both equal. Okay, yes, we will talk about these two a bit later. Okay, modulus of a complex number, we have just seen the distance between x comma y and 0 comma 0 is nothing but the modulus of the complex number, z is equal to x plus iy. Okay, properties of modulus: if mod z is equal to 0 given to us, then answer has to be z is equal to 0 only. 0 is the only complex number whose modulus is equal to 0. The modulus of z bar and z is nothing but equal only, because if z is equal to x plus iy, then z bar is going to be x comma x minus iy. That means if z is x comma y, then z bar is ultimately going to be what? X comma minus y. So their distances from origin has to be same. So that's why this particular thing. Modulus can be splitted whenever multiplication between two complex numbers is written and division is written. So modulus can be splitted only when multiplication and division is there. Otherwise the modulus cannot be splitted. Okay, yes, this is the property as I told you on the previous page, and also here the same thing, that z into z into z into z n times is there. Then you can write down mod z into mod z into mod z into mod z n times. So it is nothing but equal to mod z to the power n people. Yes. Principal argument. Now steps to find out principal argument. First of all, let me tell you what exactly is argument. If let's say a complex number z is equal to x plus iota y is plotted over here. Now this is x comma y, or we can say x plus iy. This is origin. Now this will be forming some angle with the positive direction of the x-axis. Yes. So let's call it as theta. This theta is nothing but the principal. This theta is nothing but argument of the complex number z. I hope you understood. Now principal argument goes from minus pi to pi. Principal argument goes from minus pi to pi. First, we calculate the value of theta, that is equal to tan inverse mod of y by x. If the complex number lies in the first quadrant, the argument is theta itself. If the complex number lies in the second quadrant, the argument is pi minus theta. If the complex number lies in the complex number third quadrant, then it is minus pi plus theta. And if the complex number lies in the fourth quadrant, then the argument is nothing but minus theta. Okay? Yes, this is minus pi plus theta and this is minus theta. Yeah. Argument follows the property of logarithm. Look, this m can be taken in front, this thing will become. Only you just add this one so that the value can be brought into principal argument. Log ab is log a plus log b. Look, similar property is being followed. Log a by b is equal to log a minus log b. Same property is being followed. So logarithm follows the property of, so argument follows the property of logarithm. Okay. Alright. Mod of z1 plus z2 is always greater than equal to mod of z1 minus mod of z2, and this is always lesser than or equal to mod of z1 plus mod of z2. This is the most important thing that you have to remember. This is the very, very, very important thing that you have to remember. If you remember this much, your work is done. By the way, the same thing happens in the vectors as well, because I hope you remember the magnitude of a plus b ka vector is greater than mod a minus mod b and is lesser than or equal to mod a plus mod b. Yes or no? If the vectors are in same direction, then only their summation is maximum. Yes or no? Yep. Okay, cube roots of unity. If z cube is equal to 1 is given, then 3 roots you get. Z is equal to 1, z is equal to omega, z is equal to omega square. Okay? Yes. What is the value of omega? Omega is nothing but minus 1 by 2 plus iota root 3 by 2. And its square also, or omega bar. These are both same. Its conjugate is also omega square only, and that will be equal to minus 1 by 2 minus iota root 3 by 2. You must remember this. Also, let me tell you, z square plus z plus 1 is equal to 0. This equation do have two roots, omega and omega square. Whereas if the equation is written like this, z square minus z plus 1 equal to 0, this equation do have two roots, minus omega and minus omega square. You must remember this important thing as well. Okay, cube roots of unity. I think this is not at all difficult. You are already aware of this. No issues. Let's talk about the properties of cube roots of unity. Omega cube is nothing but equal to 1. 1 plus omega square is nothing but equal to 0. Omega to the power 4 is omega. Omega square is nothing but 1 by omega, because if you multiply omega square over here, in the denominator it will be omega cube, and omega cube is nothing but equal to 1 only. Omega and omega square are conjugates of each other as well. Right? Okay. Omega and omega square are the roots of this equation. Z square plus Z plus 1 can be written like this, because omega and omega square are its roots. That's why. Minus omega and minus omega square are roots of this equation. So this equation can be written as Z plus omega into Z plus omega square. Again, an important thing. Z cube minus 1 can further be factorized into this, and Z cube plus 1 can be factorized like this, as have been conveyed. Because Z cube minus 1 can be written as Z minus 1 times Z square. Z square plus Z plus 1. So this can further be factorized into Z plus omega into, Z minus omega into Z minus omega square. That's why. Okay. The magnitude of omega, the magnitude of omega square are both equal to 1. What is the argument of omega? The argument of omega is 2 pi by 3. The argument of omega square is equal to 4 pi by 3. Okay, 1 omega and omega square also forms a geometric progression. They form a GP, isn't it, everyone? Yes, okay. 1 omega and omega square, if you see this, these are the vertices of an equilateral triangle whose centroid is at origin and the side length is nothing but root 3. Because this is 1, 0, the coordinates of this point are going to be what, bete? The coordinates of this point are going to be minus 1 by 2. Minus root 3 by 2, plus root 3 by 2, and over here if you do, it is minus 1 by 2 minus root 3 by 2. So the side length is nothing but root 3 by 2 into 2, so that is equal to root 3, right? And the centroid, if you see, is nothing but at the origin. And also for an equilateral triangle, centroid, orthocenter, circumcenter, centroid, orthocenter, circumcenter, incenter are all same point only. Okay? And that too here in this case at origin. Equation of circle in complex plane, if you see, then mod of z minus z naught is equals to r, whose radius is r and center being z naught. Okay, so points lying on the circle. If something like this is written, then z lies inside the circle. If something like this is written, then z lies inside and on the circle. If something like this is written, then z lies outside the circle. And if something like this is written, on or outside the circle. I hope you people are already clear with this, because let me tell you this thing, that mod of z minus z1 is nothing but distance between complex number z1 and z and z1. You must remember this, that mod of z minus z1 is nothing but distance between z and z1. Rotation theorem not required in JEE mains. In JEE Advanced it is there, so we will talk about this. If you want to remember, you can definitely remember this as well. Okay, yes. The area of the triangle with vertices, this is iota z. Okay, this is iota z. Yep. So can we solve this particular question? Let me tell you one very important thing, that z, iota z and z plus iota z, these are vertices of right angled triangle. You must know, these are vertices of right angled triangle. These are vertices of right angled triangle. So now you can find out the now I think you can find out the answer quite comfortably. There has to be no issue at all. There should not be any issue now. Right? So I think you can solve it now, or this question can be solved in multiple ways. This question can be solved in multiple ways. Okay, there yes, so if this is z plus iota z, this is z and this is iota z. So this distance is how much? Mod of z. This distance is how much? Mod of iota z. By the way, mod of iota z can be written as mod of iota into mod of z. Mod of iota is nothing but 1 into this only, so this is mod of z only. So if this is the right angle triangle, half into base into height, that means half into mod z into mod z will be your answer. Understood? Understood everyone? Yeah. Okay, I hope you guys are clear with this. The correct answer is coming out to this. By the way, this was asked in JEE Mains 2021. Okay. Equation of a straight line, you must know that the straight line can be written like this: a bar z plus az bar plus b is equal to 0, where a is a complex number and b is the real number. Okay, must remember these things. A bar z plus az bar plus b equal to 0, where a is a complex number and b is a real number. All right. Okay. These are the things which will be used quite fluently in JEE advanced questions, not in JEE mains. So I am skipping this portion as of now. Okay, this is a part of conic sections, so this will come back again in conic sections as well, so no need to worry. Okay. Okay, talking about sequence and series, let's take up the topic sequence and series. If it is asking me the sum of the first term, then it is nothing but T1, that is first term only. If it is asking me sum of first two terms, then it will be T1 plus T2. If it is asking me sum of first three terms, then it will be T1 plus T2 plus T3. If it is asking me sum of first four terms, then it will be T1 plus T2 plus T3 plus T4. If I want to find out nth term, then I can find it out by Sn minus Sn minus 1. Sn minus Sn minus 1, I can find out the nth term. This is a very important thing. Two things we're going to talk about: arithmetic progression and geometric progression. A plus D, A plus 2D, A plus 3D, and so on. AR square, AR cube, and so on. So over here a same thing, D is getting added again and again and again. It can be positive or negative. Over here a same number is being multiplied again and again and again. Okay. If I talk about nth term over here, then it is going to be A plus n minus 1 into D. If I talk about the nth term, then it is going to be A into r to the power n minus 1. Okay. Alright, this is the thing. An AP is dependent upon A and D only. A GP is dependent upon A and R only. Also, if you want to find out the sum of n terms of the GP, it is going to be n by 2, 2A plus n minus 1 into D. Or you can also say that sum of n terms of the AP is nothing but first term plus last term by 2. Sum of n terms of the GP is nothing but A times 1 minus r to the power n upon 1 minus r. This is true for any common ratio, but let me tell you, for r being mod of r being less than 1, the S infinity, sum of infinite terms, is nothing but A upon 1 minus r as well. Okay. So you must remember these things of AP and GP. Okay, moving ahead. If A1, A2, A3, these are few of the terms given to you in an AP, then if you add same number to each and every term, still the new thing is going to remain in an AP with the same common difference. If you subtract each and every term from each and every term minus k, then also it is going to be AP with the same common difference. If you multiply each and every term with the same number k, let's say, then this time common difference will also be multiplied by k, and if you divide each term by k, then the common ratio will also be divided by k, but it will still remain an AP only. Let's say if two APs are given to me, A1, A2, A3, B1, B2, B3, then if I add corresponding terms, A1 with B1, A2 with B2, A3 with B3, and so on, then the new series A1 plus B1, A2 plus B2, A3 plus B3 will again be forming an AP with the common difference as the sum of this and this APs. Similarly, if you subtract the corresponding terms, then also A1 minus B1, A2 minus B2, A3 minus B3 are going to form an AP only. In an AP, a very beautiful thing happens, that first term plus last term will be equal to second term plus second last term equal to third term plus third last term, and so on, beta. Example, find the first 5 terms of an AP if the third term is 4. If the third term is 4, then first term plus fifth term will be equal to second term plus fourth term will be equal to third term from the beginning and third term from the end. So it is going to be 4 plus 4, that is equal to 8. Okay, and what I need to find out is T1 plus T2 plus T3 plus T4 plus T5. Okay, so this value is nothing but 8. This value is also nothing but 8, and the value of T4 is nothing but 4. So what is the answer? 4 plus 8 plus 8, that is equal to 20. The answer is not 24, the answer is 20. Have a look at this, kids. Yes, the third term from the beginning is also 3, and the third term from the end is also 3. That's why T3 plus T3 will be equal to T1 plus T5 is equal to T2 plus T4. If A, B and C are in AP, then 2B is equal to A plus C. That is middle wale ka double is equals to sum of the rest 2. In a series, if S is a quadratic function of n, if sum is a quadratic function of n, or nth term is a linear function of n, then we say that the series is nothing but an AP. Because you know, nth term of the AP was written like this, a plus n minus 1 into d, so it is linear in n. Also, sum of n terms of an AP, if you see n by 2 times 2a plus n minus 1 into d, so that is that is a quadratic in n. So accordingly we can derive this particular thing. If d is greater than 0, we say that the AP is increasing. If d is less than 0, we say that the AP is decreasing. If d is equal to 0, we say that all the terms are same. If an AP having m terms are written, then the nth term from the end will be nothing but n minus n plus 1th term from the beginning. It's a very important. If an AP is having m terms, then nth term from the end is nothing but m minus n plus 1th term from the beginning. It's a very important thing. Again I'm saying, if you add this n with this particular thing, you are getting m plus 1. Why? Because that same number is getting added twice, is being counted twice. Let's say I say that 6 persons are standing in a row. Which person is standing at the 4th position from the front? So its position from the front is 4, and from the end its position is 3rd, isn't it? So if you add 4 plus 3, you are getting 7. Why? Because you are adding this, you are counting this person twice. That's why you are getting one more number. So so let's say a person from the end is at nth position. It has to be from the front m minus n plus 1th position, so that the person can be same. It's a very important thing. If two APs are having some common terms, then the common terms also forms an AP with the common difference as LCM of the two given APs. This is a very important concept. JEE has asked questions based on this as well. Talking about GP, if these few terms are given to me in a GP, then if I multiply each and every term with K, then they also forms a GP with the same common ratio. If I divide each and every term by a same constant number K, then also they forms a GP with the same common ratio. If I take reciprocal of each and every term of a GP, then also it will remain a GP only, but this time the common ratio is going to be the reciprocal as well. Okay, if I take A1, A2, A3, B1, B2, B3 in GP, and if I multiply corresponding terms, then they will also remain in GP. If I divide the corresponding terms, then the new thing A1 upon B1, A2 upon B2 is also going to be in a GP only. In a finite GP, the product of terms equidistant from the beginning and the end is always same. That means what? First term times last term is equal to second term times second last term is equal to third term times third last term, and so on. If the number of terms of a given AP are chosen at regular intervals, then the new sequence as so formed also forms a GP only. Let's say I take A1, A4, A7, A10, A13 and these terms of a GP, then these will also form a GP only. This is what this statement is saying. Okay. Okay, if A1, A2, A3, these are forming a GP, then their logarithms, that is log A1, log A2, log A3, they will be forming nothing but an AP. You must remember this. The sum of first 20 terms of this kind of a thing. Whenever such kind of a question is in which same number is getting repeated again and again and again, you need to take that one common. So what you get is nothing but something like this. Till 20 terms is what the question asking from me. I said okay. What you do, the next step is you multiply and divide by 9. So you keep this denominator wala 9 over here only, and you take this 9 inside. So what you're gonna have is nothing but something like this, and so on till 20 terms. Okay, what you do is you write down this particular thing as 1 minus 0.1. Okay, you write down this particular thing as 1 minus 0.1. Okay, you write down this particular thing as 1 minus 0.001, and so on. The things are going to happen. 20 terms are there, so you can say that 20 is going to come 1 plus 1 plus 1 20 times, that is 20 minus. Over here if you see these terms, 0.1 plus 0.01 plus 0.001 and so on, these are 20 terms in GP. So I hope you know how to find out summation of 20 terms in a GP. That is nothing but first term times 1 minus common ratio to the power number of terms divided by 1 minus common ratio. Just apply it. This problem was asked in JEE 2013 and it is a standard procedure. If you want to take 3 terms in an AP, you have to take them like this: A minus D, A and A plus D. The common difference of the terms involved over here is nothing but D. If you want to take 4 terms in an AP, then you have to take them like this: A minus 3D, A minus D, A plus D and A plus 3D. Their common difference is 2D this time, look closely. If you need to take 5 terms in an AP, you have to take them like this: A minus 2D, A minus D, A plus D and A plus 2D. Their common difference is nothing but equal to D. If you have to take 3 terms in a GP, you have to take them like this: A by R, A R, the common ratio is R. If you have to take 4 terms in a GP, you have to take A by R cube, A by R, AR cube. R square is the common ratio, by the way. If you have to take 5 terms, then 5 terms in the GP will be taken like this. Okay, harmonic progression. If A1, A2, A3 are in harmonic progression, then their reciprocals will be nothing but in a GP. Sorry, their reciprocals will be nothing but in an AP. Over here, if it is asked 1 by 2, 1 by 6, 1 by 10, is this an harmonic progression? So we can look at their reciprocals. So 2, 6, 10. Are these numbers in AP? Yes. That's why 1 by 2, 1 by 6, 1 by 10 is nothing but in a HP. So if 1 by A, 1 by B, 1 by C are in AP, then we can say that A, B, C are in HP. Okay. Yep. We don't know the summation of n terms of HP yet. The formula hasn't been derived yet. Okay. If 3 terms are in AP given to me, then the middle term is nothing but the arithmetic mean of the other 2. So if A, B, C are in AP, then we know that B can be written as A plus C by 2. So that is nothing but arithmetic mean of A and C only, right? Then the arithmetic mean of, let's say if A1, A2, A3, these are few numbers given to me and I need to find out its arithmetic mean, then what I need to do is I need to add all the numbers divided by total number of numbers. This is going to be nothing but arithmetic mean of those numbers. N arithmetic means inserted between, look, if let's say it is given to me that A is a number, B is a number, and I have inserted n arithmetic means between them. So this is first arithmetic mean, this is second arithmetic mean, this is third arithmetic mean, and so on. This is nth arithmetic mean. N arithmetic means are inserted. So how many numbers I am having with me now? 1, 2 and these are n numbers. So total n plus 2 numbers. These n plus 2 numbers now will form an AP. Now forms what? Now forms an AP. Forms an AP. Yes, these will be forming an AP. Okay. So this is second term of the AP. This is third term of the AP. Okay, this is fourth term of the AP, and so on things will happen. So this is n plus 1th term of the AP, and this will be what? This will be n plus 2th term of the AP, right? Okay, moving ahead, beta. Geometric progression. If 3 terms are taken in geometric progression, then A, B, C are in JP. We can say that B square will be equal to AC, or we can also say that B is equal to nothing but AC to the power half. That's it. If A1, A2, A3, An, these are the non-zero positive terms given to me in a GP, then the geometric means is nothing but their product raised to the power 1 by n. Okay. N geometric means the same story. A and B, if n geometric means are inserted, then these are n plus 2 numbers in a GP. These n plus 2 numbers terms are in GP. That's it. Okay. Alright. Harmonic mean. The harmonic mean of the two numbers A and B can be written like this, or in another word it can be written like this: number of numbers divided by the sum of their reciprocals. So if there are n numbers, then they will be written like n upon 1 by A1 plus 1 by A2 plus 1 by A3 and so on. Okay. Similarly over here as well, if n harmonic means are inserted between the two numbers, then n plus 2 numbers form a HP. Okay, same thing. Okay, relation between AM, GM and HM. AM is always greater than equal to GM is always greater than equal to HM. If let's say two numbers are there, then their arithmetic mean will be written as A plus B to the whole power, A plus B by 2. Geometric mean will be root AB, and their harmonic mean will be like this. This equality holds whenever the terms involved are all equal. That is, A will be equal to B. Whenever A is equal to B, then only these equalities will hold. Otherwise, inequalities will be there. always geometric mean ka square is equal to arithmetic mean into harmonic mean. So if two things are given to us, the third thing can be found out by this equation quite comfortably. Always do remember. When we need to use AMGM, whenever minimum value of the expression is asked, terms involved in the expression are all positive, and if product of the terms is coming good. Good means something which helps us to solve our problem. Okay. Yes, arithmetic geometric progression, if we take an AP, if we take a GP, if we multiply corresponding term of an AP with corresponding term of GP, we do get nothing but an AGP. If we multiply first term of an AP with first term of the GP, second term of the AP with second term of the GP, third term of the AP with third term of the GP, and so on, what do we get is nothing but an AGP. If we need to find out the summation of n terms of the GP, first we write down this equation and we multiply this equation with the common ratio of the GP. We multiply this equation with the common ratio of the GP and subtract the two equations to get the summation of arithmetic geometric progression. Okay. Yep, these three formulas. Okay. Properties of sigma ak, where k is going from 1 to n, is nothing but a1 plus a2 plus a3 till an. Sigma can be splitted about plus and minus sign. So about this plus and minus sign, sigma can be splitted. If there is a constant, this constant can be taken outside of the sigma directly. And over here, if you see, k is nowhere a variable involved. So if you put k equal to 1, the value will be c. If you put k is equal to 2, value will be c. K equal to 3, value will be c. And sigma means addition. So ultimately you will be adding c plus c plus c plus c n times. So the value is going to be n into c. By the way, multiplication, sigma cannot be splitted. So these two things are not equal. Also, in division also, the things cannot be splitted. Sigma can only be splitted whenever plus and minus is written between the two numbers. Alright, so these are the three important results that you need to remember, kids. Sigma 1 plus 2, sigma k, that is n into n plus 1 by 2, sigma k square, that is n into n plus 1 into 2 n plus 1 by 6, and sigma k cube, that is equal to n into n plus 1 by 2 ka whole square. Understood, everyone? Yes, any confusion of whatsoever kind, do let me know. Right, I have clubbed all these things at a single place for you people. Right? Yep, understood? Understood, everyone, or not? Yes? Okay. Moving ahead. Okay, talking about binomial, the important things that you have to focus on is this property 0 factorial is nothing but equal to 1. Okay, n factorial is nothing but 1 into 2 into 3 into 4 into 5 into 6 into 7 into and so on till n. Yes or no? That means 1 into 2 into 3 is nothing but 3 factorial. 1 into 2 into 3 into 4 into 5, that is nothing but equal to 5 factorial. So from here you can say that n factorial is nothing but equal to n minus 1 factorial, that is product of these natural numbers, that is n minus 1 factorial times n. Yes or no? So that is what written over there. I hope you guys are clear with this property. NCR is nothing but n factorial, r factorial, and n and r's differences ka factorial. Okay, NCR is always equal to NC n minus r. You must always remember. NCR is known as nothing but binomial coefficient. We do call NCR as binomial coefficient. All right. The expansion a plus b to the whole power n can be written as this: NC0, a to the power n, b to the power 0. You need to observe few things over here: NC0, NC1, NC2 till NCn. How many terms are these written? N plus 1 terms. Number 1. Number 2, in each and every term, if you see, the power of b is starting from the power of c is same as the subscript of c. The power of b is always same as the subscript of c. Yes or no? And the summation of the powers of a and n is always equal to n. The summation of the powers of a and b is always equal to n. Yes or no? Yes. General term. If I want to write down the general term, then number 1, the general term is written as tr plus 1, and that is equal to ncr a to the power n minus r into b to the power r. Right? As I told you, the power of b will always be same as the subscript of c. So if I am writing down the r plus 1th term, in the first term below c, 0 is coming in the second term, 1 is coming in the third term, 2 is coming. So in the r plus 1th term, r will come at the subscript of c, the very same thing will come in the power of b, and the summation of the powers of a and b is going to be nothing but n. So do remember that formula. Okay, I need to tell you a very important thing over here. If I would have asked you what is the expansion of a minus b to the whole power n, then whenever the power of b is odd, minus would have come. Whenever the power of b is odd, minus would have come. Yes or no, people? Do let me know. Whenever the power of b is odd, minus would have come. Yes, so if you add these two, if you add a plus b to the whole power n and a minus b to the whole power n, don't you think that whenever even power is there, the terms will remain 2 times of, whenever even power of b is there will remain, and if you subtract this with this, 2 times of odd powers of b will remain? Yes or no? How many of you guys can feel this? It's a very, very, very important observation. Whenever minus is coming over here, so whenever this term is having even power, that will be coming with a plus sign, but whenever this term is having odd power, this will come with a minus sign. Odd power, it will come with a minus sign. Yes or no, people? So if you add these two, then odd powers of b will be gone and even powers will come 2 times of all the terms having even power of b will come. If you subtract this minus this, if you do, then 2 times of all the terms having odd powers of b will come. Yes or no? So it's a perfect question that I would like to give you, that over here, look, x square plus under root x ki power 6 minus 1 to the whole power 5 plus x square minus under root x ki power 6 minus 1 to the whole power 5. Look, if you do not open this question directly and think a bit, the moment that the thing that I've just told you, that if a is equal to x square and b is equal to under root x to the power 6 minus 1, okay, if you do this, then the problem is nothing but a plus b to the whole power 5 plus a minus b to the whole power 5. Over here, everywhere plus will come, but over here, whenever the power of b is odd, minus will come. Yes or no? If you add these two, then ultimately you're going to left out with this particular thing, that whenever the power of b is even, those terms will remain. So these kind of terms will remain. Yes or no? How many of you guys are clear with this? These terms will return. Now if you put the value of a and b, don't you think that you will have to write down less in the examination and you can solve more number of questions in that case? Yes, definitely. So you can write down your question like this as well. 5c0 is nothing but 1, okay, and a is nothing but x square, so x square to the power 5 will come, and this is nothing but b, so if you do the power 0 of this, obviously it is going to be 1 only. So not writing it. 5c2 is nothing but 10, okay, a cube will be how much? X to the power this, and if you do this, under root x to the power 6 minus 1 ka square will come over here. 5c4 is nothing but 5, okay, and this is x square to the power 1 times under root of x to the power 6 minus 1 ka whole square. Now look how less you need to write down if you can think this much in your mind. So now you can obviously solve this and can get the answer. Yes, people, anyone is having any sort of confusion in this, feel free to reach out to me. Yes, easier? Okay, you can do the remaining thing now. Middle term, look, if n is odd, then the total number of terms will be n plus 1, so this will be even. If total number of terms are even, then 2 middle terms will come. How many middle terms? 2 middle terms will come. Let's say, feel it like this. If there are 12 people standing in a row, then there has to be 2 middle people. Yes or no? Which one? 6 and 7. Yes or no? Can you find it out? How to find out the middle terms? It's quite easy. You don't need to write down formula. You don't need to remember formula for each and everything. You just have to find out middle terms by eliminating one from this side, 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 and it will be done. Okay. If n is even, then number of terms, that is n plus 1, is going to be odd. Let's say n is equal to 8. Then in that case, number of terms will be 9. Which term is going to be the middle one? I think fifth one. Yes. So how can you find it out? Single middle term. This is quite easy. You don't need to remember the formulas for each and every term, for each and everything. Otherwise you will get a bit confused. Okay. Term independent of x. First you can write down general term. And in that general term, make overall power of x equal to 0. Calculate r from that. By the way, r can only be a whole number. Either it will be 0, 1, 2, 3, 4, 5, 6 and so on till less than or equal to n. It cannot be any other value than that. Greatest binomial coefficient. Greatest binomial coefficient is, look, NC0, NC1, NC2, NC3, NC4. In these binomial coefficients, whichever is middle will be the greatest binomial coefficient. Okay. If let's say I ask about 9C0, 9C1, 9C2, 9C3, 9C4, 9C5, 9C6, 9C7, 9C8, 9C9. If you talk about this bete, then let me tell you which are the middle terms. The middle terms are nothing but these two, if I'm not wrong. Yes, these two. Yep. So these are the greatest binomial coefficient. The middle binomial coefficients are the greatest binomial coefficients. Okay. Yep. You also remember this property, NCR plus NCR minus 1 is equal to N plus 1 CR minus 1. If I ask you what is 7C3 plus 7C4, then you must tell me that it is nothing but 8C4. A very important property. NC0 plus NC1 plus NC2 plus NC3 till NCn is equals to 2 to the power n. NC0 plus, look, NC0 subscript is even. The summation of those terms will be equal to subscript is odd. And that will be how much? 2 to the power n minus 1. Okay. Yes. Also remember this, that if n is changing, r is same. N is changing, r is same. Look. There is everywhere subscript mein r is there, but n is changing. So this summation you must remember, okay? Yes, direct formula based questions will come from here. Multinomial theorem. Multinomial theorem, let's say x1 plus x2 plus x3 till xr to the whole power n is given. The number of the terms will be what? Beggar's formula. N plus r minus 1, cr minus 1. R means number of candidates available over here. N is the power. So beggar's formula n plus r minus 1, cr minus 1. Okay? Yep. I hope you remember that x plus y to the whole power n, in binomial theorem we have seen that this will be nothing but equal to NCR, that is n factorial, x to the power r into y to the power n minus r. Okay, now observe one thing over here. Whatever is written over here, its factorial is written over here. Whatever is written over here, its factorial is written over here. Yes or no? And the summation of these powers is also written over here. Yes or no? Now listen to me very carefully. If I talk about binomial, multinomial, then in multinomial also same thing will happen. Over here, sigma n factorial will come, then x1 will be having some power, let's say k1. x2 will be having some power, let's say k2, x3 will be having some power, let's say k3, and so on till xn. So their factorial has to come over here, k1 factorial, k2 factorial, k3 factorial, and so on. And what should be the sum of k1, k2, k3, and so on? It has to be equal to n only, k1, k2, k3, and so on. The summation has to be equal to what? It has to be equal to n only, because their summation was equal to n. So you have to observe these things over here. Number of terms ka formula over here was n plus r minus 1, cr minus 1. That is a very, very, very important formula. Binomial theorem for any index, whenever n is a fraction or a negative value, then also binomial theorem can be applied. You must remember this formula, 1 plus x to the whole power n. Do remember over here 1 has to be there. Then only you can apply this formula, and over here mod x should be less than 1. Then only this formula can be applied. Alright, permutations and combinations. Combinations means selections. Combinations means selections or choosing. Order does not matter in a selection. Okay, which one we have taken first, which one we are taking later, it does not matter. If we want to select r objects out of n distinct objects are there, and we want to select r objects, the number of the ways in which it can be done is NCR. Again, I am telling you, distinct objects are there. If n distinct objects are there and it is not given to you how many objects you have to select, it is only given to you total number of ways of select. Total number of ways of selection of objects means if you select 0 object, that is also fine. If you select one object, that is also fine. If you select two objects, that is also fine. If you select three objects, that is also fine, and so on. If you select all the objects, that is also fine. Then the summation of all these things is nothing but equal to 2 to the power n only. So over here, look very closely. Total number of ways of selection out of n distinct objects. Whenever distinct objects are there, then only we use NCR. Otherwise, we don't use NCR in order to select things. Okay, so total number of ways of selection out of n distinct objects is nothing but 2 to the power n, right? I hope you guys are clear with this. Okay, total number of ways of selection such that one or more objects are selected. One or more objects are selected means NC1 plus NC2 plus NC3 and so on till NCn. So this has to be equal to 2 to the power n minus NC0, because 0 object cannot be selected. By the way, NC0 is nothing but equal to 1, because the question is, because the statement is saying one or more objects I want to select. The statement is saying one or more objects I want to select. If you want to select R objects out of n identical objects, look, I told you if the objects are distinct, then only in order to select you use NCR. If the objects are identical, then the number of the ways of selection is only 1. Okay, total number of ways of selection. This time again I am also not saying you how many objects you need to select. So over here n plus 1 is there. If I select 0 object, that is also fine. If I select 1 object, that is also fine. If I select 2 object, that is also fine. So 1 way for everything. That's why n plus 1 is the answer. If I want to select one or more objects out of n identical objects, then it will be n, because you cannot select 0 object this time. That's why. Okay. Yes, but I am telling you identical. Number of the ways of selection of R object out of n distinct objects where P particular objects always included. Let's say I want to form a playing 11 and I need to have Jadeja, Rohit and Virat already there in the team. So there is one way of taking these 3 people. Now out of the 12 members available, because on a tour 15 member squad goes, right? Out of these 15, 3 players have already been taken, and out of the remaining now remaining 12, how many players do I need to select for my playing 11? 3 players have already been selected, so 8 players more I need out of the 12 players available. So ultimately I can do like this. So that is what the formula is saying me, n minus p cr minus p, if p particular objects are to be included always. There will be 1 into 1 into 1 into 1 p times, then n minus p will be left out of which r minus p are still needed to be selected. Okay, number of the ways of selection of R objects out of n distinct objects when P particular objects never included. So from the choice itself we need to remove them. So we are left out with n minus P choices only, and ultimately we have to select R people only. So let's say Virat and Gautam Gambhir fought with each other and the coach is angry with them. So these coach told them, we don't want these 2 players, make them sit on the bench. So out of the 15 people, 2 people are gone and we have to select our playing 11. So this many ways we can select our playing 11 if Virat and Gambhir are not to be included in the playing 11. Selection of R objects out of n objects. Few are alike of one kind, few of another kind requires case formation. Look, like if I give you how many, look, few letters are of one kind, few letters of another kind, and something like this is there. Not all are distinct, not all are identical. And if I say that select 2 letters out of the available, select 2 letters, select in how many ways? In how many ways selection of 2 letters can be done? 2 letters can be done from the word banana, So here what do we need? We need case formation, all distinct, both identical, like this. So number 1 case, both distinct. So distinct are how much? B and A. So 3C2, only 3 possibilities, B and A. Out of these 3, take any 2. Number 2, both identical can be NN and AA. So 2 pairs are there. Out of those 2 pairs, take any one, either NN or AA. So we have already done the bundling over here. right? So over here 3 will come, over here 2 will come, so ultimately there are 5 ways of selection. So case formation was required. Moving ahead, permutation. Permutation means arrangement, and in arrangement order does matter. Number of the ways of arrangement of R distinct objects out of n distinct objects. Arrangement of R objects out of n distinct is NPR. Look, whenever distinct thing is there, NPR and NCR will be used. NPR will be used in permutations, that is arrangements, and NCR will be used in combinations, that is selections. Number of arrangement of n distinct objects at a n places. So it will be equal to npn, that is equal to n factorial. The same thing can also be done by multiplication method as well. Multiplication rule as well. Okay. Yep. Number of the ways of arranging n objects out of which A are alike, B are alike of another kind, and rest are distinct is what? Look, if it is given to me that there is a these are the letters available and I have to form 7-letter word. If we need to use all letters of the word, all letters available, and form words, so over here how many words can be formed? 7 factorial divided by 2 R's are identical, that's why 2 factorial should divide. 2 A's are identical, that's why 2 factorial should divide. This is what going to be our answer, kids. If we need to use all the letters available and form words, then the number of the words which can be formed will be this. If all the letters would have been distinct, the answer would have been 7 factorial. But if I don't need to use all the letters, then the answer will not be this. If let's say the question tells me that form 4-letter word by using the letters of the word arrange, then first I need to select 4 letters, and in order to select 4 letters I need to do case formation. So case formation I'll do, and then I'll do the arrangement, just like the assassination problem, examination problem you might have seen. Okay, yes, here is the problem. Case formation is required. Selection through case formation is required, and then arrangement is to be done if few things are to be taken from the available. Like over here, assassination wala problem. So 4-letter word is to be formed. Okay, how many A's are coming over here? 3 A's are coming. How many S are coming? 4. How many I are coming? 2. How many N are coming? 2. How many T is coming? 1. Okay, 3, 3, 6, 3, 9, 3, 12, 13. Okay, 7, 9, 11, 12 and 13. Okay. Okay, so we need to form only 4-letter words. If we need to form 13-letter words, then we will do 13 factorial by 3 factorial by 4 factorial by 2 factorial by 2 factorial, and we will get the answer, right? But over here it is saying me 4-letter word only. So in that case, I will first select 4 letters. So for that I will do case formation. All 4 letters distinct. All 4 letters distinct. Number 2, 2 identical, 2 distinct. Number 3 I'll do is 2 distinct, 2 identical of one kind, 2 identical of another kind. Just say SSII, something like that. Okay. Number 4 is 3 identical, 1 distinct. Number 5 is all identical. So these are the only cases which will be formed. Okay, you will have to think over here how to form the cases. This is a very important thing. Okay, how many distinct varieties numbers are present? 1, 2, 3, 4, 5, 6, 6. So out of these 6, take any 4. Because distinct 1, 2, 3, 4, 5, 6. 6 distinct number, take any 4. All the 4 letters are distinct, that is done. Okay. 2 identical means who can provide you the bundles? So there is a bundle of AA which can be provided. There is a bundle of SS can also be provided. There is a bundle of II and there is a bundle of NN can also be provided. Okay. So 2 identical. 2 identical means we can take any of these bundles. So 4 bundles are there. Out of these 4, take any one. Okay. Let's say we have taken A. If we have taken A, then 1, 2, 3, 4, 5. 5 things are there, out of which we have to select 2 distinct things. So that's what we have done. Okay, over here if you do, then here you need to take 2 identical of one kind and 2 identical of another kind, means out of those 4 bundles, take any 2 bundles. Okay, 3 identical and 1 distinct means we need to form bundling of 3. So bundling of 3 can only be provided by AAASSS. AAASSS, because II is only 2 only, NN is only 2 only, and T and O are only 1 only. Okay, so 3 identical means out of these 2 bundles we can take any one. Okay, let's say we have taken A, then 1, 2, 3, 4, 5. Out of these 5 choices we have to take any one, so that one distinct number can be chosen. Okay, all identical, for all identical we do have only one choice, SSSS. So 1C1. Okay. Okay, this is how we have selected. Now we have to arrange. So 4 distinct things are there, we can arrange them in 4 factorial ways. Over here if you see AA and SI, these are distinct and these are identical. These are 2 identical and 2 distinct. So 4 factorial divided by 2 factorial will come out to be the arrangement, because 4 things we have selected 4 things and we have to arrange them, out of which 2 are identical. Here 4 factorial by 2 factorial, 2 factorial. Why this? Because 2 identical of one kind, 2 identical of one kind, that's why we have divided it by this. Okay, over here 4 factorial by 3 factorial, because 3 identical of one kind is there, and over here 4 factorial divided by 4 factorial. Just add all these, what you get is nothing but the total 4 letter words getting formed only. Clear? Gap method. Particular objects never together. It is given to me that particular objects never come together. Then we need to arrange them in gaps only. So for that we need to create gaps. So if it is given to me, understand it with an example. Let's say it is given to me that 4 girls are there and 5 boys are there. It is given to me in the problem that no 2 girls sit together. No 2 girls sit together. No 2 girls sit together. If this is the question given to me, then boys have no issue. So let's say 5 places we need in order to get these 5 boys seated. So 5 factorial is the number of the ways in which these 5 boys can be arranged. Around these 5 boys, if you see 1, 2, 3, 4, 5 and 6, there are 6 places. Out of these 6 places, if I choose any 4 for the 4 girls available and make them and arrange them, this is the total number of the ways of arrangement, such that no 2 girls sit together. Understood? Okay, whereas block method is the one in which it is given to me that all girls sit together. All girls sit together. If this is the case, then 5 boys and girls will be considered as one unit. So ultimately 6 things are there, and inside the girls can arrange among themselves. So girls can arrange among themselves. That means 4 girls are there, they can interchange among themselves. So total 6 factorial will come. Okay. Yep. Okay, this is the formula for derangement. Must remember, let's say I have been given 4 letters and I want all those 4 letters to go at the wrong places. All the 4 letters to go at the wrong places, then that is nothing but derangement. So over here we just need to put n is equal to 4, and in how many ways this work of sending all the 4 letters to the wrong places can be found out. Note, not even a single letter will go to the correct address. Okay. Distribution of alike identical objects, like Pani Puri Wala. Pani Puri Wala does the distribution of alike objects only. So what do? We hold some bowl in front of him like a bagger. So distribution of alike or identical objects, whenever it is there, we use beggar's method. That is the beggar's formula, n plus r minus 1 cr minus 1. Okay, do remember this. This method is also is used in finding non-negative integral solutions of the equations. Like, let's say x plus y plus z is equal to 8, and I need to find out how many solutions are possible so that x, y and z are non-negative integers. X, y and z are greater than or equal to 0 and integers only. Okay, so what do is 3 members are there, 8 plus 3 minus 1, C3 minus 1. These are the total number of solutions possible. Okay, you must remember this particular thing. There are 8 identical things which are needed to be distributed among 3 persons. One people have got X number of things, another person have got Y number of things, another person have got Z number of things. Okay, so this can be done in how many ways? As I just told you. Distribution of distinct objects. Look, identical objects ka distribution follows Beggar's method, whereas distinct objects ka, the thing is m to the power n. The thing which we want to distribute can go to how many choices? Let's say I am having 3 distinct chocolates such that any guy can get any number of objects. Here also any guy can get any number of pani puris. That means any guy can get any number of objects over here as well. Okay, do remember this thing. Okay, 3 distinct chocolates are there and there are 4 people, such that I want to distribute it so that any guy can get any number of objects. Okay, yes, either it can happen that one guy is getting all the three chocolates, either one guy is getting 2, another guy is getting 2, and other 2 guys are not getting anything like this. Okay, so how many such distributions are possible? So we will first pick up the thing which we are distributing. So first we will pick up a chocolate. So first chocolate can go to how many people? 4 people. Second chocolate can go to how many people? 4 people. Third chocolate can go to how many people? 4 people. So what is the answer of ways of distribution? 4 to the power 3. You understood it? Whichever thing we are distributing it, we will first pick that up. Okay? Yep. Moving ahead, kids. Equal and unequal division of distinct objects into groups. It is same as that arrange wala problem. Same as arrange wala problem. Okay, yeah, all right. Circular arrangements, number of the ways of arranging n distinct objects is n minus 1 factorial in a circle. In a row it is n factorial. Number of the ways of arranging n distinct objects where anti-clockwise and clockwise are same, like in the problems of necklace, garland, etc. It is nothing but n minus 1 factorial divided by 2, because anti-clockwise and clockwise are considered same. That's why everything has been counted twice, so we need to divide by 2. Okay, number of the lines that can be drawn using n points such that no 3 are collinear is nc2, because in order to draw a line we need 2 points. So if no 3 points are collinear, that means if out of those n points, if we take any 2 points, a line can be drawn. This problem is same as number of handshakes, because in handshakes also we need 2 hands. Okay, number of triangles that can be drawn using n points such that no 3 are collinear is nc3, because in order to draw a triangle in which no 3 points are collinear, we need 3 points, so nc3. Number of the diagonals that can be drawn in an n-sided polygon is nc2 minus n. nc2 is number of the lines and n is nothing but number of the sides. That's why nc2 minus n is nothing but number of the diagonals, because a line can either be a diagonal or a side. Number of divisors of a natural number, this particular thing, let's say a natural number is given to me, can I factorize it where a, b and c are prime numbers? Yes sir. The number of the divisors of that number will be nothing but the power of this plus 1, the power of this plus 1, the power of this plus 1. Let's say I want to find out the number of factors of 72. So first we do what? We do this. Okay, so 72 can be written as 3 to the power 3 into 3 to the power 2. So number of divisors of 72 will be how much? 3 plus 1 into 2 plus 1. We are taking the powers, adding 1 to it and multiplying it. So how much? 4 3s are 12. 12 factors are there. Okay, if I have been asked the sum of the divisors, how do we find out the sum of the divisors? What do we do is, this is a to the power 0, a to the power 1, a to the power 2 and so on, a to the power p. It is like this. Okay, so 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 times 3 to the power 0 plus 3 to the power 1 plus 3 to the power 2 and so on is there. Okay, so you can just calculate it, and sum of divisors you can get quite comfortably. Okay, exponent of a prime factorial in this, let's say I have been given in 100 factorial, what is the power of prime number 2? So what do? We first take 100 by 2 greatest integer function, 100 by 2 की power 2 greatest integer function, 100 by 2 की power 3 greatest integer function, 100 by 2 की power 4 greatest integer function, 100 by 2 की power 5 greatest integer function, 100 by 2 की power 6 greatest integer function, 100 by 2 की power 7 greatest integer function, and let me tell you, from here the things will come out to be 0 and will always be 0 0 0 0 0 only. So what will be the, because you know what 100 factorial can be written as 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into and so on. So look, 2 is coming from here, 2 2s are coming from here, 1 2 is coming from here, like this. If you do, what is the power of 2 coming in 100 is the question. So that's why we're going to follow this particular method. This is greatest integer function, by the way. So this is 50. This will be how much? 25. This will be how much? 12. Okay. This will be how much? Okay, this will be how much? This will be how much? And then 0. So this much power of 2 will come, right? Okay, try this problem as homework. It's a very, 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 very good problem, kids. Okay. Rank problems also. Find out the rank of Sujata. This is the question you guys will do as homework. Sujata. This is Sujata, homework. Find the rank of the word Sujata. Okay? Yep. All right. Okay. Okay, so we're gonna end this session here only, because even though we have a lot to cover, but I think a lot of guys are already tired. So we will keep the session till here only. We will do different parts as well, because as I can see, the kids are tired in the chat box, right? So we're gonna end the session here only. We're gonna do the remaining portion in the next class. I'll arrange it for you so that you can follow this up as well. And whatever I have covered, do try whatever I have covered. Please read it completely from PDF, because I have covered almost all the things of the chapters that I have covered so far. So no point will be missed, and in examination definitely you will be able to score more marks. All right, I'll keep the session here only. Keep learning, keep shining, keep rocking, keep enjoying. Let's make most out of this. Thank you so much.